So I have to thank our sponsors. You know, without them, this would not be possible at all. So thank you to all of them. At our malt level, I love the name of our sponsorship levels, I've got to say. But at our malt level, we have Lloyds and Control Plane. So we appreciate you and thank you very much. And the same for Solo, Loft, and Teleport, who came in at our grain level. All of those sponsors that I've just mentioned do have tables upstairs. I encourage you to go speak to them. And they all have awesome products. They all have great teams. You'll learn a lot through those conversations. So, you know, go talk to them. We also have a whole bunch of blend sponsors that also helped make this happen. So thank you to all of the companies here. These little items from most of them or all of them in the bags. So enjoy the stickers and swag. Now, thank you all for buying tickets. You know, we got really lucky with this conference that when I listed the first set of tickets, we sold them in a few weeks. And I think that just shows that we have a really good tech community in Scotland and abroad. We have people from Europe and even the US. So again, I appreciate everyone for coming here. And now the schedule and code of conduct. You all have a flyer inside of your bag. It has some QR codes on it. I would encourage you to just read the code of conduct, make sure you understand what's expected of you. We just want everyone to be polite and courteous to everyone around them. The schedule, it's all on the website, but there is also a QR code that will take you to a sessionized PWA that you can add to your phone. It's really good. It will show you what is coming up next. So just add that, scan it, and away you go. We also have some workshops available in that glass room just down there all of today. So I would encourage you all to take a look at those workshops. There are workshops on working with Knative, eBPF, and Service Mesh. So all of the sessions are live streamed and recorded, so you're not going to miss anything. So if any of those topics on the workshops do take your fancy, just pop down to the room at the start time and we'll get you registered. And also, we have Eddie and Sarah at the conference joining us. They're going to be taking loads of pictures and videos, and they encourage you to go and speak to them and talk to them. So if you want to record a small sound bite or anything, please go speak to them. If you are worried and do not want your photo taken for any reason, we do have some red lanyards available. Just come and speak to someone in a blue friendly face t-shirt or Eddie and Sarah at the back here. Open UK are giving away a dinner for a 5-course meal with wine and drinks. All they want you to do is tweet Open UK and KubeHuddle. So at some point today, tweet your photos, whatever you're thinking about the talks, include those, and you stand a chance to win. And also, we have another really great Kubernetes conference in the UK. KCD UK is coming up in November, so go check out their website for schedule and ticket information. And if you want to win tickets, we will be giving them away, so keep tweeting, and more rules when how we're going to do it will be available. To be honest, I'm still making it up, but we will be giving away tickets for next year, so I'll keep you all informed. Enjoy the conference. Both tracks are hosted by the primary sponsors. So we have Craig in this room from Lloyds, who's going to take over from here, and we have Ian from Control Plane in the other room when that room starts. So I wish you all a great conference, and thank you for coming.
Morning. So I'm Craig. I'm your host for today's room. There's still some seats at the front if people are standing and not wanting to stand for the next hour or so. Don't be shy. So we're going to start off with Leanne from Loft, who's going to give us a quick 10-minute chat, and then we're going to hand over to Liz after that. So over to Leanne. Thank you.
All right, let's see if this worked a couple of minutes ago. Oh, no. All right. Don't do this to me now. Okay, so good morning, everyone. I'm really, really glad that I can be here and also give, I guess, the first talk of the day. My name is Lian. I'm a DevRel for Loft Labs and also the Chief Karaoke Officer of the world. And today I'm supposed to talk to you about multi-tenancy on Kubernetes. This looks great. Okay, so when we talk about multi-tenancy, what we usually mean is a situation in which multiple tenants, so that could be teams, domains, or even individual people, share an underlying platform, structure, architecture, or software. So if you imagine, for example, an organization where all developers share one development cluster, that would be a multi-tenancy situation. So if we just assume we have a bunch of teams who are all at different stages at the Kubernetes journey, they might have different requirements regarding storage or compute, so you won't be able to have like a one-size-fits-all solution. Plus, you also need to make sure that the individual tenants' workloads are somewhat isolated from each other. And so that kind of brings us to the question that a lot of platform team members will ask themselves, like, what is the best approach to do that? So basically, it comes down to this kind of question. You could use namespaces. You could give every tenant their own namespace. And that might work well until they want to experiment with stuff that will transcend the scope of a namespace, like when they need to touch RBAC or custom resource definitions. So another alternative would be to give every tenant their own cluster. Well, have fun maintaining that. And if you're on a cloud provider like AWS or something, you will be charged per control plane, so also try to explain that to your CFO. Is there an alternative where we can have kind of a middle ground between a cluster and namespace, something that will behave like a cluster but doesn't cost as much? Yes, of course, that's why I'm here. That's what we're paying for me to speak to you now. So there's this concept called virtual clusters that can live on other Kubernetes clusters. And you can install services on the host cluster that can be shared into the virtual cluster. But you can also install stuff on the virtual cluster that is then isolated from other clusters. So that's very cool. There's one implementation of this, which is called vCluster, and you can check it out on vcluster.com. So I'm done with that part. Still have 7 to 8 minutes. I'm going to go slightly off script today. I had prepared a talk about how we can, take the knowledge that we have from the idea that we have to build a system in which we can't even, have a negative impact on other people's work, instead of just thinking about the intent of what we're doing. So the impact of our action is something that we need to focus on more. And I had a bunch of examples prepared to illustrate how the path to hell is paved with good intentions. But then something happened, and I wanted to talk about that and how well-intended things can have really bad impact. So last week, before I came here, actually, I was at another conference. It was a really big one. There were almost 3,000 people attending. And there was an after party at the conference venue. Of course, there was free booze. There was a live band. I think there must have been 1,000 people there. There was a guy who I spoke to for about, 10 minutes, because he was really boring and drunk, so I just cut the conversation short. And then during the evening event, he came up to me really closely from the side. I could feel his mouth touching my ear. And he grabbed me by the waist and said to me, "I love you, I love your body, I want every part of your body." This is a guy I met that day, and I talked to him for 10 minutes. And I don't even want to dwell on how gross and traumatizing that is. One moment, you're just a person at the conference, you're just, feeling safe and normal. And then the next, you realize that you are actually vulnerable. You have a body that is not male, and that puts a target on you, because some people think that they are entitled to that body, to look at it, to leer at it, and to touch it and tell you what they want to do with it. So I don't want to talk too much about that. Obviously, it was a breach of a violation of the code of conduct, and he was banned from this conference and the future conferences. But I want to talk about how the reaction that I received of really well-meaning people could just have been better. And I think that's something that we can all learn from. So I'm a very community-minded person. I shared the story on Twitter, and the reactions were really interesting. So everyone who replied or DM'd me, they generally wanted to be supportive. They really wanted to, share that pain, I guess. But the impact was just not ideal, I would say. So some people were coming up to me and saying stuff like, "You should have come to me. You should have reported him." And I was like, how did this become now about what I should have done? Right? I understand that the intent was to be supportive, but the impact was just the exact opposite, because I felt not supported, I felt very pressured, I felt lectured about something that happened to me. Another group of people were shocked. Feigning surprise is one of the worst things that you can do. "I cannot believe this happened. Oh, I don't understand why people do that. It's 2022, blah, blah." Yes, it is 2022, and we've gone through multiple cycles of Me Too. If you are still insisting that these things don't happen and you don't know about it and you've never seen it happen, you are just really talking out of your arse, and you can't be trusted, because you cannot honestly say that still. It's just like you need to open your eyes. And again, I understand the intent is to be supportive, but it is not supportive. It is completely dismissive of me and what I experienced. The claim is, oh, this is some outlandish thing that just never happens. Like, I don't see it happen. It adds zero value to the conversation. You could just as easily not say anything. So, when people do these well-intended things that have terrible impact, in my experience, that's because of a couple of different reasons, one or more of these reasons. Some people just don't know any better. Like, they've never been in this situation, they don't know how this feels, and the examples that I just gave you, those were all dudes. You know, they are just, the women that reacted, they were all telling me, like, that really sucks. I feel so bad for you, that's disgusting. You know, it was really just focusing on my experience and giving me support, instead of talking about themselves, like, oh, I cannot believe this, right? The other thing is that most of us are empathetic creatures, and one way that we want to empathize is to relate to the situation ourselves, and we will try to shift that conversation to ourselves and our own experience. We want to put ourselves into that situation, but because we cannot really relate to it, you know, we can just say like, oh, I have never experienced that, fine. And then once you try to relate, and then you realize, oh, this actually feels shitty, I then have the need to emotionally distance myself again. So I don't want to feel terrible, or I want to just announce to the world that I would never do such a terrible thing. That is great. Maybe do that on your own Twitter feed, you know? Like, you can talk about that, but not in a conversation where I'm trying to share. Also, I think that it's just the bare minimum to not do that, so I hardly worth a mention, in my opinion. So again, it might make you feel better, but it adds no value to the conversation, and it's taking away the space and the light from what really matters. So to wrap this up, because it's a bit of a downer, I know. What can you and what can we all do to be better, to make this better, to prevent these things from happening? I think the most important thing to remember is that when someone shares an experience like this, this is not about you, your feelings, or your experiences. When you engage, you should ask yourself, am I providing any value to this conversation? If I want to support someone, is saying, I would never do this, doing anything besides making yourself feel better. I know a lot of people, we want to make others feel better because we want to feel better ourselves. But this might not be the thing that that person that we want to help actually wants. So when in doubt, you should always ask questions rather than doling out unwanted advice or lectures, like I'm doing right now. You should try to shift the focus away from you and back to the person you're trying to help. The most important rule of allyship is to listen more than you say. So instead of saying, you should have come to me, I would have smacked him in the mouth, you should ask, how can I support you? How would you like me to support you in a situation like this? Instead of saying, I don't know any guy who would do this, my friends are like, just never would they ever do that. You can ask, how can I get better at spotting this kind of behavior? How can I step in before the situation escalates? Don't try to find the perfect strategy to change the entire world, focusing on other people's behavior, but take this opportunity to, you know, like Michael Jackson says, take a look at yourself in the mirror, at the man in the mirror, change yourself, and lead by example. And with that, I leave you to enjoy a hopefully wonderful conference. Please be kind and look out for each other. Don't forget to join us for karaoke tonight, and thank you.
Thanks so much for that very powerful testimony. I don't think anyone wants to see that ever again. Okay, so, sorry Liz, you try and get us up. I'll just get a shout. So Liz Rice is Chief Open Source Officer with Ebpf Specialist in Solid, creators of the...
I'm so valent.
She was chair of the CF Technical Oversight Committee in 2019 to 2022 and co-chair of KubeCon Plus. Well, finish here?
That's fine.
Yeah, okay. Thank you.
Thank you. everyone. I just want to say thanks to Leanne. That was a really important thing to talk about. So round of applause for her again. And now we will move on to something completely different. So yeah, I'm going to talk about whether eBPF is going to mean the end of the sidecar model. So I guess, you know, maybe you already know a bit about who I am. So I am Chief Open Source Officer at Isovalent. Important to say that correctly. Isovalent is the company that originally created the Cilium networking project, which I hope maybe a few of you have heard of. Can you put your hand up if you have come across it? Excellent, good. As mentioned, I used to be on the CNCF's Technical Oversight Committee, which gave me a really, like the privilege of seeing quite a lot across what's happening across the cloud native landscape. So that was a really good experience to just step a bit away from day to day and see what's happening across the industry. And now that I'm no longer on the TOC, I had a bit of spare time, which I ended up putting towards Open UK. Open UK is here, I think, later on today, and it's an important body, I think, for encouraging the use of open technologies, not just in the UK, but collaborating internationally as well. I've written a couple of books. The What is Ebpf book I have got a few copies of with me, so if you want one, find me, and I have a few to give away. So I'm going to talk about sidecars and eBPF. So when I talk about sidecars, I'm thinking about how we quite often have common code that we need to incorporate into our different application code, probably our different microservices. And something like, let's say, logging or tracing or security code, if we build it directly into our application, we have to write it or import it from a third party in the language that we wrote the code. So we might need multiple implementations of the same, let's say, logging code in Python and another version in Go. And we have to, every time we want to use a different language, we'd have to rewrite that code and potentially have some inconsistencies in that. When we move to a containerized environment like Kubernetes, we have the option to start running things in containers. And when we put things into pods, we can move that common code into its own container. We can run an instance of that container in each of our application pods. It no longer needs to be in the same language as the application, and we've got consistent tooling in each of those pods. So this is pretty cool. The sidecar model is a good way forward for this kind of infrastructure tooling that we want to be the same in all our applications. Now let's turn to eBPF. So how many people here have come across eBPF? Actually, loads. Excellent. This is great. I've put the acronym Extended Berkeley Packet Filter here. I want you to kind of forget that because it's pretty much meaningless now. You can do so much more with eBPF than filtering packets. It allows you to customize the way the kernel behaves. We can run programs inside the kernel, change the way that the kernel behaves dynamically without having to load a kernel module in a very safe manner, because eBPF programs are verified to ensure they're safe before they run. And we can change the way that the Linux kernel behaves, much like JavaScript allows us to change the way that a static HTML page behaves. So dynamic programmability. So let me show you a little hello world just to make sure everybody's on the same page about this. So let's say hello KubeHuddle. And I'm using a framework here called BCC, which is just very convenient for running little demos like this. This bit here is my eBPF program, and it's just going to write some tracing that says hello KubeHuddle. And I'm going to attach that program to a system call event. The event I'm using is execve down here. And every time any process on this virtual machine calls execve, that's going to trigger my eBPF program. And then I've also got a line here that's going to read the tracing So all this bottom part here is user space code, and just this little bit here is what's running in the kernel. So if I run that one, okay, and hopefully if I start running or doing something that generates that execv system call, yeah, we start seeing some tracing. And we can see things like the command name, the process ID, some other contextual information about what triggered that event. I didn't have to restart this terminal. It was a pre-existing bash process that was immediately instrumented by me running this, this Ebpf, or loading this Ebpf code and attaching it to that event. And if I stop it, you know, there's no difference in the way that I run processes or run new commands in that existing shell or anywhere else. So it doesn't matter which process triggered the event. We get contextual information passed into the Ebpf program. And I could load that dynamically. All I've done changing behavior there was adding some tracing, but we can do all sorts of interesting things beyond just sending messages. Now, I've talked about the kernel and user space, and we should probably just make sure we're all clear about what those distinctions are, because usually, as application developers, we write user space code. But whenever our user space code wants to do anything that touches hardware, whether that's accessing a file, writing something to screen, sending network messages, even allocating memory, all of these things require hardware involvement, and the kernel is the only part of the system that has the privilege to interact with hardware. So our user space applications are using a system call interface to ask the kernel to act on its behalf. Please open a file for me, that kind of thing. Usually that's hidden in some kind of abstraction from whatever programming language we're using. So we don't normally worry too much about these system calls, but they're happening. We're constantly interacting with the kernel. If we're instrumenting the kernel with Ebpf programs, those programs are loaded into the kernel, attached to an event, and that event could be pretty much anything in the kernel. So not just system calls, but any other function call, the arrival of a network packet traversing different parts of the network stack. All these things can be events that trigger Ebpf programs. Now, if we think about a Kubernetes environment, and we've got our application code running in containers in pods, but there is only one kernel per virtual machine, or bare metal machine if we're running on bare metal. So every time our containerized application code does these things that require the kernel's assistance, they're all doing that through the same kernel. So per Kubernetes host, there is one kernel. And that kernel is involved whenever our pods are doing anything. Pretty much anything interesting is going to require the assistance of the kernel. So we can instrument the kernel with Ebpf, and it's aware of everything that's happening on that host. And we don't have to make any changes to the apps. We don't have to change the way they're configured. We immediately get visibility over applications that were already running, so we don't even need to restart our pods. So how does that compare to sidecars? What are the pros and cons of these models? Well, a sidecar is injected into a pod so that it shares the same namespaces as the application containers in that pod, and that's how it gets visibility over what's happening inside that pod. And to get it there, there has to be some YAML. Now, that YAML is usually created through some kind of automated process. Maybe it's an admission controller, maybe it's part of your CI/CD process, but something has to add that YAML over and above what you wrote for your application code. So if something goes wrong with that, or if maybe you've misconfigured the pipeline that adds the YAML, then if somehow that sidecar isn't injected, your pod is not instrumented. So if it was, let's say, security tooling, you might have a pod running that didn't have that security tool injected. If we use Ebpf, we just have to instrument the kernel one time per host rather than one time for every pod. Also, if I manage to compromise your node and I manage to run some kind of malicious process on your node, well, from the kernel's perspective, it's just another process. So it's just as visible to Ebpf tooling as a legitimate activity. So from a security perspective, we're more likely to get visibility over malicious activity using Ebpf tooling. There's also an advantage from a resource usage perspective. If we use the sidecar model, we have to inject those containers into every different pod. And by design, each pod is isolated from each other. So if they wanted to share information like configuration information or state information, well, they'd either have to send network messages to each other. Maybe, they could share a mounted volume or something, but there's no efficient way of sharing information between these different pods. So we tend to have a copy of configuration and state information in every instance. If we're using Ebpf, we can have one set of instrumentation running in the kernel rather than a different instance in every pod, and that also saves us resources from a configuration perspective. We might also have some user space agent. Very typically, we would have some user space code as well. And we can share information using something called Ebpf Maps that are a very efficient way of sharing data between user space and Ebpf programs in the kernel or between different Ebpf programs. I'll show you a little example of an Ebpf Map program. So this is a pretty similar kind of tracing program. I'm actually not using trace. I'm using what's called a perf buffer to send. I'm going to send information about every event through my perf buffer, and here I'm going to print it out directly from user space. But I'm also going to use a hash table. Here's my hash table. And I'm going to allow for a message to be configured for different user IDs. So this U64 is going to be a user ID, and I'm going to have a little message that I can send for a specific user ID. So the default message is going to be hello world, and then I'm going to find the current user ID. So this is the user ID of the process that triggered this program. And I'm going to look up in that hash table called config and see if there is a custom message for that user ID. So I'll send a different message if there is a custom message. And in user space, I'm going to configure so that if it's root, which has the ID of 0, let's say I'm in, actually that'll be too long. I wonder if that's going to be too long. Let's go with, actually I'll just do 0 KubeHuddle. I'll do. Definitely be short enough. Okay, so let's try running this one. Config map, hopefully. Not sure why my autocomplete isn't working, but ah. Screen. Okay, so now if I start triggering, it's still attached to the same execve system call. Now I've got the process ID, the user ID, and if I do sudo ls, we should see two processes, one of which is run by root here, and one of which is not run by root. So I was able to pass some information from user space. Again, all this stuff from here on is the user space code into my kernel program using a map. This hash table is a form of map. And in fact, the perf buffer is sort of a form of map. It's really a perf buffer rather than a map, but it uses a map to tell the kernel which perf buffer to write to, and that's what's writing the trace. I'm going down a rabbit hole. We'll come back to that. Ask me about that. All right, so that was an example of using maps, which are this very efficient way of sharing data between user space and kernel or different eBPF programs in the kernel. Now, I've just shown you some extremely simple examples that just write some text to screen, which is not terribly useful. But there are loads of really great eBPF-based tools out there now. I'm going to start with an observability tool called Pixie. This is part of CNCF. It uses, it allows you to run a whole load of different eBPF observability or tracing tools to trace all sorts of different metrics and then present them to you in nice graphical forms. This is an example of a flame graph showing CPU usage across an entire cluster. So it's aggregating the information from across multiple nodes. Loads of really powerful things that you can view using Pixie. Cilium also has some really great observability tooling based on showing you the networking. So from individual packet flows to showing you a service map of how different Kubernetes services are communicating, and also showing you metrics. So you can get metrics at layer 4 and layer 7, showing you exactly how your network is behaving and helping you diagnose any problems. Again, eBPF based. Cilium is not just about observability, it's about networking and also network security. And at the end of last year, we introduced service mesh capabilities, which are sidecarless. I should probably just say briefly what I mean when I talk about a service mesh. So a service mesh is about connecting applications while abstracting away the underlying network. So we want the connectivity between those applications to be secure. Service meshes typically give you a bunch of observability and give you some additional resilience behavior and the ability to manage traffic between things like different instances of your applications. Now, a whole lot of this already existed in Cilium. The observability already existed. The load balancing that you need to redirect traffic across different instances of an application. The security, certainly in kernel encryption. We don't today have MTLS, but we've got a very interesting mechanism that's being developed at the moment for next generation authenticated secure connectivity. But you can have encrypted connectivity using Cilium already. So we were already very close to what a service mesh provides with native Cilium. I mentioned that it's sidecarless, and typically service meshes have used a proxy to handle the complexities of layer 7. That proxy might be Envoy. Envoy is the proxy that we use in Cilium as well. Linkerd uses its own proxy. But I think until we introduced the idea of sidecarless, all service meshes were injecting the user space proxy as a sidecar into every pod. With the sidecarless approach, what we're doing is having one instance of that layer 7 proxy running in user space, but connected to those pods using eBPF. And that allows us to reduce the resource usage dramatically for all the same reasons that I talked about before, about reducing the multiple instances of every resource in every pod. There's also an advantage in terms of the network latency. So when you have a proxy inside every pod, a packet that's coming, let's say a packet's being sent out of the application, it has to traverse the network stack inside the pod essentially 3 times to get out of the pod. if we're using eBPF, we can sidestep a lot of that network path because we don't have to go through the user space proxy inside the pod. And instead of having this kind of complex path, we can make it much more direct by just going through one proxy if we're communicating between two pods on the same node. And we know from our beta testers who first tried out the Cilium service mesh that there are a lot of people for whom the latency of service mesh and the complexity of injecting sidecars and the kind of consequent issues that people often find when they're injecting sidecars and sort of race conditions when pods are starting up, they were finding that that was too high a price to pay. And there's a whole load of users out there who just were, for one reason or another, not able to adopt Cilium service mesh because of the complexity or the latency. So the idea of removing sidecars from the model was really attractive to those people. And it turns out that we're not alone in thinking that sidecarless is an interesting model. I think 2 or 3 weeks ago now, the Istio community announced their sidecarless service mesh. And I think it's really interesting to see Matt Klein, who is the kind of founder of the Envoy project, talking about sidecars always being an unfortunate implementation detail. He talks about mesh features moving into the underlying infrastructure. And that's essentially what, in the Cilium project, we were asking ourselves. How much of this sidecar functionality can we move from user space into the kernel? And the answer is quite a lot, but not everything. We still need to delegate layer 7 complex processing to user space today. And this idea of using the kernel for efficient processing but delegating some of the complexity to user space is a model that you see elsewhere. This is not the first case of it. Suricata is a very popular security tool that takes packets, or packets are sent to Suricata in user space to make security decisions from NFQ in the kernel. Another example of this idea of delegating complex processing would be if you plug in a piece of hardware and it loads a kernel module, the kernel module will call to a user space helper function to sort of help with the configuration of the kernel module. So we're doing a similar model here by saying, okay, here's a network packet that needs processing in user space, and we pass it to Envoy. Now, we're mostly operating in a one proxy per node model, but with the option to run multiple proxies if you want increased isolation. I think the Istio model is more in that sort of one proxy per namespace model. You might have good reasons for running a proxy per pod. An example of that would be if you've got some custom WASM filters that you're running in your service mesh that you want specifically for one application, you probably don't want those WASM filters interacting with your other applications, and that would be a very good reason to inject the proxy into that one application or those specific applications as a sidecar. But if you just want basic service mesh functionality and you're not doing kind of really in-depth customization, one proxy per node could be a more efficient solution, and maybe the interaction with noisy neighbors might not be an issue for you. And the ability to reduce resources could be a better trade-off in your situation. So I think we will see service meshes offering these different kind of menus of choices around how you deploy your sidecars. But I said, does this mean that eBPF is the end of the sidecar model? And I think we're going to see more and more tooling, like we're seeing observability tooling and security tooling and networking, moving into the kernel. But it's not trivial. Writing eBPF code is kernel programming. So that is quite a high barrier to entry. I think sidecars will continue to be a really great way to innovate and a really great way to allow a broader range of developers to build infrastructure tooling. But I think when it will be driven into the kernel will be for performance reasons. The other reason why you may not find eBPF appropriate is if you're using a managed service where you don't have control over the node. So, for example, if you're running a kind of containers as a service type deployment, you may not have the ability to run eBPF tooling unless it's offered with the cooperation of your service provider. Increasingly, that's the case. Increasingly, we're seeing the major service providers adopting Cilium, for example. So more and more eBPF-based tooling being the default. But as I say, I think the reason why we will see more function being driven into the kernel will be, the driver will be performance. So this is some data from, this isn't open source, this is a proprietary eBPF-based HTTP parsing that we run in the kernel. And you can see that the latency is dramatically faster if we're doing that HTTP parsing in the kernel, which is the red line, nearly as fast as not having any observability at all, or running it through the proxy does add significant latency. This also illustrates why reducing the number of proxies you pass through is really good for performance. So I think it will be this kind of performance driver that increases the pressure to build things into the kernel using eBPF. I love that top right-hand cartoon that Nathan Leclerc did. He actually did that probably 2 or 3 years ago now, and I think it really was very sort of foresightful that, yeah, the sidecar model is perhaps not the best, particularly for infrastructure-based tooling. So with that, I say thank you very much. Check out the Cilium project, check out ebpf.io for more information about eBPF. And as I say, I've got some copies of my little What is eBPF book if you would like to dive in more. Okay.
Just enough for me to set up, huh?
Yeah.
Going to the mic or?
Yeah, it goes through the mic.
So I should stay in place.
I'll give you yeah, the USB-C. I'll give you like a 10-minute warning. I'll just hold up the paper to 10 and 5 so you can time yourself, yeah?
Where are you?
I'm just sitting behind Lloyds.
Okay,
Yeah.
okay.
How long was your talk? I know it's 45 minutes in your schedule, but
How long is it in schedule?
45 minutes?
45, okay.
Just 'cause
45 minutes then.
if you can hit 40, because people turning over, you know.
Yeah,
is that right?
You just tell me when to finish. Can
Right.
give me 10 minutes, doesn't matter how long it is.
Okay.
I'll speed up or slow down.
Okay.
Hey, I missed you yesterday. Yeah. Hey, how you doing? Good. Oh. Huh? Yes. I don't know what the stuff is. I'm just following the crowd. So whatever. Yeah, definitely.
Sorry. Hello. Sorry, I've just been asked to remind everyone there's a workshop going on just down there in the glass room that you walk past on the way down here, which is around the Kubernetes as a service, if you want to go and get some hands-on time with that. I'm just going to hand over to Victor Farrick.
Yeah, Victor.
Victor, yeah, okay. I need to read this in advance. So he's a developer advocate at Upbound, a member of the Google Developer Experts and a Docker Captains Group, a published author as well. His big passions are DevOps, containers, Kubernetes, microservice, continuous integration, delivery and deployment, test-driven development. He often speaks at community gatherings and conferences. He's also published a DevOps Toolkit series, as well as courses in Udemy. I'll let you pass on your URL. Thank you very much, Victor.
Okay. Thank you. Okay, I'll be talking about GitOps and how we can, why aren't we doing GitOps for everything, assuming that you are doing GitOps in the first place. So let me pass through this introduction because you already heard who I am and all this stuff. Okay, so let's talk about GitOps, right? Where are we? So, who is applying GitOps, Argo CD? Only 1/3. Was the rest? Be ashamed. Anyway, it's very easy to explain. In a nutshell, the idea is that we have a desired state, what we want to have in a Git repository, and then we have some process that is making sure that whatever we want is what is really actual state, what is really happening, right? Very easy. From that perspective, we did GitOps. Whomever put anything in Git ever was doing GitOps in a way in the past, right? Now, in the meantime, we got a better definition of what that is. If you go to, I think it's opengitops.org, you will see that there are 4 principles, and whichever tool wants to, or a process wants to call itself GitOps, needs to fulfill those 4, meaning it needs to be stored in a declarative format, it needs to be version and immutable, that's why it's in Git, it needs to be pulled automatically. This is now, whomever is using Argo workflows or Jenkins or GitHub Actions to say I'm doing GitOps, that's not pulling mechanism, right? You're pushing something into a cluster. And it needs to be continuously reconciled. And especially because of the last point, all the tools that I know that could be called GitOps tools today are essentially 3 in total, as far as I know. We have Argo CD, we have Flux, we have Rancher Fleet, right? And it makes perfect sense that all the tools that are one way or another implementing GitOps, meaning that synchronization, reconciliation, and all this stuff, they're all in Kubernetes simply because Kubernetes already does half of the work that those tools need to do, right? We have the mechanism to reconcile, the mechanism to observe, and so on and so forth. Now, yeah, I already spent it. Now, the real question that I want to ask today is, why are vast majority of people who are using GitOps one way or another applying GitOps only and exclusively to applications? And actually, even that statement is not correct, but to applications running inside Kubernetes clusters, right? You're most likely not using Argo CD or Flux or whatever you're using to manage your Lambda functions. You're not using it to create your EC2 instances, set up your load balancers, or whatever else you might be doing. And the reason for that, I would say that is there is a, generally speaking, misunderstanding of what Kubernetes is, right? The vast majority of people, when we speak about Kubernetes, what's this Kubernetes? It's that thing that allows me to run containers inside of my servers, which, at least from my perspective, is not really the case. That's just one of the implementations of Kubernetes. Kubernetes is all about the API that is somehow uniform, universal. It can be extended with additional capabilities through custom resource definitions and operators. Kubernetes cluster is a control plane that can manage whatever you want it to manage. That depends on the operators running that cluster. And then one of the zillion options of that something being managed could be containers. And when I say containers, I mean containers with all the shenanigans that go around containers. But when you think about it, whomever thinks that Kubernetes is all about containers, we've been using Kubernetes. Even those who think that they're running only containers are using containers to manage infrastructure already today, right? If you create an ingress controller and you define ingress resources, you're getting an external load balancer, right? Your Kubernetes cluster is communicating with AWS, EKS, with Azure, Google, whatever it's using, and saying, hey, I want to manage something outside my cluster. Same thing goes for storage and so on and so forth. So Kubernetes really, and I think that that's almost the problem with the current idea behind GitOps tools, and that they assume that the desired state is in Git, that's fine. and then the actual state is Kubernetes. And actual state is actually not Kubernetes. The actual state are Kubernetes resources, Kubernetes manifests that they in turn are creating something else, right? If you go the simplest possible example and you say, hey, I define a Kubernetes deployment, that's my desired state, and that's my actual state. In reality, that's not your actual state. That's just something in Kubernetes creates a replica set that creates pods and so on and so forth. So the actual state is something else, which could be in the same cluster or outside and so on and so forth. And on top of that, almost nobody today, as I mentioned before, is using only containers, right? We have databases. Some of you might be extremely brave and run databases in a Kubernetes cluster. Call me in a year or something. You are most likely, if you're a bigger company, running your applications in many different places. You might be using functions, you might be using this, you might be using that. You have servers, you have clusters, services, and so on and so forth, right? Everybody has much more than containers. And that's what we are asking ourselves, when I say we, in this case, within the Crossplane community, is why wouldn't we extend Kubernetes? Why wouldn't we convert Kubernetes in a control plane so that Kubernetes itself can manage whatever you want it to be managed using the same API and all that jazz, and then we hook it into GitOps and allow you to actually extend your GitOps practices to everything else. You already know this, you already know this. What I'm going to do is jump from slides into a demo. I get nervous, I've been talking already for 15 minutes. So let me show you a quick demo of all that, of a combination of converting Kubernetes into control plane, managing stuff, and doing that all with through GitOps. Today I'm going to use Flux. It's not because I like Flux more than others, it's just that I randomly change the tools I use. The same applies to Argo CD or Rancher Fleet. So what am I going to try to do? I'm going to try to accomplish at least two things. First, that I never interact with my Kubernetes cluster. And when I say never interact, I mean never interact in a write mode, meaning that I will never instruct my Kubernetes cluster to do something. I might go there to observe and say, give me the status of what is going on. Not directing the interaction. I will actually make one exception because for a Flux to work, I need to tell Flux initially to create a resource saying, hey, this is the application, that's the Git repository, but outside of that, no interaction directly. And while I'm at it, I will try to simplify things in a way that everybody in my organization can manage clusters, applications, whatever that something is, right? So I will try to shield people from complexities of AWS and Kubernetes and all those things, simply because, unlike the popular belief, not everybody spent 3 years learning Kubernetes, 2 years learning Service Mesh, and 17 years learning AWS. So that's the goal, right? I'm going to skip the setup, I already did, and I'm going to jump straight into a terminal. If any of you, you're in KubeHuddle conference, so probably none of you, but if any of you likes pretty colors with nice UIs and all those things, that will not happen today. Sorry for that. Okay, so simplifying everything, managing everything through Git, and so on and so forth. So let's say at the very start, I need to create a cluster, right? I need a cluster that will run Flux. Sorry, I'm already running Flux in a management cluster, but that will run my applications and some other things, right? So how would I do that? I need something that is, and I already mentioned, I need something that is very, very simple. And that very simple, that very simple could be definition like this, right? I'm enabling my developers or whomever is working with me to have a self-service. You can create a cluster yourself. Don't open Jira ticket. I'm not watching those things anymore. All you have to do is to define something called cluster claim. Cluster claim, that's not something that comes out of the box in Crossplane. We do not use any resources directly. we create what we call compositions, meaning that this is a new custom resource definition in Kubernetes. You define it yourself. When I say you, let's say sysadmin, operator, SRE, DevOps, whatever you call yourself. I'm going to enable people in my company to choose through labels what they want, what type of a cluster they want. In this case, it's AWS EKS. It could be what those options are through the labels depend on how many implementations I made, right? I might have made a variation of this same thing for Azure, which behind the scenes will be completely different because what you need to do to run a cluster in Azure is completely different than in AWS. But for you as a user, that's all the same. You just select different implementation. A couple of parameters. I want small nodes. I want to start with 3 nodes, and I want Kubernetes version this one. I have no idea what small means in AWS. You figure out whether that's T3 something something or 2 something something and so on and so forth. And finally, I need that cluster to be useful, meaning that I need to be able to access it, or some other applications, processes might need to access it. So I'm going to store kubeconfig, in this case, in this secret, right? It's relatively simple, relatively straightforward. Everybody should be able to create and manage cluster because now what all those parameters and what that exact definition is depends on the communication. Imagine that I spoke with developers and said, what do you need? When you want a cluster, what do you care about? And that could be, I don't care about anything, or that can be, I care about X, Y, Z, whatever that something is. So, what was I about to say? Yes. So, what I should do now is, I will cheat a bit, right? I should now push this to Git, and then Flux will figure out that there is something in Git and synchronize it with my cluster, and then Crossplane would create everything that needs to create. I'm not going to do that for a simple reason, because it takes approximately half an hour for AWS to create all the shenanigans. So I cheated a bit, and I already pushed this file to Git last night after I was stuffed with Indian food and a lot of beer. So we'll see whether it works. It's yet to be seen. Anyways, imagine that I did push to Git, and I could say something like this: namespace production. Sorry, namespace is not production. Namespace is Flux system, and I want to get all cluster claims, right? And you can see that there is one of those resources running in my cluster. The fields there are also something that I define. So I, as creator of this custom resource definition, this operator, define what will be output there for a user. And if somebody is very brave and want to see what really running a cluster in AWS means, I can execute, managed. This is a alias, a shortcut that says, give me all the resources managed by Crossplane right now. And you can see that behind that YAML, those 15 lines, is a service in a way, right? It's a combination of stuff. I got security group, route table, VPC, subnets, internet gateway, cluster, node group, releases. Releases means that when somebody gets a cluster, I don't mean just here's a cluster, but that cluster is production ready, meaning some help charts were installed, some role policy attachments, roles, and a bunch of other Kubernetes resources were applied over there. I want that cluster to be fully operational, production ready, and all that jazz. So that's kind of easy. I have the base of what I want to do. Now what I'm interested is, okay, now how do you create your application? How do you run your application in that cluster or somewhere else? And let's say that for a hypothetical in a hypothetical scenario, I would like to run a backend database, a backend application connected to a database. Now, in that scenario, I'm not necessarily, do not really know all the details I need to know about running successfully a database, but somebody created a service, that's great. I want to run my application as a backend. I don't necessarily know whether I should use Linkerd or Linkerd or whatever I should use. Somebody created a service for that. And to make it a bit more complicated, I would like, when I'm in development mode, the database to kind of start running immediately. That will mean that it's easier to run it inside of the same cluster. But when I go to production, I would like the database to be, let's say, RDS in AWS, right? So I'm getting Postgres in all the cases, but Postgres might be one thing or another depending on the context and the speed that I need to work with. So how would I do that? Let me open my notes. There we go. I have already prepared the manifest. There we go, right? I will define two things. Again, this is all custom, right? This is something that somebody created as a composition, as a custom resource definition in Crossplay. And say, hey, whenever you want to run an application, that application can be in Kubernetes cluster, it could be Lambda functions, it could be GCR, whatever we define that we will have. We have something called upclaim, matching labels to say what you want. You want a backend application with a database. You want to run it in the same cluster. It could be somewhere else. Some parameters, off you go. And then I want a database. Again, new custom resource definition, SQL claim. I'm going to say that database in this case should be in the same Kubernetes cluster and the Postgres database, few parameters. And most important thing here, not most important, but when you create that database, I want you to generate authentication, a secret with authentication to the database so that this application can connect to it one way or another, right? What am I going to do? What I'm going to do is I'm going to copy this file. What was the file? Dev something something. There we go. To the directory dev apps. No, I need to create a directory dev apps. I'll do that right now. Dev apps. So I'm creating a new directory in this repo. I'm going to move that file or copy it better. To here. All right, I'm going to add it to Git. Now I'm not cheating anymore. I'm going to push that to Git. Now, nothing yet will happen because depending on how you organize your tooling and stuff like that, you might or might not need to tell, in this case, Flux, that, hey, you should start monitoring what is happening in this directory. Whatever is there is the state I want. So I'm going to tell that to Flux. Flux, no, instead of trying to type, I'm going to pretend that I'm a developer and I'm going to copy and paste the command. Think of this as being Stack Overflow version of what I'm doing. There you go. Right, I'm telling Flux, hey, there is this repository that is already configured. There is a directory DevOps. Do whatever needs to be done. And do whatever needs to be done is KubeHuddle -- namespace, I think dev get, what was it called? Up claims and SQL claims, right? Those are the resources. And you can see here that it's there. It is, what is it doing? Yeah, it created those two resources. Now, behind the scenes of those two resources, you will see that we got right? Those two custom resources with that their operators were expanded into stuff. So my backend application ended up being a deployment. The database ended up being a stateful set. There are some secrets with stuff. There are some services and so on and so forth, right? And they're all running or will be running. They're all running. That was fast. That's why I wanted the database locally. Now, let me switch to a different cluster now, because as I said before, get clusters, I think, no, that's not the one. I forgot now, what's the name? Get CRD cluster. I forgot the name of the resource clusters, EKS clusters, right? KubeHuddle get, there we go. You remember that one that I was cheating that last night I created? That's the cluster there running. What I'm going to do is, again, copy and paste, pretend that I know what I'm doing. I'm going to get the secret, kubeconfig stored in a secret from that production cluster. I'm moving somewhere else. Store it as kubeconfig. And I'm going to no, it works, must be working. What I'm going to do next, now I have kubeconfig for my production cluster, and I want to deploy the application to that cluster as well. I'm going to call the directory prodops, and I already prepared a manifest, which is, I think, this one. There we go, backend, right? Now I want that application running in production. That application cannot be the same application because I want it to be similar in not production and production, but cannot be the same simply because there are maybe more replicas, different qualities of the application. But from the perspective of somebody managing and defining those applications, it's almost the same, right? This is the same app claim. These are the same labels. And this is the same parameters. The namespace, I think, is the only difference in the host I'm using. Now, in the database perspective, it's almost the same. The major difference is that now I'm saying, hey, provider is not local anymore, right? I don't want you to run that. I want to have exactly the same database, but that one shouldn't be in a cluster because now we're in production. It should be in AWS, still Postgres, and a few parameters, right? So I'm going to do the same thing as before. I think that I'm going to do the same, so I'm going to copy this into prodops directory. There we go. I'm going to add it to Git. I'm going to push it. And I'm going to create a Flux application now that will monitor this different directory. I think I already prepared the manifest. Let me see where I put it. TMP prod. Yeah, here's the manifest. This is Flux standard stuff. The only thing that I'm doing here special is that I'm telling Flux, hey, do not synchronize within the cluster where you're running right now. Go to this different cluster, this production cluster, and you will know how to connect to it through the secret that I already used myself to connect to it. So I'm going to say kubeHuddle, apply. File name is, what did I say? TMP prodops. There we go. And then if I say, if I go to that new cluster, and I'm using this kubeconfig, and I'm saying in production, what do you have over there? Do you have some app claims and SQL claims? I should see probably not much or something. There we go. All right, it's already running since 14 and 15 seconds ago. And my applications, what those two compositions created, you can see here, ingresses and secrets. Now, what you will see here is much less than what you saw before, because in the development, I said I want cluster in the same namespace, in the same cluster, and I got additional resources. Here, I have only the application. And the pod is failing big time with create container config error, right? But that's normal, because what that error means is that, hey, I'm trying to connect to the database. I cannot connect to the database because there is no secret with authentication to the database, and there is no secret with authentication to the database because there is no database. And there is no database because AWS is too slow and takes 5 to 10 minutes to create RDS database. But eventually, it will happen. And I can see what's going on by saying, hey, here are the managed resources. This time, and this is now, remember, this is a completely different cluster. This is production. You will see that Crossplane in this case is expanding my definition of the database and running all the shenanigans we need in AWS. There is DB subnet group, going from bottom to top, RDS instance, some Kubernetes resources, some subnets, route table, and all the jazz that is needed, right? What matters is the database is still being created, meaning there is no secret application cannot work, but it will work 5 minutes from now or something like that. I will not wait for that because 5 minutes is too long. I don't know how much time I have. Nobody knows. Probably 10 minutes, 15 minutes, 20 minutes. 15, okay, then I have 15 minutes for questions. Or you can watch in silence until AWS creates an RDS database. Why customize? Because in this case, it's when you tell Flux, you can create a Helm. In Flux, among other things, you can say, hey, this directory contains Helm charts or anything Kubernetes, not only customize. Now, I hate Helm. I was about to say more than anything. That's not true. There are things I dislike more. I'm not very fond of Helm. I don't like Helm. I use Helm all the time for third-party applications. I think that nothing beats Helm for third-party apps simply because all the world library of all the world software that I might want to run is in Helm. But for my own applications, I prefer anything else. And since, actually, I'm not even using customers in this case because I simplify things so much that all the complexity is on the server side in a cluster. So my YAML is always very short, like those 10, 20 lines, even though there's a huge things happening behind it. So I don't need even customize, really. Pure YAML works. It's just that you cannot tell Flux this is not customized. It thinks it's customized, even though it's not.
If you've got a question, put your hand up and we'll give you a mic and then people can hear you.
Hello.
Works. Even.
I hate mics. I do. He can hear me.
It's a small room. Everybody can hear without mics, but okay.
It's for the new.
Sorry, video.
I didn't know.
I will talk into the mic. No, you probably know this when it's coming. So what are you using for secrets management? What are you using for secrets management?
Oh, today nothing in this demo. In this demo.
Ah, okay.
Depends. I go back and forth between if I need to keep my secrets in, let's say, Vault or Google Secrets Manager or whatever, I tend more often than not to use external secrets that synchronize those secrets into Kubernetes secrets. When I can get away with not using any secret managers, I tend to use, what's the name? What was GoDaddy before? No, not Go. My brain stopped. I'll find it. Sealed secrets, sealed secrets, sealed secrets. Yes, that's the one. Yes. But also, kind of, I'm trying to avoid anybody really having to deal with any secrets. They're in a cluster one way or another. They're used by other processes. And what you need is two things to be able to access Git repos that with sufficient permissions to do something over there, and to access the tools that give you visibility into what's going on. Observing only, read-only mode.
Hey, Victor, I want to just say thank you for your videos. You've gotten me over 1 million humps, and I do this professionally every day. So
Well,
thank you, sir.
Thank you, man. Anybody else?
Come back here.
No, not him. Don't give him the mic.
So, hey Victor, thanks
Yeah.
for the presentation. Short question with Crossplane. Is there a possibility to run a dry run? Because I know for Terraform or Pulumi, that's one thing we always do in our flow, create a pull request, show the person, okay, this is going to be the impact on your infrastructure, how
Yeah.
it's going to be with Crossplane.
No, so something equivalent to Terraform Plan, right?
Yeah.
Yeah, so there is no that option today. I mean, you can see the diff between the manifest in a cluster and what you want to apply, but that's not the same. There is no equivalent of Terraform Plan, and I honestly don't know whether we will ever get there. And the reason is that there is a huge difference in the approach that tools like Terraform, and I'm using Terraform as an example, not all the other similar tools are doing and what we're doing in Kubernetes, right? When you execute some Terraform apply or plan, it's a process that is controlled 100% by the CLI, it does things, and then it finishes, right? When we use Kubernetes, we are delegating Kubernetes in a way to figure out, orchestrate what will happen, when and how, and so on and so forth. So we don't really know in advance what will happen. And this is not crossplane only. Like as far as I know, nobody came up with, let's say that you're using just Kubernetes deployment, right? Nobody came up with a plan, equivalent of a plan, because Kubernetes is going to schedule it later, after you finish applying something through the API. So, not sure.
Hey, Victor, good stuff. I'm glad the demo gods were working as well. You mentioned about databases inside Kubernetes, and then we got on with the demo. Maybe use the rest of it to just give us that. So my point is, like, so from a Kubernetes release point of view, we're seeing more and more effort go into that how do we get stateful workloads within Kubernetes? What's your opinion on that? I've seen a lot of customers using external data services. RDS you mentioned a lot. What's your opinion on data services inside of Kubernetes?
So, assuming that that database is not Oracle to begin with, we are going there, right? It's just that there are a couple of obstacles. First of all, databases is not the first thing that I would start with when going into Kubernetes journey, right? Kind of, that's almost the last thing I would move to the cluster, right? After you had enough experience with stateless applications and then stateful applications connected to the databases somewhere else and so on and so forth. So it's the last stage from my perspective. It should be running Kubernetes one way or another. Now, there is a different question of how much should I manage and how much should I leave to some provider to manage. I'm hugely, if I ignore money, because that is in a play, but that's a separate discussion, I prefer not to manage anything. If I can have CI/CD and cluster management and this or that all in the hands of somebody else and I can focus on what matters for my business, I think that I would be more successful. Except when somebody charges arm and leg and then I say, okay, so I can actually hire 50 people instead of this service, then okay, maybe. So yes, I would, if ignoring money, if I could choose run it in a cluster or RDS database, and I'm using it as an example, RDS database, no question. As example, no, not advertising AWS now.
Okay, this will be the last question.
Oh, you better make it good.
No pressure.
Not quite sure about that, but we'll see, I guess. Well, first of all, thank you very much for the talk. I'm kind of stealing other people's thunder on this from previous talks I've seen and a bit of my own experience. But one thing I've seen is the biggest risk with managing infrastructure through GitOps and then CRDs, like with Crossplane, is that sort of opportunity to shoot yourself in the foot. I've seen examples of people with small changes to YAML files that's being operated in GitOps. And I think the person sat beside me referenced if I don't have a plan or like this sort of ability to foresee what's going to happen when I click the merge button, all of a sudden my entire infrastructure is wiped out because it's all linked back into this GitOps flow that's just caused cascading failure. So I guess my question is, from your experience doing this stuff with Crossplane and other sort of GitOps to manage your whole estate, what are the main things that you need to look out for in the process of not shooting yourself in the foot and causing pain for the next 48 hours?
Yeah, I mean, that's, I think that that's I don't think that problem is specific necessarily to GitOps. You know, if you have pipelines that will do something, build releases and do this and that and deploy, whenever you merge or push something to the main line, we have the same problem, right? It's a problem generally that the more automation you have, the bigger chance that you will propagate your issues or errors on a bigger scale, right? That's with all automation, not necessarily, at least from my perspective, with GitOps. I've been creating mess across data centers easily with Jenkins 15 years ago, right? So it's really how much testing you have involved, how much peer reviews of your pull requests you have, and so on and so forth, right? It's just that when we work with infrastructure, the scope of the mess we can create is potentially bigger than a single application somebody incorrectly did this or that. And unfortunately, you know, all those things like testing and reviews and stuff like that tend to be, in practice, much less common for infrastructure and services than for applications. I can bet that if I go to an average company and say, show me the test practices for your applications and then show me the test practices for everything else, it will be like this, right? So I think that we need to evolve to the level that actually all other things that we do are following in a way development practices. Not necessarily to the letter, it needs to be the same and all those things, but it's almost, that almost reminds me like, I don't know, like 15 years ago or something like that, when typically companies had completely separate QA department when nobody is a developer, nobody writes code and stuff like that, and then we slowly moved that actually testing is just as much development practices app development, and we are getting there with the infrastructure. But yes, plain you will not have, simply not for anything Kubernetes. So if plain is a must for applications, infrastructure services, Kubernetes is not a thing. Until somebody figures out to know what will scheduler do in advance.
Okay, just want to say thank you very much to Victor. Everyone can put your hands together.
Thank you.
The next talk will be Martin Hickey at 10:30. So you've got a few minutes to get a comfort break, and then we'll start again. Thank you. Started, so I'm going to introduce you to Martin. He works in the open technology team at IBM, focusing on open source software. Put my teeth back in. He's a regular contributor to the open source and core maintainer for Helm. He's also contributed previously to OpenStack and Elastic communities. Martin enjoys speaking at conferences and meetups and has many years' experience in the creation of enterprise software for different industries from Teleos to cloud. So let's put our hands together for Martin.
Thanks, Greg. Hello, folks. I'm delighted to be here in Edinburgh today. It's my first time. So anyone here from Edinburgh? Hands up. You're not from Edinburgh out there to back. Okay, so we have a few locals. That's good. That's good. Yeah, it looks like a really nice city here. So I'm glad to be over, and thanks to all the organisers. So today I want to talk really around the journey of open source, starting from, I suppose, the valley, you know, when you're trying to become a new contributor, right up to when you're trying to make a maintainer. So when you're climbing that mountain trying to get there. So I suppose let's get a kind of a level set of people. Hands up anyone who's a maintainer in a community. Okay, we have 3. Hands up anyone who is would like to start contributing to an open source community. We have a few hands, great. Anyone that's in between, so has been contributing but wants to get there oh yeah, we have a few hands as well. So that's fantastic, okay? So I suppose why I wanted to do this was my own journey started about, I would say maybe about 9 years ago when I worked on a downstream product where we built on top of OpenStack. And I started getting exposed to the open source community, and I really got a real interest in it. So a few years later, then I got a chance to work full-time in open source, and that's what kind of kicked me off and got my love of it. And I suppose the whole joy of the collaboration with people from all different parts of the world, in all different companies, and we just working to trying to make the community a better place. So that's kind of my journey. So what I'm going to talk about today is there's a few phrases that are out there like chop wood, carry water. You know, have a look at the good first queue issue, triage your issues, make yourself known in the community. Hands up anyone that has heard phrases like that before. Okay, we have a few hands. Hands up anyone that sometimes has wondered what do they mean. Okay, that's good. So that's what I want to kind of do. I'm going to talk in my own inimitable Irish way. And you probably go, we do not know what he's talking about, but hopefully they'll have subtitles at some stage and you can understand it. So let's see how we get on. So who am I? My name is Martin Hickey, and I'm about 25 plus years in the tech industry, and that's been working in enterprise and in open source for the last probably about 7 years. I'm a Helm core maintainer, and I'm on the technical oversight committee. I'm a contributor to some of the Kubernetes projects and to OpenTelemetry in the CNCF, and I work over at IBM. So these are some of the topics we're going to cover today. I'm going to basically bring us through that journey as I talk about how to get started, how to move along, and then, you know, making the, I suppose, the top or the zenith of a maintainer. And I think the biggest part of this is really the journey. You know, the destination, I suppose, is always important, but as we go through life, and I found as I got older in life that sometimes making the destination isn't that exciting. It's the journey along the way, the things you learn, the people you meet, stuff like that. Right, a few tips for getting going. First and foremost, does anyone know what's in that picture? Tea. Hands up anyone that likes tea. Now, we call it tea where I come from because it's the Irish word for tea. My kids call it tea because they have nice sophisticated accents, but I call it tea, and I like tea. And the great thing about tea is there is so many choices out there. And not everyone likes every different teas, you know? It's the same with an open source project. And this is probably, if you're going to take anything from this today and you want to start out, it's picking your project is the most important thing. And this might sound obvious, number one, or number two, you might say, what does it matter? But it matters a lot. Because if you pick the project you're interested in, when the hard days come or the challenges come, you're more likely to stick with it. You're more likely to keep going, and you're more likely to try and stay on that journey. And you'll enjoy it more, probably, as well. Okay? Now, I've put a little asterisk on this because the caveat here is sometimes it's picked for you. like a lot of things in life where, you know, maybe an aunt arrived with this shirt and you just looked at it and went, oh my goodness, I am not wearing that shirt. And you just go, I'll put it on, it looks lovely, Auntie May. Yeah, so that's the caveat I'd say there, that sometimes it's chosen for you and you have to go into that community. That happened to me when I first started, and I went with it, but I enjoyed it. But as I say, the key part is if you can choose it, choose wisely. A real practical example came to me about 2-3 years ago. I was mentoring somebody and they wanted to get involved in open source. It wasn't part of their day-to-day job. It's something they wanted to do as a side project. Now, when they came to me first, they goes, oh, you work in Helm. I'm really interested in Helm. So the very first mentor session I had with him, I said, do you know what? I want you to go away, pick the top 5 open source projects you want to work in, and then come back to me. And he was going, but. You know, it was kind of like you go to somewhere and you pay for something and they say to you, well, you have to go away and do the work first and come back to me. So I sent him away and he came back the following week. And suddenly Helm was number 5, not number 1. You know, number 1 being his top choice. So he then was interested in getting involved in Tekton. So I helped him get going on that. I pointed him to people I knew in the community that were maintainers, and he got off the ground and he started working away in his own time. Now, I did say to him, this is going to be difficult in your spare time because he's a family and stuff, but he really wanted to do it. So he started off really well. He started pushing a few issues. He started looking at PRs and getting involved in the community. So after about a year, I wanted to see him progressing on to the next level. And we look at this as we go down along, you know, where he really starts taking responsibility. He's reviewing stuff all over the place and he's bringing up his, you know, his contributions. And he wasn't coming to the next level. So I was trying to figure out what's wrong here. So I talked to him about it one day and he was a bit shy about it, but he eventually admitted, I don't like the project. Nothing to do with the people there. He just felt that, you know, he may have picked the wrong project to start with and he wasn't able to make the progress on. So then I sat down with him again and we talked it up more and more and we eventually found then he was interested in Knative. And he started working there then, and as look what happened, he got an opportunity to work full-time in the community and he moved into this new role and he's done really well in that project and he's moved up to maintainer status and so forth. But the key here is that when you're interested in something or it clicks for you and you like it, you are going to make progress, like everything in life. Read the docs. Hands up who's always heard that phrase, read the docs. Hands up anyone where you didn't understand something and someone sends you a link to a doc and you go, hell with that, I asked you a question, give me an answer. Anyone hands up where they got a bit annoyed with that? Yeah. So I'll admit it, I haven't always been the best docs person in the world. I am probably one of the worst. When something is bought, I just take it out of the box and try and make it work. You know, and then find the instructions afterwards when it's not working right. Why are the docs important? Because for a few reasons, in open source communities, we put in effort into the docs. Now, sometimes it mightn't look that way, but we do. And we do this so that we can help people going along, number one. But number two, there's probably a secret little thing where we go, I don't want to be answering questions all the time, you know. And the great thing about docs today, not like the static docs we rendered in the old days and printed them and sent them out. There's URLs. URLs are your friend. You know, if you have good docs and someone asks a question, you can put a URL out there. And you know what? If your docs are good, it's going to answer a question. But why is this valuable to you when you're starting out an open source project? Because you will get a lot of your answers in there. So if you start with the user manuals, let's say you haven't been using the project before. If you start with the user manuals, how to use the project, that'll give you an idea how the project works or what does the tool do. Second of all, there's good docs usually around how to contribute to the community, how to set up your environment, how to deploy things, how to build things, etc. You'll find out about the code of conduct. If you haven't read a code of conduct before, a lot of them are the same, but it's important to know. And especially after the absolutely courageous speech of Leanne this morning, code of conduct is so important for all of us out there. So, you know, it's important to know how to behave ourselves in community, and I'll get to that in a few minutes. I have a little slide on that. You'll also find out how does the project ladder work. So how do you go from starting off as a contributor, maybe moving to more intermediate, having more contributions, and then finally making maintainer if that's where you want to get to, and also knowing those maintainers that are out there. And then the communication channels, they're important. So when are the weekly meeting or meetings? Where are the Slack channels? You know, where are the places where you can go out, you know, and respond or ask questions, and also in the meetings as well. Now, at the start, this might be scary, but what's good about this at the start is you can be somebody who watches from a distance. You don't have to, you know, show, you know, if you go to meetings, you don't have to put your camera on if you don't want to, all that kind of stuff. You can just see what's going on and get an understanding. And oftentimes, seeing what happens is easier. Do you know, it's the same as if you're showing someone how to do something, is that by showing is often better than by telling, if you know what I mean. You know, if anyone has got kids here, do you know, I think Bruce Springsteen talked about it once, that, you know, my kids learn more from how I did stuff than from my telling them that. So do you know what I mean? You know, do as I say and not what I do kind of approach. But the docs can be so helpful on that, and basically can get you a good overview and an understanding of how the community works. Last example I give that, and when we worked in Helm, we moved from Helm 2 to Helm 3. Now that was a really big release because we changed the infrastructure, we changed the architecture, and a lot changed. And one of the key parts was when you no longer had to install a service into the cluster in Helm 3, but you had to in Helm 2. So you had to do a Helm init. And I remember when we did the maintainers talk at KubeCon San Diego, and we just had released, this is the thing I said, docs. Docs are very important. Questions are starting to come in, and it's all in the docs. And it went on, I'd say, for months where people kept asking, I can't do a Kubernetes anymore, there's nothing installing in the cluster. We went, yeah, it's no longer there, and you'd send the URL to somebody. You know, but always it's about kindness as well, and I'll talk about that. That yes, you might be at your keyboard going, well, you read the docs, but you must go, no. You know, this is the way it is now, and then you show the docs. So having the docs and keeping your docs up to date is important, so that you can get an understanding. So yes, go through the docs for a while, but eventually make that jump. You know, build your project. You know, run it. And when I talk about contributions, it's not just code. Contributions are everything in the community. It can be testing, it can be documentation, it can be the website, blogs, whatever. They're all contributions. But what I'd say to you is, whatever you're doing, take the project first, set up an environment and try and build it. Because whatever you do, whether you're writing a blog or documentation, you still need to understand how something works, because it's easier than to have a context to write about it or whatever, or if you're contributing to code or whatever. Now, the lovely thing about this is there's always bugs in the documentation. So I'm just after telling you in the last slide, read the docs, now I'm telling you there's bugs in there. There's always little silent bugs in there. And one of the reasons is when maintainers write it, they've often been using the project or in the community for a long time. So we often have things already pre-installed in our systems, so we take things for granted. We forget that this needs to be set up, and we often miss a jump, you know, from one part to the next. We often miss that little bridge that somebody who's new or starting out will not see. And that's why I say when you're setting up your environment, follow the docs to the letter of the law. And if the docs don't work for you, then the docs are a problem. And you found a bug, and you found your first PR. Yay. And that's the key. Because this is the hardest part. How do you find your first PR? Like when I first started in OpenStack, they used to use IRC. Hands up, anyone knows IRC? Yeah, there's a few nerds out there, yeah. So it's Slack today is a nicer version of it. But I remember, you know, I was told, go out there and make a difference in the community. And I sat there, and it was like tumbleweed for 2 weeks. Like, what, you know, the first day I said, hi, I'm Martin, I'm here to help in the community. Nobody responded. Now, this is like, you know, I don't know, your worst day in, I don't know, in school or something when no one wants to be your friend. So then about a week later, I said, I'm not giving up. And I said, hi, I'm Martin, I'm here to help out. Nothing again either. Now, eventually, you know, and I'll go through it in a minute, I started looking at, you know, the issues and stuff, and I found something. But it is tough starting out. But this is a nice way, because you do a PR and you push it. And remember, every time somebody does something in the community, maintainers see that. You know, the emails come in, they know. And suddenly, your GitHub handle is you. You mightn't take it like you say, I've got a name. No, what's your GitHub handle? Because that's the way how people know you, is by your GitHub handle. So this is a nice way of getting going. It also ramps you up nice and quick as well, because you can see how things are working and stuff like that. You might even have a look at the code. And it's a good way of building up your confidence. And you're doing a lot of this at the start. You can do this anonymously, you know? And what I mean by that is you don't have to be, you know, if you don't want to, you don't have to be communicating straight away with folks. You can be doing this on the side. And your GitHub handle is known, and people will start knowing you as you go along. So it's a nice way of getting going. Now, becoming visible. And I know not all of us, we all have different levels of being sociable. Over the years, I've had to learn to be more sociable. And it's not easy, but it's important not to be a shrinking violet or hiding in the corner. You know, when you do your work, put yourself up there and be proud of what you do. But also, if you want to start making this journey, building your eminence as you go along, or your kudos, or getting known, or you have to build a rapport with people in the community. And if COVID has taught us anything, human beings are not supposed to be on their own all the time. We really need companionship, you know, whatever that companionship is, your friendship or partners or whatever, we need somebody in life. And it's nice to be able to talk to people and interact with people. And this is the same here, that if you don't build your rapport up in the community, then it's going to be very hard for people in the community to recognize you or want you to go to the next levels, if that makes sense. And the way to get going on this is, in my opinion, is, you know, look at the issues that are out there, you know, see what's going on. You don't have to maybe answer them straight away, but you'll see what's coming in. Read them as they come in along. The same with the pull requests. Have a look at them. See how our people are responding to stuff. And what's nice about this is you'll suddenly start, you know, going off in tangents into the code and seeing where things are and the documentation, whatever. So it brings you in different directions and helps you get a better idea what's going on. So what you do is you start learning by osmosis. It's fantastic. Like, you suddenly go, yeah, I remember that's in there somewhere, isn't it? And you go down, oh yeah, I know that's in there. And I saw someone make a change there before. I think I can make a change there. So it builds you up bit by bit. And then when you start getting that confidence, start responding to issues. You know, take an issue that comes in and verify it's an issue, because that's what maintainers will have to do. Go and see, can I reproduce that issue? And if you can't reproduce that issue, give a nice message and say, look, I tried it such and such, it couldn't happen. Because the person might come back then and say, actually, you need it set in this scenario, and you go and try it again and go, oh yeah, that's right. This seems like an issue. You know, but in a way then you're starting to do work, and maintainers see you starting to do work, and you're starting to make yourself more and more visible in a nice, simple fashion. Same with PRs, you know, start doing a review of a PR. Yes, you're not going to know everything. You only know a little bit at the start, but go with it, because the community should be kind enough to help you build yourself along, be able to give you positive feedback, not trying to shoot you down. The same with join your weekly meetings, get out to Slack, see what's going on there. Make yourself known bit by bit. You know, maybe answer someone on Slack if you say, oh, I had that issue before, you know, I know how to do that, and give them an answer. Because people really appreciate that you can answer their questions on Slack, even if you're putting the URL in for a doc again. But there you go, you know. No, so that's probably the first phase, you know, getting started, you know. And we've gone through, I suppose, some of the key points I would have said. Pick your project, be the most important. Use your docs, build yourself up. Try it out. Try the project out, build it, see how it works. And you might find issues as you go along. And then build yourself up your visibility as you go through different things like doing PRs or looking at issues and stuff like that. So next part is when you want to move from being a contributor and making some contributions to what I call a committer, which is really a serial contributor. Somebody who's always contributing on a regular basis, whatever that contribution is. You don't want to be a drive-by. And what I mean by that is you don't want to make a couple of contributions or do a few things and disappear for months on end or come back a year later or whatever. This is alarm bells to the community because they don't know, are you willing to, dedicate to the project or not. Now, this might not be your fault. There may be parts of your life or your job or whatever that has happened. But if you want to, I suppose, really build yourself along in the middle part of your open source journey, you really need to be there regularly and contributing regularly. So that's important. Building with everybody else, like all the folks up on the roof here. This should go without saying. Like everything in life, it's better to be kind than right. Sometimes there's no need to correct. If you're out with people, you know yourself, there's no need to correct someone just because you were right. Does it matter, really, if somebody's a slight bit off, as long as you're having a good time? And it's the same with the community, all right? Yes, you help someone along, but please don't, shoot them down hard, okay? So be authentic, be sincere with folks, help folks, but don't be a jerk. And every now and again, we get a jerk in the community, where somebody, and I've seen it, somebody comes in with an answer and somebody comes back, that's the most dumbass question I've ever had in my life. That is not nice. Look, even if the question is a really obvious question, that someone should have seen at the docs, answer the person nicely and give them the link to the doc. Don't just say, dumbass, here's the URL. And now that sounds a bit extreme, but I have seen it, and you'd say to yourself, what are you doing as a person? Because those people like that, they will get called out by the maintainers of code of conduct. If they're not, the community is not doing its job. And if they keep at it, they will temporarily be suspended. And when they come back again, if they do it again, they will be banned from the community. So if that's not something to tell you, how you should behave if you don't understand, then that should be a good level to you. Because if you get banned from a community, and this is a great thing about open source, is it gives you so much opportunities because it's so open, but it also gives the opportunity to shoot yourself in the foot. Because if you get banned, you may find it difficult to get work again. So just, the key here really is help people, and that's what it's about, and be kind. So the famous chop wood, carry water. To me, really, it's all about helping and volunteering is what I think chop wood, carry water is. My reference to this is go out and clean the drains when no one else wants to do it. Hands up who's ever had to clean the drains in their house or apartment or whatever. Yeah. It's not a pretty job for anyone. There a couple of months ago, I'll never forget, I was finished for the day. I was doing after work, I was doing a few things outside, and I was just about to go to bed. I saw a drain out the back, and it was nearly full, and I go, oh no. An hour later, I eventually finished, came in, said it to my son, I thought I was going to come in, relax, whatever, clean the drains. And he just says to me, deadpan, he goes, isn't that your job? So, no sympathy was coming there. But it's the willingness to do the jobs, the unattractive jobs. The jobs that, are not, the sexy pieces of code or, the 1,000 lines of code. It's the stuff where you have to get stuck in there and get into it. An example I would have is when I started in OpenStack, I was trying to get, what I said earlier was in Neutron, I was trying to get a few issues to start with, and eventually I got one or two issues and it got me going. But one of the issues I worked on, when the maintainers reached out to me, says, well, you're in that code now. And I said, I have a feeling this is not going to be good. Well, you're in there's a piece of work we've been meaning to do. And it's an important piece of work because the foundation has told us it has to be done in every project, and we've been putting it, on the back burner, which means no one wants to do it. So he described the piece of work, and I went in and I go, oh, this is horrendous. You had to go into every piece of code and find where all the configuration items were, and then put annotations on them so that it would dynamically generate the configuration. Awful stuff. Awful. Drudgery. Yeah. And the first PR had to be a big one because I couldn't break it down anymore, and that took weeks and weeks of reviews and the whole lot. And it was not nice, but I knew it needed to be done. But I didn't realize the benefit and side effect afterwards for me was there used to be meetups then in between the conferences. They were called mid-cycles, and we had a meet-up in February that year. And maintainers started coming over to me and goes, will you, my handle, whatever my handle was, GitHub handle, was you did that work? Yeah. Deadly. That was great. And it just exposed me to a lot of people, or made me visible to a lot of people, without me even knowing that. And they were so delighted with the work. And even one of them said it to me, and I'll touch it inside in a while, is we were so glad too, with all the feedback that came back. Because sometimes, if you're not careful with feedback, you can take it as real criticism and take it personally. But I just decided to hell with it. Look, I want to get this in, whatever people feedback gave. And they were positive, but you could. And he just said to me, he said, I'm so glad that you didn't take anything personal. You took the feedback, you change it every time, and I don't know how many commits I put in. I just kept going. I said, I'm getting this in. I was like a Terminator. I said, I'm not stopping. I'm gonna make this. So, that's what it's about, doing those jobs. Same in Helm, like doing reviews, doing triage. And when I first started, all those things got me visibility because I was willing to work and showed the person I was that I'm willing to work for the project, for the better of the project, not for the betterment of myself. And I'm going to finish on mindfulness in this section because, again, I suppose I go back to the COVID and stuff. This became a big word during COVID. And I never knew what mindfulness is, but I saw a nice phrase where it said, mindfulness is not mindful. Your mind not full of stuff. It's mindfulness. It's the opposite. It's where, I suppose, hands up whoever's gone for coffee maybe with a friend, and you've had loads of stuff going on, and you need to pick up someone there, or you need to get that thing there, and you sit down, you have the coffee, and you realize that really you weren't with the person. Hands up, does anyone ever happen to? Yeah, it's happened to most of us in life. Where we just, our mind is somewhere else. And over time, I'm learning, you need to be in the moment. Because if you're not in the moment, you're going to miss the things of life. You know what I mean? The little things you achieve, the great friendships you've with people, you're just going to miss them because you're always thinking of the next thing instead of the thing you're at. And why I bring that in with the community is be in the community when you're there. Even if you can only work 30% a week on it or 10% a week on it, be there during those 10%. Like, don't be jumping in and out to emails and different things like we are always trying to do and multitask. Multitasking is a load of rubbish. No one can multitask. If you're multitasking, it means you're doing only bits properly of everything you're doing. Like my mum was an amazing multitasker. She'd be putting on washes when we were young and making dinners and doing everything, but the dinner always got burnt because, she was trying to do too many things. So I got used to helping then, which was great. It taught me how to cook and stuff, so yeah. But yeah, being in the moment is important. Right. So that middle part where you're trying to earn respect and build up the rapport is be present, be helpful, volunteer, earn your stripes, get known in the community, show that you're a doer, not a talker. Okay? That's important. So looking at the last aspect of it, if you want to get to, your goal is making the summit of a maintainer, which really is probably the easiest part of all. And you're probably going, no, that's the hardest part. No, it's the easiest part. No, it's the hardest part. I'm going to say it's the easiest part because by the time you come to be a maintainer, you've proven yourself already. And really, it's a validation. And I suppose it's like our jobs when we get promoted. If we ever get promoted, when you get promoted at that level, to be honest, you've been doing that job the whole time at that level. By the time you get the title or the nice thing from our manager or maybe you get, I don't know, 0.01% of a pay rise or whatever we get these days or whatever. It's probably going to be negative if the economy keeps going the way or we'll have to pay money back to get promoted. But on a serious note, you have done the work there. You know, you're at the top of your, as I can see here, the lovely castle or house in the top of the mountain. You're up there by then, and you've earned the right to be there. You've chopped your wood, carried the water, the phrases we don't want. You've volunteered, you've done the work. Now, to get there and to be eventually validated then that depends on the community. So you may have to send an email to nominate yourself, or create a PR in the community, or, you know, when the maintainer does it, or the leader says, yeah, maybe the project leader or whatever. It depends on the community. So that'll change from project to project, and just if you've read your documentation, or if you read how the project ladder works, then it should be there. If not, push a PR, work with the people and maintainers and say, right, we need better verification here, or open an issue. So as Peter Parker's uncle said, and I don't even know I'm putting this up there, but I kind of like the Spider-Man image, so that's why. As Peter Parker's uncle said, with great power comes great responsibility. So once you get up there, I suppose it's like everything in life. You know, when you become responsible for something, you know, be responsible, okay? And really for a community, when you're in an open source community, it's no longer about big pieces of functionality you're trying to push in or whatever else. Once you become a maintainer, it's now really about helping other people, driving other people on, bringing other people to the next level. That's where your role is then once you're a maintainer, okay? Helping other people become unblocked. And that, after that then, now you'd still be doing stuff like cutting the releases and doing all that important stuff, or hosting the meetings, etc. But it's the unblocking of other people afterwards. And also to remember where you came from as well, you know? How people helped you as you went along. And that's how we all drive on in communities, and how we all get on to the different levels. Right, to finish. For me, being that kind present person and being present in the community is probably one of the most important things you'll do. And that when you're in a community, you're doing it for the better of the community and the improvement of the community, not for the betterment of yourself. If you go down the rabbit hole of the betterment of yourself, you'll eventually hit a brick wall somewhere. Whereas when you're doing it for the betterment of the community, then the benefits will come to you. It may take time, but they will come to you over time, and little things will happen to you. And you'll say, how did that happen? That was kind of lucky. But there is luck, but there's also, you earned the right for that luck. As I said, with becoming a maintainer, at this stage, it's really a validation of what you've done. When you've done all that hard work in, I suppose, the middle part of your career, even the starting out part, where you had the courage to go out there, and then in the middle part where you drove on and you became that serial committer and that serial contributor, you're a committer, and you're making those contributions to a better project, it's then when the community will eventually give you that validation. And then once you're there, you're trying to steer that project home. You're trying to keep it going. You're trying to keep the ship off the rocks. You're trying to drive the project forward and better the project for the community and for everybody else. So that's where you go in the end. Okay, that's all from me. Thank you. Do we have time for questions? Anyone got questions? I'm not promising I can answer them now, but okay.
How about 2 questions? Is that all right? Is that too much?
Craig is the boss.
Making everyone's lives hard. So first of all, thank you very much for that. It's really nice to see, especially like a presentation like that. I've not seen them as many presentations like this previously, so really enjoyed it. My 2 questions, I guess, are first of all, is for from my perspective. Do you find, or have you ever found, or can you relate to the fact that when looking at projects to contribute to, in terms of sort of feeling more integrated with the team, time zones and things like that can be hard blockers, meaning that especially if you're doing it as a side hustle, like you described for your friend earlier, if they're not in similar time zones to you, the window that you have to actually communicate with those people is then very small. and then it poses as somewhat as a blocker of getting started. Do you feel that that's a problem, and are there any things that you could suggest that might help or ease that issue? And then the second question is, I guess...
take your first one first, because my memory's so bad. So yeah, sorry.
Me too. That's a great idea.
Yeah. Very good question, actually. It's a challenge, is how I put it. And it's a challenge of how you decide to take it. And it's much harder, as you say, when you work in a different time zone and you're doing this as a side project. So when I was in OpenStack, not a problem, because to be honest, OpenStack, of all the communities I worked in, seemed to work 24/7. Really did. You know what I mean? It was amazing. Then when I worked out in Elastic, they were generally in the west coast of America, so I had to adapt. So I often did it maybe when I put my family to bed in the evening. And that's not ideal, but when I needed to drive stuff, you know, what I talked about earlier, collaboration and communication are just the most important things. Nothing beats communication. You know, you get someone on a Slack or you get someone on a quick Zoom call and you just, I don't mean setting up meetings for the sake of it, but you know, in a way, if you can't, you know, someone just go over and back and you go, what am I doing wrong here? And then you get someone on a Zoom call and you have a chat for a few minutes, you go, is that what you were talking about? I didn't understand your Irish English. I didn't understand your funny ways. No, not that ways. But, you know, it's a case of there's always can be a bit of misunderstanding with people, even with your own partner, with your own friends. It's getting someone on a call for a few minutes, you know, because my brother's deadly for texting. And he'd go on for ages just to meet him. And eventually I just pick up the phone and ring him and we've it done. But he won't do it. He decides he has to go over and back. So that's what I mean there. So it's finding the way that works for you. So sometimes you have to adapt, i.e., you know, we can't carpet the whole world for your feet. Sometimes you have to put slippers on. So you have to adapt as well. And that is within reason, but hopefully the community can adapt with you as well. Yeah. And your second question?
Yeah, to follow up on what you said, I find equally that as well as time zone, like there might be a project I'm interested in, and in the past I found though, is that when you do make like sort of a concerted effort to get involved with that community, you don't always, and I think it may be partially part to the fact that some projects are really stretched thin in terms of contributors, but that has the negative effect that they don't have time to sort of reply to your issues or any comments or PRs that you submitted. I feel that's a large blocker as well. Which brings me on, I guess, to my second question, is sort of flipping on its head a bit. What do you think, from your experience with Helm or other open source projects you've worked on, what could those projects do better in terms of making the gate for new contributors coming in more open? And do you see any examples of projects where, as I said, there aren't many contributors and they'd like more, but they're not helping themselves by trying to offer themselves open to be a project that people could onboard themselves onto if they want to?
Yeah, this is a very hard thing to answer, actually, because at the moment, open source communities are struggling for maintainers. A lot of maintainers have been stretched over a period of time, and sometimes when they're not getting answers, it has nothing to do with you, it's to do with people themselves and their lives and everything else. And sometimes open source projects are just being battered with the amount of requests and things coming in. And, you know, maybe for every 10 issue that comes in, there might only be one person who's willing to contribute afterwards or help to contribute. And that struggles, and there's only so many people that can work on a project. So projects are struggling. I don't think it's a personal thing, and I don't think it's more often, I won't say it's all projects, but most projects aren't trying to be unhelpful. It's just they're trying to survive, is what I'd say on that. And we are struggling as a community because, you know, even if you go back to 5-6 years ago, there wasn't that many open source projects. It is proliferating the amount of projects, which is fantastic, but there's only so many people that can work on the projects, and then they have the constraints of their company who's paying them, and then they have the constraints of life as well, you know. And the burnout rate for a lot of maintainers is quite high because it eats into their family time and everything else. So all I can say is, keep at it and see what's community, but I can't give you a real answer on that, or direct answer on that, Can't.
But do you think that coming onto your slide about that sort of taking it for a spin and then making your journey to start, to answer the question, do you think there's a lot of value in sort of creating that wider gate for new maintainers that are coming in behind you? Do you think that's a valuable thing? Because as you said, those contributors that are on stretched teams, they don't have the time maybe to spend like time writing docs, helping other people on board. So do you think sort of like making your first contribution to making that easy route to contribution, do you think that's a valuable thing?
Yeah, I think so. Yeah. I think so. Yeah, definitely. Like it's people, asking questions but willing to help at the same time is key, really. Rather than, sitting on your hands and waiting to be helped. I think that would help a lot in communities. Yes. One, two.
Thank you. Great talk. Thank you so much. My question is, how do you deal with notifications on GitHub? So if you're getting a lot of notifications because your project gets busy or people tagging you. I mean, I get like 2,000 GitHub notifications a day, and I feel really bad that I can't respond to most of them. So it would be great to hear how other people hopefully deal with it.
Can I ask a question? Do you work for GitHub?
I don't know.
You've got GitHub.
I'm a GitHub star, so they send me lots of swag. So,
oh, that's fabulous! It looks good. I don't know. It's very hard. It's. I suppose you just end up prioritizing as best as you can. I suppose the best example I can give is I've had a few things happen in the last few years of my life, personally, and when something serious happens with someone then that's important. Not that somebody can't deploy something into some cluster. I know deploying to a cluster is important, but if someone in your family gets sick really suddenly, then that becomes a priority. So, I don't know, a manager said to me years ago, when I was young, like I said, how do you do all these things? He says, I just prioritize. And that's just the way it becomes. But it is very difficult, and you try the best you can. And, if you were out in the community and you've been a user or you've raised issues and, you're pissed off because you haven't got an answer or got the answer you want, we are all human beings in the community. We're doing the best we can. And, is it life or death? And it comes down to that sometimes, sometimes take a deep breath and just relax and see, right, can we get to this? And, someone that comes in, shouting around and saying, I'm going to lose my job here now because I went deploying this thing and I've been all weekend and this is great. You've got into a tailspin. You need to stop, relax and sit back. Talk to your manager or whatever. Say there's an issue in here. Explain what the issue is. Don't try to keep it all internal and trying to work out everything on the fly and you're not getting the answers. I suppose we have to put things into perspective, but it's not easy. So I'm sorry, that's not a great answer, yeah.
That was really good, thank you.
Okay, so it's time for a break. Go get some coffee upstairs.
Yay.
We'll be back here at past. Just want to say thank you again to Martin.
I really was left hanging there.
I was like, oh. And when we come back at past, it's integrating back up into your GitOps CI/CD pipeline.
I really thought I was going to get...
experience with a key focus on technologies such as cloud native, automation, and data management. His role at Caston,
Yeah.
thank you, is to act as a technical thought leader, community champion, and product owner to engage with the community to enable influencers and customers to overcome the challenges of cloud native data management. And to be successful, speaking at events, sharing technical vision and corporate strategy while providing an ongoing feedback from the field into product management and to shape the future of success. Okay, so over to Michael. Thank you very much.
Awesome. Hey, everyone. Firstly, thank you for coming to a session about backup. It's clearly interesting, or the other session. Well, hopefully you'll stay here. Basically, the premise of the session is to talk about integrating backup a little bit further to the left, making it a little bit more automated so that we don't really have to worry about that. Whether we're on the platform side of things, where we might set our backup jobs to happen every hour or every 30 minutes in a more retrospective way. This is about how do we go from version 1 to version 2 and capture the actual data service that we're building into our applications. So more of a integrating backup into your GitOps CD pipeline. CI, there's another session that I've been doing around restoring the data as part of that workflow, so you're getting the latest and greatest copy of that data by using this method, so that your CI pipeline is actually using good, solid data as well. So, as I was dramatically introduced, yeah, I'm a senior technologist at Caston by Veeam, so I've been at Veeam for 7.5 years, focused on the infrastructure, operations background. Probably my biggest thing this year has been the 90 Days of DevOps repository, so about filling in my own educational needs in a lot of different areas around automation, DevOps, etc. That's what that QR code, but also focused on open source tooling around Canister, Kubester, but really my focus is around looking after data, like gets deployed in various different places. Let's worry about how do we protect it so that we can get it back as fast as possible. I'm kind of like the insurance broker of data, if you will. So if we're going to talk about CI/CD without getting into too much of the weeds, so if we think about CI from a developer point of view, this should all look pretty familiar depending on where you are on your own learning journey. So we're going to create something, we're going to create our application, we're going to use some sort of version control, we're going to build that, we're going to test it, we're going to do all that good stuff. But our focus is when we then come to that release phase. And I think it's important to say is that not every company is going to have that CI model. Not everyone is a software development house, but I believe that from a CD point of view or from a GitOps point of view, we should be releasing software in the same way. As we start to see like the likes of Microsoft and other vendors deliver their software as container images, how do we deploy that into our environments in a controlled fashion? Because the version is going to come thick and fast, or that's the plan, right? We should be developing faster is the whole premise of that. So what we're really going to focus on is how and where do we integrate backup into this process so that our data is safe as we go from version 1 to version 2 to version 3, etc. So if we think about the need for backup, as we start to like use a product, and this is because Victor used Flux earlier, I changed my whole presentation to use Argo CD because we're all about fairness in this community. So I changed everything this morning after Victor's session where he spoke about Flux. So if we think about a stateless application or any application, we're probably going to want to use some sort of continuous deployment tool to get our application into our cluster. Now, if we start implementing our stateful workloads such as Postgres or MySQL, another talk I've done on MySQL, but literally picture any stateful service or stateful workload there. For the demo, I'm going to use Postgres. But then we've got an external user coming into that data, influencing that data, potentially adding, creating more data. And version control then kind of goes out the window for that said data, because we have to start thinking about what that data looks like if we implement changes. But it's kind of a separate version control will not hold all of the changes to that database, especially if you think about a stock app, for example, or a catalog. That's going to be implemented, or it's going to be changed by the actual external user, whether it's internal or external. Hopefully that makes sense. And for the purpose of the demo, I'm going to be using a persistent volume. The database is going to be deployed within the Kubernetes cluster. I think the important part, though, is that this could and maybe should, in some areas, be an external data service as well. Again, going back to Victor's talk, he spoke about using PaaS-based services such as RDS as that external data service. But in terms of backup, it's still part of the application. I still want to be able to protect everything. Now, I'm not going to use AWS RDS today because it takes at least 12 minutes to just trigger the AWS API, so we don't want to be sat waiting for that to happen. But in theory, everything I'm showing could use a PaaS-based service as well. So if you think about it's all about the data, I'm going to say that. I come from a data protection vendor, right? But ultimately, that data is probably the most important part to our company, depending on what that data service is. And you could replace that MySQL, that Postgres, with something like Elasticsearch or something else that is actually important. And for the business, we need to keep that as well. So don't just think of data services as the database in the cluster. Think of it as any data service that has some sort of state. As I said, like that persistent data is not captured in that version control. Now, if it's a static database and we've got all of our init commands to push that data into it, that's fine. But ultimately, you're going to be pushing a database out that's going to have some sort of external use case. It's going to be someone putting data into that database, DBAs, or end users influencing what that data looks like. So if we think about that, any persistent data or volumes used by applications are not captured in version control. I don't know how many times I can say that. Hopefully that's pretty clear by now. But we need to protect the whole entire application stack as well. So it's all well and good. We can go get a point solution if we're using the RDS use case. We can go and protect that RDS instance with an external tool. But when it comes to the application, we're not aware of what that is. So when it comes to backup, we need to protect the whole application, including that external data service is really the key there. I made some notes this morning after Victor's. I've kind of touched on it. Victor says no databases in Kubernetes. Well, bang goes that demo of mine. This walkthrough would also work with RDS, as I mentioned, but time constraints mean that we're stuck with everything inside the Kubernetes cluster. But I will add that Victor did say that, or he mentioned around the evolution of Kubernetes and how we're seeing that the focus around data and APIs that are being developed within the Kubernetes code base is that it's lending quite nicely to data being stored into Kubernetes. It's just a matter of your learning journey as you get more proficient in Kubernetes. So the goal of the demo, when I walk through what it is and actually get to it, and hopefully the demo gods are with me, but as we release a new change to our application, I want to make sure we have a good copy of our data. So dynamically, we can release our application any time. Dynamically, it could be 2 releases a day, etc. But as we do that, I want to make sure that we're taking a copy of that data proactively rather than waiting for that 6 p.m., 7 p.m. backup window that maybe our operations or our platform teams are putting in place. So if you think about the demo, and this is what I have already set up. I don't need to go through how to deploy your data protection service, and I'm using custom because I work there, but really you could bring your own as long as it works from a Kubernetes API point of view. Again, I'm using Argo CD, but you could use Flux, you could use Rancher as well or any CD pipeline, as long as it has that sync wave and that phase play within the annotation that you can use within the YAML manifests. I'm going to use version control. I'm not going to use the remote storage because that takes just a little bit longer to throw the data out into maybe an S3 bucket or something, but know that it is there as an option. Obviously, I'm using a Kubernetes cluster to make all of this happen. So what we're going to do is we're going to deploy our application via Argo CD into our cluster. A stock demo is going to consist of a deployment, pod, services, a PVC. It's going to have a front end. It's going to have a very simple Postgres database that is attached to some sort of external data storage. Then what we're going to do is we're going to commit a change to that, and that change is going to influence what that data looks like in a bad way, because mistakes happen. And I'm hoping as well that if we get to that CD point, we've already run through the Kubernetes jobs or whatever we're implementing has already gone through staging, but the whole premise of this is that I still want to make sure that my production data is in a good state. No pun intended there either. Then what I want to do is I want to release that bad change into my application, which is going to ultimately affect our application or our database. But in doing so, I'm going to trigger, using those sync waves or that initiation of that version 1 to version 2, I'm going to trigger a backup out of the box. It's always going to happen. Then we're going to take that snapshot, and then if I had the time, I'd be also able to export that out to S3, just in case anything bad was to happen inside that Kubernetes environment. So yes, I'm using a snapshot as my first line of defense. I always advocate the 3-2-1 rule, so 3 copies of your data on 2 different media types. So a snapshot is a great recovery point, but it's not the answer, especially if your Kubernetes cluster goes down or it's not available. Then I want to be able to bring it up somewhere else. That application needs to be a viable, or that export needs to be a viable restore solution to another Kubernetes cluster somewhere else that's available. So we're going to sync that back. We're going to make the right change. We're going to fix our problem. We're going to restore our data back to how it was from maybe a version 1. And then we're going to implement the right change that we wanted to do with the Kubernetes job and our data. And then what we are going to do is implement the change that we wanted to do initially, which is I want to add another line item to my stock demo. I think I've jumped massively ahead, but the slides look pretty, so we'll go through it. Restore, so we restore the good copy of the data before the bad change and ultimately get back up and running. But that's enough of the slides. Let's get into some demo. So really the first thing to mention, so this is a GitHub repo. That QR code will take you to this. If you wanted to follow along afterwards, you can absolutely jump through that. And it gives you the instructions on how to play this game, if that's what we're calling it. But the idea here is that we're going to deploy Argo CD into our cluster, regardless of where that is. I'm actually using Minikube here because it's achievable and obtainable for all. And it gives us all of the fundamentals of Kubernetes that we need to use here. So very easily, I would use Minikube here, but actually the hotel Wi-Fi disabled me from downloading container images last night. So I'm actually using EKS, but the demo does work if you've got a good, reliable internet source. So I've already deployed Argo CD. I've deployed Casting K10 via a Helm chart. Now what we're going to do is we're going to deploy the stock demo via Argo CD, and we're going to start going through those, implementing the changes. I'm going to show you some of the Argo CD pre-sync jobs that we have, or the YAML files that we have as part of the process. We're going to implement the change that affects our stock database. Oh no, bad things happen. How do we get that back up and running, and then implement our good change? And if we've got time, hopefully you'll see what that looks like. So all the instructions here. So this is what we're going to do. So our stock demo app, we're going to push it through Argo CD. It's not an Argo CD demo per se, but really it's going to give us our stock demo front-end deployment. It's going to give our Postgres stateful set. It's going to give us a persistent volume, a secret, a service, or a couple of services that enable the application to work. So a very simple demo, simple application. While I'm here, let's copy this. And then we're going to get back to this and we're going to implement the changes. So within Argo CD, in fact, let me show you so that you can see here from a get namespace that we have Argo CD, we have custom, but we don't have anything called stock demo. Just doing the magic before it happens. Okay, so if we go new app and we go stock demo, just run some defaults. Let's auto create that namespace as part of that process. This is where standing up and doing it goes really well. So there's 2 options as well as part of that. If you fork the repo, then you can obviously do your git commits and you can push the data, the changes, or I've made it possible through versions here as well that we can run through version 2 and 3 of the product. But let's go with main. We're going to be lazy and go recursively through the path. We're going to use the local Kubernetes, and we're going to make sure that we use stock demo, otherwise that breaks everything. And we're going to create our application. Now, I've done it as a manual sync. I think another thing that Victor was saying, to be in a true GitHub state, you would have that automatically sync with your GitHub repository or your Git-based repository. and it would automatically go from version 1 to version 2. Purpose of the demo, I'm leaving it as manual so I can show you what each of them steps actually looks like. So all being well, yeah, everything looks good. So here you can see we've got our stock demo and all of the bits, all of the artifacts that I mentioned. So let's kick that off and go to synchronize that. So what we're first going to see, and I'll show you what the YAML looks like for the Argo CD precinct job shortly, is you're going to see this Kasten precinct job that happens first. And in Kasten, you see that we've automatically discovered the application, and you can see there's a backup already going. Now, there's nothing going to be in there apart from we've created a namespace. That's it. So it's going to be very generic Kubernetes stuff that we're protecting. We've not deployed the application, but think of this as a pre-version 1 backup. Like, it's going to happen, but it's not taking up much space at all. But if we go and look at what that Kubernetes YAML looks like, so here's the YAML for the application. If we go into Argo CD, and we've got this sync job, we also have a role binding and a server's account that we use to authenticate. But basically what this does, and these are the important annotations that we use, and this is what allows us to always run that Kasten K10 backup job or export first, is that the idea of a hook and then the wave. So a hook being a precinct before you put any code commits into our application, into our Kubernetes cluster. I want you to run this, and then we're going to use this wave 1, which means before we do anything, we're going to do this. Now later on, when I run the job, we're going to use wave 2, because I always want to make sure that the backup happens first, no matter what. But all this is doing is really calling a simple Kasten precinct or a Kasten backup job, basically a backup action. So when Kasten's deployed, it's deployed with CRD, so it becomes part of the Kubernetes API. So we're basically calling that to create this backup action. You can see some of the detail in there. Again, I'm not going to go through all of that. But basically, that gives us a way of naming what that looks like. And if we jump back into Kasten now, as if by magic, that backup has finished. But there's nothing in there. It took 40 seconds. You can see that there's 7 artifacts, and you can see what they look like. It's basically namespaces, the out-of-the-box secrets that are created, config map, service accounts. And you're going to see that grow as we then actually now have deployed our application. Okay, so hopefully here, everything's good. So what we want to do now is implement that change. Now, for the purpose of the demo, now normally I would jump into VS Code and you'd make that change, you'd create that file, and you'd deploy that Kubernetes, the manifest for the new Kubernetes job. And that's what's listed in here in the README as a step through. So we could do that. Let's see what time it is. Let's see if I can really break a demo. 20 minutes, so we've got loads of time. So basically here, this is us implementing a change that affects our stock database. In fact, before we do that, let me show you the database is now up and running. That's probably a good start as well. So you know what it actually looks like. So get namespace, we should have stock demo. Let's clear that because there's not enough room. Get pods, stock demo. Okay, so hopefully that's clear enough, if not a little bit too clear. We basically have our front end and our back end Postgres database. Pretty simple application. And is that actually forwarding? Who knows? Let's go and check. Looks like it. Okay, and then on the end of this, what I've done is part of the deployment is there's an init. So it goes and creates what we want as part of that init process. So here you see that we've got a list of stock. If someone can shout out a number under 10,000. 9,000. 9,000. Another number.
7.
Oh, we don't want many Kasten K10 licenses. Another one.
780.
It has to be a number. No, I can't put strings in there.
1 billion.
18. Let's do 187 because I heard 7 plenty of times. So let's go and buy that. This isn't part of the demo, although it's quite fun. So you can see here that we've got 1,000 left in our stock. We've got 9,993. easy for me to say, and 9,813. Now, why is that important? Because when we go and implement that change next, we want to take a backup of how our stock system looks now, so that when we implement a bad change, and we'll see that shortly, I want to be able to get back to this as quick as possible so that we know how much inventory we have in our stock. Okay, so let's grab a copy of this. Let's make sure that we're in the Kubernetes folder, although it wouldn't matter because we're doing it recursively. Let's see if I've broken anything. Make sure that's in there. Okay, yep, new stock job. Let's do a get. Let's actually get out of that. Do a get add all. This will not be best practice. We will put a little message in there saying bad demo. Hopefully that's not an omen. And then we're going to push that up to our. This could be fun. Oh, good stuff. Okay, so that should be uploading that change. So if we go and look at our repo under Kubernetes, we should have new stock job. Okay, and now if we go back into here, because I set that to manual from a sync point of view, let's go and do that again. Synchronize. But again, first of all, we're going to see that backup job kick in any second now. Any second now. Yep. And now this is going to change because now we've implemented some data, right? So now we've got version 1 of our product up, so we're taking a backup of version 1 and whatever the changes were that we made. So we're taking that backup dynamically. We haven't waited for that backup window or that scheduled backup that operations might have put in place. This is just a dynamic way of making sure that we've got a good copy of that data before we implement version 2 or the next version of, or just a change within our application. So you can already see that it's changed quite slightly, is that we're taking application consistent copies of that data. I'm not going to get into how we're doing that. There's a canister.io is an open source application framework that allows us to dive into the data service. So things like Postgres, pgdump, allows us to go and coerce that workload so that we're getting a good clean copy of that data as well. So we can do that here as well. And already if we look at the artifacts, you start to see a little bit more going on, like there's actually the stateful sets, the deployments, and that gives us the ability to just bring back the whole application as we need to. So if we now go to our product app, he says, if I've implemented the bad change, oh, hang on, I'm too keen. Let's make sure that the jobs actually run. Get, no. So new stock app is container creating. Should be done by now. Okay, completed. So if we go back to the browser, back to our mission critical stock app, and we've accidentally zeroed everything out. We've added too many changes. We've basically messed our database up. And if I go and look at that, what that new stock job looks like, you can see here that maybe someone has just left this in as part of a template. Like we've zeroed everything out. What we actually wanted to do was insert a new product into our system, but maybe not familiar with it or whatnot. Mistakes happen. It's not always ransomware that causes data problems. Sometimes it is just accidents, probably more so than anything. Okay, so we've recognized that that's our mistake. So we've taken a backup of that. So let's jump into Kasten. Let's take a quick restore of that to get it back up and running. You can see that we've got 2 backups. So one will be that back to pre-version 1, and this one's taken us back to where we made those changes with all your amazing numbers. And what this is going to do is basically restore not only the code base, but also the the data. Probably the most important part is the data. But what we've also got in here, and I did this for time more than anything, as part of that restore, we can be granular about what we recover. So we can say only bring back the data. So only bring back the PVCs that we have, or if it's an external data source, only bring back that particular component of the backup. I just hit everything because it's easier to get everything back up and running at that point. Plus, I've padded enough now that hopefully that's also finished. So you can see here that we've already, well, if we look up here, you can see that we turned off the existing stateful set, or the pods that are built up of that stateful set, as well as the front end. We did our restore, and hopefully, eventually, the Postgres will come back up. We kill this port forward, bring it back up now. And if we go back in, we should be back to where we were before, right? With the numbers that you gave me. Hopefully. Okay, phew, good stuff. Yeah, do they look like the numbers? Good stuff. Love a live demo. Okay, so now we want to fix it. We need that new line item in there, right? We need that new product. We need that new license. We need to start making revenue for the business, because that's why we're all here. We all need to make more money for the companies that we work for, right? So with that, let's jump back in here. Now, did I put the proper, yeah, there it is. But what I need to do first, if I'm doing this, is that I need to remove new stock app. Otherwise, we're going to be in the same jam again, right? So let's remove new stock job, and then let's go and create this new Kubernetes job, which is going to do the correct, if I can just show you here. Yeah, it's above that. I'll show you in a second. So let's do a get add, and that's going to remove the new job and put in the correct stock job that we want. Get commit. Good demo. It worked demo. Get push. Hopefully that's already cached. Yeah, good stuff. Okay, so back into the browser. Confirm what we've got. Into Kubernetes, correct stock job, no new stock job. We've basically made the change. Now, obviously at that point, the job might have just been edited. So we might have changed that new stock job to be a different version of that Kubernetes job. For this, I'm just highlighting what we're doing here. I'm just removing that bad implementation, that accidental problem, and putting a new one in place. So, which is going to hopefully create our new line item. So let's go back and manually synchronize that again. Again, as if by magic, he says, should start another backup. Good stuff. So again, this is going to be another good backup that represents good data. We've never taken a backup of that, the zeroed out, the line items that changed. Hopefully this is emphasizing how easy it is to just implement this as part of that pipeline, so that if you're pushing data services out into your environment, you're seeing that that's just a simple add that anyone can take advantage of if you're in control of that CD pipeline, as well as the operations team that might still want that nightly or that daily or that monthly, weekly backup, right? It doesn't interfere with that. Okay, and then once that is done, you can see there that we've got that Kasten precinct. So in Kasten, come on. It's got to beat 1 minute, 6 seconds. I'm sure I had more padding time then to talk about something else. Okay, cool. Phew. Okay, and you see now that our correct stock job is now up and running. It's creating that container, bringing that container in to run that, ultimately just run that job. I've done other talks that are similar where we're diving into MySQL to show all of this. It's actually a pet clinic, but I thought actually the web front end made for a better demonstration and using Kubernetes jobs to implement the change, whereas before I used a config map and then integrated with that. Okay, so that's done. So when we go now to our stock app in the browser, if we hit refresh, so the plan is, I haven't hit it yet. The plan is that we should see a new line item that just appears there for Salesforce. Okay, good. And all the same numbers, so we haven't affected, we've just implemented that change into our data service, into our application. Okay, so I think that's enough demo for me. So just to kind of finish off, I'm not sure what time we're on. Yeah, probably about 10 minutes, so enough time for questions. So if you did want to follow along, that QR code is there again. I've kind of highlighted a lot of these like little fast tutorials as project pace. So just getting up and running a data service within Kubernetes, running a data service within Amazon RDS, and running the same like Argo CD, and having that playground to be able to run this. So that's just one of the options that I have in there. There's other repos around project pace as well. The other plug, and this is the only thing I'll talk about Kasten from an educational point of view. We started last year at KubeCon NA, this learning resource about learning more about Kubernetes, and it goes from very rookie level to very pro level. We've just done a monitoring, so getting hands-on with PromQL, because who doesn't love a bit of PromQL, and then Grafana dashboards and how we create that, how do we create notifications, and how do we implement or integrate that into our Slack messaging or into our emails. So that's on the left-hand side, free resource, and then like I mentioned at the start, that QR code on your right-hand side is the repository that I started at the very beginning of the year, because who doesn't want to start a project on the 1st of January? Was really about filling a lot of gaps around DevOps as process principles, but then looking at the tooling that goes inside of that. It's there's an interesting take around that whole piece, but it basically breaks down DevOps not in its entirety, but it looks at 12, 13 different areas around that area, around DevOps, CD, infrastructure as code, configuration management, Kubernetes, containers. I know a few people have already mentioned it last night and this morning about sharing that with teams. It was just my notes, and it just kind of got up to 18,000 GitHub stars, which is absolute bonkers, and then got translated into different languages. So, yeah, a big pro to learning in public, like put your notes down somewhere visible so that people can learn from it, is my only takeaway. I didn't start it in that. I didn't have the logo before I started the project like I do most of my projects. But yeah, with that, any questions at all? Yes, Victor. I was going to say apart from Victor, but
okay.
No, you're good. You're good.
No, how are you triggering the backup? I saw whenever you deploy something, a backup is triggered. Is there some event or a manifest in that? Or
yeah. So within this Argo CD folder, we create this pre-sync job, which is ultimately a batch file that calls upon the Kasten backup action, CRD, that when Kasten's deployed, it becomes part of the Kubernetes API.
How do you see this being used in production? So an example for us, to do a backup job of our database takes about 3.5, 4 hours. And if we kind of had this pre-sync job as a part of our continual deployment pipeline, our deployments would take more than a day. So is this being used, that sort of scale? Are people doing that and kind of extending their deployment pipelines to build a backup stage into it?
So the biggest problem is the time. The size of a database, that size of the database, you can imagine, is very minimal in size, so that I can get it into the demo. But exactly that, like Postgres database is up to terabytes of size. We do have customers that are doing this, also using Canister as part of that drive, who want to use open source and that tooling as well. People are doing that. It's the sacrifice that you make, right? If you're, and I guess it comes down to your process and principles around changing data as part of your application, your deployment. If you're not, then maybe the backup at 7 p.m. every night is the right way to go. But this is just an option for, I would say that all data potentially is mission critical, so you have to afford that 3 hours to take that. There's no magic button. We have to lift and shift data from A to B. So I think it comes down to what that data set is, and then how you want to, like, how important it is to take that. Is it important to take that backup or not? That doesn't really answer it. I think it all just depends. The other way that I've seen it, and I think I mentioned it at the start, is actually flip this in reverse, and now where you're using CD to deploy potentially your Kubernetes clusters for your developers, and they need some sort of data, flick that restore action, that backup action to a restore action, and now we can restore data into those namespaces or wherever you need it to be, so that they've got a good copy of last night's data. And as part of that, we've got the ability to put in pre and post sync hooks, so we can then start to integrate, like masking that data, so that your developers don't have that sensitive information. I've got more data scientists using that than this process. Even though we always start our conversation about casting K10 around backup and restore, there's a lot of other use cases that we have in there. Hopefully that helps.
That's one more.
Hi, Michael. Good one. At the beginning of the presentation, you mentioned that this could also work for external data sources, right?
Yes.
What would you say, for example, if you're using RDS, would you still recommend using this approach rather than the kind of cloud-native approaches that cloud providers would offer?
So I think it comes down to when you come to recover, like, so we can back up RDS using a different product completely outside of Kubernetes. And that'll be great. It'll bring back your RDS database, no worries. But it wouldn't be aware of anything application-wise. It wouldn't have any visibility of what's going on inside the Kubernetes cluster. So if that works for your application, i.e. it's just a static database that holds some information and you just want to restore it back to the last known good configuration, maybe that does work. But if it's an application a bit like a stock app in real production, maybe you do want to integrate the whole application, including the RDS, and the way in which we connect to that and be able to protect it. And I'm sure this is actually from a production app point of view is using config maps and secrets to get to that RDS. So we just leverage those if we've got the rights to do that. Does that help?
Yeah, absolutely. When you say capture the whole application configuration, what does it actually capture? Like when you say snapshot, what does that include?
Yeah, so when we trigger the AWS, so RDS in particular, we leverage the AWS API, we trigger an RDS snapshot over there, but as well as doing everything that basically I just did in this demo to capture the application inside of the Kubernetes namespace. We do it on a namespace, so where we have the dynamically discovered applications, a very marketing thing, but basically these are namespaces. Now we can pull together those as part of, like, we can use labels to pull in multiple resources from different namespaces. So you can absolutely get very complex on it. But the snapshot point is exactly that. We're leveraging the underpinning storage on the Kubernetes cluster to create a volume snapshot. Then we have the export copy that will allow us to take it out to object storage or an NFS server or a Veeam backup server if anyone ever uses that. But yeah, so that's the premise behind. The reason why I use just the snapshot is pure speed. Otherwise, we'd be waiting for a little bit.
Cool. Thank you.
Cool. Thanks for sticking around.
Any other questions?
Okay, so we'll just put our hands together. Thank you very much, Michael.
Awesome. Cheers.
Okay, we'll start in a couple of minutes, but the next talk is Securing Kubernetes with Open Policy Agent. He is a software engineer at VMware Carbon Black. He has a strong engineering background, having previously worked at market leaders in multiple industries, from payments to cloud and infrastructure provisioning. At VMware is helping define the future of container and cloud security. The Kubernetes ecosystem is interesting to him because of his elegant solutions to real-world problems and constant drive for innovation. So can everyone put your hands together for Anton?
Thank you. Thank you for the introduction. So I'm Anton. I work for VMware Carbon Black, and I work on a product for Kubernetes security. And this topic is something that is really interesting to me. I'm really passionate about it, and it's obviously what I'm talking about today. So on social media, you can find me on Twitter and LinkedIn, or on my blog, where from time to time I write articles about Go and Kubernetes. Now, what is on the agenda for today? First of all, we're going to talk about why do we need Kubernetes security at all? Why is this something that we should care about? Then we're going to talk about the different aspects of Kubernetes securities. Then we're going to try to implement some of these aspects, and in the end we'll see how these two open source projects, Open Policy Agent and Gatekeeper, can help us in this endeavor. And we're going to finish with a short demo of some of the things that I talked about. So why do we care about Kubernetes security? After all, some of you might say that Kubernetes is just a container orchestrator and it doesn't need much security. If you say this, you might be right, but there's a better chance that you will be wrong, because over the past 8 years since Kubernetes was introduced, it became much more than an orchestrator. It became a platform. The reason for this is that Kubernetes was designed to be highly extensible, so people started extending it and using it for more than it was originally designed to. And now we're using Kubernetes not only to orchestrate containers, but also to orchestrate storage and basically any other type of resources like ingresses, certificates, secrets and configuration, and so on and so forth. And if you want to build a secure application, you cannot really do that on an insecure platform, because each system is only as secure as its weakest link. And I've listed here some bad things that can happen if an attacker got access to your cluster. Obviously, if someone gets access to your cluster, they can deploy malicious workloads. They can try to steal your data, to use your compute resources for bad things like ransomware or crypto miners. And if they leverage some vulnerability in the container agent, they can get access to your whole infrastructure. I was going to talk more on this slide, but there was a great session this morning by Andrew about hacking Kubernetes. So if you're interested in bad things that can happen to your insecure clusters, just rewind the recording of today to this session and watch it. It was really, really interesting. Cool. So now that we established that Kubernetes security is important, let's talk about how actually to approach this. And if you have no idea how to approach Kubernetes security, a good place to start is the Cloud Native Security White Paper. This is a white paper published by the CNCF. It talks about the best practices in Cloud Native security. It is not exclusive to Kubernetes. It talks about all Cloud Native deployments, but we can take a look at it from the perspective of Kubernetes. And according to this white paper, there are 4 main areas to Cloud Native security. Everything starts in your IDE on your laptop. This is the develop phase. And this includes all the things that you're running locally, all security linters, scanning tools, the tests that you're running locally, that kind of stuff. The second step is a distribute step, which starts whenever you push your code to version control. And what usually happens there is a build pipeline gets triggered, your container images get built, that kind of stuff. And the things that are included here are how to secure this process. We're talking about image scanning, manifest scanning, scanning for vulnerabilities, for misconfigurations, artifact signing, and so on and so forth. The third step is the deploy phase, which is when we already have our artifacts built and we are ready to run them in our environment. And as a good practice there, it's good to have some pre-flight deployment checks for your resources. This again includes having visibility inside the container images that you're running. For example, you might want to have some rules that you don't want to deploy containers that have too many critical vulnerabilities. or you want to protect from misconfigurations as running containers as root. And it's good to have some sort of enforcement so that you're sure that workloads like this won't get deployed to your environment. And the last step is runtime. Here, the most important thing, according to the white paper, and I agree with this, is observability. Observability is quite a buzzword and it can mean a lot of things, but what it means for me is knowing what's going on inside of your workloads. Knowing what network connections your workloads are making, what processes are running inside your containers, that kind of stuff. And once you have good observability, you can do anomaly detection, which is using this information to detect anomalies which could be symptoms of an attacker that managed to get access to your environment. These 4 steps constitute the overall cloud-native security landscape. And in my opinion, it's pretty important to have some sort of security implemented for each one of these steps. Because as we said, the system is only as secure as its weakest link. So let's try and implement some security. This landscape is quite big, so I cannot really implement everything that I showed you in the previous slide. So I will try to focus on only one area of this. And this is the deploy phase, where we want to implement these pre-flight checks that I talked about. So we're going to implement one such check, where we want to enforce rules for our Kubernetes deployments. By deployment here, I mean the Kubernetes resource deployment, not something else. And what we want to do is we want to have some set of rules which we are checking each time someone applies a deployment object to our API server. And if an object violates these rules, it should not be created, it should be denied. This is how we can protect from misconfigurations. Now, Kubernetes doesn't have like an out-of-the-box solution for this, or not entirely, but it does have a rich toolbox which we can use to implement this. And one thing we can use is validating webhooks. This is a mechanism for deploying additional validation logic for our Kubernetes resources. Basically, what we can do is we can write a webhook, we can register that into Kubernetes, and then each time that we are interacting with a certain Kubernetes object, in our case deployments, Kubernetes will call this webhook. It will pass in the resource in the request, and it will expect a response from the webhook saying whether this resource should be allowed in the cluster or not. And of course, the implementation of the webhook depends on the rules that we want to have. Architecture, it looks something like this. This is quite simplified diagram, but it will do. So we have a user that is trying to create a deployment. They are using kubectl. They are applying a deployment.yaml file. This goes to the Kube API. It passes authentication and authorization checks. And after that, it goes through all the validating webhooks that we have created in our cluster. And as we said, if any of these validation webhooks denies this request, Kubernetes will respect that response, and it will return an error to the user. And it will never create this deployment in our cluster. If none of the webhooks deny it, if all of them allow it, this deployment will eventually be created. This is how the validating webhook resource looks like. It is of the validation webhook configuration kind, and it has 2 main important things here. First is, when should this webhook be called? Kubernetes has a lot of resources. You have deployments, services, ingresses, jobs, you name them. And it doesn't make sense to have a master webhook for all the resources, because usually you would have different rules for your different resources because they are different in nature. So it makes sense to have different webhooks for the different resources that we have. And with these views, we tell Kubernetes that this webhook is only valid for create and update operations on deployments. So Kubernetes will only call this webhook when we are creating and updating deployments, not when we are doing something else. And of course, the other important thing is where is this webhook located. So this is just an URL, and Kubernetes will call this URL when it wants to invoke the webhook. So should we all start writing our own validating webhooks now? The answer to that is not necessarily, because we can use two open source projects to help us write these kinds of checks in a faster and easier way. The first one is called Open Policy Agent. This is a general purpose open source policy agent. It allows you to write rules in the Regu language, which you're going to see in the next slide. And once you have rules, you can supply JSON input, which gets evaluated against these rules, and in the end you get JSON output. It is quite general purpose. You can use it for absolutely everything, and at this point it still doesn't have anything to do with Kubernetes. This is how a really simple Regu policy looks like. We have a package name, then we define a variable called allow, which by default is equal to false. And on the bottom we have something which I call reverse if condition. So what this statement means is that if the thing in the parentheses is true, so if in the input we have an object named conference which has a name equal to KubeHuddle, we are going to set allow to true. And if we supply this input to this policy, in the output we are going to get this thing, because this statement here is true, so we evaluate the statement on the top, and in the end we get allow equal to true. If we change the input, this thing here never gets evaluated, so so allow will be equal to false in the output. More complex but still quite simple Regu policy is this one, where we now have two checks. We check first for the name of the conference and then for the venue. And if these are wrong, we output a message. So for this input, we get this output. This policy may look correct, but it's actually wrong, because the way these Regu rules work is they're just chained end conditions. So this rule, it will evaluate to something like this. So if the name is not KubeHuddle and the venue is not Edinburgh, we are going to set the message. But this of course means that if only one of the fields is wrong, we will never output any message. So there won't be any violations, which is wrong for this case. If we want to correct that, what we need to do is we need to change the policy a bit. And the way to change it is this one. Now we have split the policy into two rules. The first one that checks for the name, and second one that checks for the venue. These rules are evaluated independently. So even if only one of the fields is wrong, we will still get a violation in the end. And if we have two of the fields wrong, we get two violations. If we correct the venue, we only get a violation for the name. This was about OPA, but as I said, OPA doesn't have anything to do with Kubernetes. It's just a general purpose policy agent. So we need to have something that will basically be the bridge between Kubernetes and the open policy agent. And that thing is called Gatekeeper. This is basically a first-class integration between OPA and Kubernetes. Gatekeeper implements a validating webhook. It provides that to you. And for the implementation of the webhook, it uses OPA. Gatekeeper also creates a few CRDs in your cluster, so you can actually register your Regu policies as Kubernetes resources. The architecture looks something like this. So again, we have a user that's trying to create a deployment, and then the Kubernetes API will call the Gatekeeper validating webhook. It will pass in the deployment object as JSON. Gatekeeper will fetch the policies which are already stored in Kubernetes. It will pass them to the open policy agent, and in the end, based on the decision of open policy agent, it will return a response to the Kube API saying whether this interaction is allowed or not. The two CRDs that we're going to use are these ones. So first we have the constraint template, which actually wraps the Regu policy. And then we have the constraint, which shows when and how to invoke the constraint template. In more programming terms, the constraint template is a function that describes the policy, and the constraint shows when to invoke the function. If this doesn't make sense, don't worry, because you're going to see it in practice in 1 minute. And let's go and write some Gatekeeper policies. What we want to achieve is we want to write a policy that will reject deployments that run as root. And a deployment runs as root if it has containers that doesn't have a security context, or have a security context but doesn't have run as user set, or have the run as user field set to 0, which is the root UID, and it's also the default value. So we want in all of our containers to have security context and to have run as user set to a field different than 0. And let's actually go and implement these policies. I have here a Kubernetes cluster. I have already installed Gatekeeper. You can see here the Gatekeeper pods. This means that I already have the CRDs. So I have here the Gatekeeper CRDs. And I also have a webhook. This is the Gatekeeper webhook. And now I need to create constraint templates and constraints. So for the constraint template, I have it here. This is the constraint template that we're going to use. The important thing here is the review policy, which is here. And we see that we have 3 rules. The first one will output a message if the container doesn't have a security context. The second one will output a message if the container doesn't have the root as user field set. And the third one will output a message if the container has the run as user field set to 0. So we can create this constraint template. And now actually, if we try to create a deployment, none of these rules will be evaluated because they're still not active. In order for them to be active, we need to create another object, and that is the constraint. Let me apply it first. This is how the constraint looks like. This is a type, which is actually another custom resource that got registered whenever we create the constraint template. You see here the kind of this custom resource is no run as root, and we actually specify the kind here. So whenever we create a constraint template, this will create a new custom resource which will serve as the constraint. And here in the no run as root resource, we specify that we want to invoke these policies only for deployments. And now I have here a YAML file that has 3 deployments that are not compliant with this policy. So first I have a deployment that doesn't have any security context. Then I have a deployment that has an empty security context, so it doesn't have the run as user field set. And then I have a deployment that has the run as user field set to 0. So all these deployments constitute a violation of our policy, and we should not be able to create them in our cluster. So let's see what will happen if we try to create the deployments. So we see we got three errors. So what happened is basically what you saw on the slides. We made a request to the API server to create these 3 deployments. The API server called the Gatekeeper validating webhook. The webhook used OPA to evaluate the policy, and since this policy evaluated with a violation, Gatekeeper did not allow to create these resources. And you can see actually here the errors that we set in the policy. So we see this container doesn't have a security context, this one doesn't have the run as user field set, and this one has the run as user field set to 0. And actually, just to be sure that they are not created, I can just list all the deployments in my cluster, and we see that we don't have these deployment created. Now I have another deployment which is actually compliant with this rule. And as you can see, this one has a security context, and it has the run as user field set to 1, which is compliant with our rule. So let's try to create that. And actually, this deployment got created. So here the workflow was the same. Again, the webhook was evaluated, but because this deployment doesn't violate our rules, it was allowed by the Gatekeeper webhook. So it was eventually created in our cluster. So this was the demo, and before we finish, I actually want to talk about some of the alternatives to what I showed. First of all, you can obviously write your own validating webhook. If you know what you're doing, you can write the webhook in probably 1 or 2 hours in your favorite programming language, and deploy it in a cluster. The hard part of things comes when you have many rules that you want to enforce and many rules that you want to manage. And maybe in this case, it will be easier to use something like Gatekeeper for easier management of the rules. Another alternative is called Kyverno, which is another policy agent. It again uses CRDs to enforce policies. I haven't personally used it, but I've heard good things about it, so you can check this out as well. Another thing comes with Kubernetes. It's called Pod Security Standards, and it replaced the already deprecated and removed pod security policies. This is a set of standards which you can enable for your pods, and they perform checks similar to the one that I showed you. Basic misconfigurations like running pods as root, or allowing privilege escalation, stuff like that. They're not that flexible as using OPA, because with OPA you literally write code that will evaluate your resources, so you have all the flexibility in the world. The pod security standards, they're just standards which you can either enable or not. So if they work for you, you can use them. If you want something more flexible and something that doesn't have a template in the standards, you can use something like Gatekeeper. And of course, you can use a proprietary product. There are a lot of proprietary products that work similarly to what I showed. Some of them even use OPA under the hood, so you can also use one of these. If you found this interesting and you want to learn more about OPA and Gatekeeper, the first thing you can do is you can check out the links on the slides. I have referenced most of my sources, so you can do that. You can also check out these talks about OPA, which I have linked. Some of them talk about OPA and Gatekeeper, so they have more Kubernetes context. Others talk about just OPA as a policy agent without any of the Kubernetes stuff. They are all interesting, and you can learn a lot from them. And of course, the best way is just to get your hands dirty, go write some policies, and see what happens. As a summary, Kubernetes security is important. You should not overlook it. Validating webhooks provide an easy way to plug in your own logic for validating your resources, and Gatekeeper and Open Policy Agent can help you in that. And with that, I can take questions.
Hiya. Is it possible to move it further, like earlier in the development cycle, so that the CI step in a PR could maybe reject a bad resource?
Yes, absolutely. For this, you don't need Gatekeeper because, as I said, Gatekeeper just provides the Kubernetes plumbing. You can just plug in OPA in your CI, so you can have your policies there, and you can just OPA has a COI. It also has an SDK. So you can use this in your CI. And you can actually find a way to maybe reuse your policies between the CI and your cluster. Because even if you have it in the CI, in my opinion, it's good to also have it in your cluster, because someone might go manually create some resources if you don't enforce this on the Kubernetes level.
Also, I just want to ask a question so he doesn't have to come back out quickly. No, I'm kidding. So OPA looks super powerful, but I don't want to write JSON. That looks really hard to write and error prone. What would you suggest? Is there another abstraction layer that you would suggest that can leverage OPA for me? Because that looks really hard.
Yeah, first of all, you don't write JSON, you write Rigu. You talked about Rigu. Rigu, okay, yeah. Yeah, Rego, yeah, it's a nice language, but it has like a steep learning curve. It can be quite confusing in the beginning. If you don't want to do this low-level stuff, I don't know. Maybe first of all, maybe you can just look up some policies online, where you can like some library, for example, which you can reuse. And the other option is to use a proprietary product, because yeah, most of these proprietary products, they just have a checkbox like I want to enforce this rule, and you just select it and they enforce this rule, and they have many rules. So yeah, that would be.
Thanks for the talk. Say I don't mind writing Rego, but I don't want to write security policies in multiple places. So obviously Kubernetes isn't the whole story. I also have cloud infrastructure and stuff like that. Say I want to write policies in the one place that say your container can't run as root, and also don't deploy any public S3 buckets. Is there a way that I can use OPA to go beyond Kubernetes and cover all my security policies?
Yeah, you can cover absolutely everything with OPA. As I said, it doesn't care about Kubernetes. It just cares about you have some JSON inputs. This input has some fields. You can write policies for these fields. So you can write absolutely all sorts of policy for with OPA. And actually, one of the reasons OPA was when it was invented, it was to have one policy agent for all your policy checks. So you can use it for Kubernetes, for your cloud resources. You can write authorization policies with OPA. Basically, you can plug in OPA anywhere just because it's so generic.
Thanks for the talk. On your demo, the first deployment that you did would have actually failed all three of those requirements of the policy template, but it only spits out the first non-compliance. Is there a way to get it to give you all of the non-compliances? I'm thinking on larger policies, you might want to revisit that deployment YAML once, or the manifest across quite a large repository once, and fix all of the issues. Is it a default stop if found?
So you mean that in the first deployment, if we just put in a security context, it will fail the next check?
So it doesn't have a security context,
Yes.
but it also doesn't have a security context with runners root,
Yes.
or a security context with runners root 0.
Yes.
So it actually fails all three checks, but you only get a single error message for the first one that it found. Is there a way to get it to spit all three of those results out?
I'm not really sure, and actually I'm not sure that it will fail the other two policy checks. Yeah, actually I need to check that, because if you see that it's a different, I'm checking here in a different way about these fields. I'm not sure that the first deployment would fail these two. This was something that I was playing around while preparing the demo. Yeah, because of the way, like OPA would not throw like a no pointer exception or something like this, but I think that it's designed in a way that it would actually wouldn't fail this check if you don't have a security context at all. Yeah. Actually, there is one other way to perform this check. I didn't show it, but I have it here. So this is is the same rule, but now we have here runs as root check, and we have runs as root defined 3 times here. So this basically it will evaluate to true if any one of these is true. And if I apply this constraint template and rerun the deployments, they will again fail, but it's just another way to define these rules.
Okay, let's stop there. Can everyone put hands together for Anton?
Okay, thank you.
So it's now lunch. You'll be glad to hear that's a very difficult slot to fill, mate. So well done. Back at 2 o'clock in this room. I'm not going to read out what's next, but yeah, 2 p.m.
I can't count. When you switch off and just keep counting, I've often found myself skipping out whole numbers, and I'm like, oh. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Nine, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. 51, 52, 53, 54. This is scintillating stuff. This is the best talk of this day. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Still keep going?
Just a couple more seconds.
1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry?
Happy with that.
Thank God. Sorry about that.
Sound like a guy from View Cinema, if anyone knows what that is. Did everyone have a good lunch? Yeah, good. Awake? Fueled? Caffeinated? Nicotined? Saw some people out there. Yeah. Okay, so now we've got Mahe up. He is going to talk, I lost it, hacking Kubernetes like a beginner. Mahe is a security engineer, security R&D engineer at Quarks Lab, specializing in Kubernetes and container security. So let's hand over to and make him feel welcome.
Thanks. So yeah, today we are going to hack Kubernetes the easy way. So with KDigger, a small tool we release at my company called Quarks Lab. So it will be, for those who attended, it will be a bit less advanced than Andrew morning presentation. So a little bit about me. So I'm Mae. I'm a security R&D engineer at Quarks Lab in Paris. I participate from time to time to SIG Security and SIG Docs, and you can find me on Twitter at mtardy. So I wanted to start with this thing. So this is vulnerabilities related to containers for the early 2022. This is kernel vulnerabilities, dirty pipe, for example, and some runtime vulnerabilities that actually allowed to do container escapes. Recently, the community created the official CVE feeds for Kubernetes, so now you can basically get a source for all your CVEs related stuff directly on the Kubernetes website. But today we won't actually need these things because for us, for beginners, Kubernetes security starts with configurations, with problem with configurations. So I decided to create a new tool, KDigger. So why a new tool? I participated to some CTFs, observe the habits of people in the field. And I really loved MyContain by Jesse Frazell. Some people might know it. So I was like, why not automating a security checklist from when you're inside a pod and doing a pen test? So what can KDigger do for you? There is plenty of stuff here. So on the left side, you have some stuff that MyContain can do for you already. So I re-implemented this kind of stuff, some very basic stuff that is included in the checklist. And there is, like on the right, Kubernetes specific things that you can use with this tool. So yeah, I won't go on all the things it can do for you. We'll see a little bit later. So just few precisions. So yeah, some checks rely on implementation details. For example, when I investigated MyContain, I realized that the PID namespace detection was not working anymore. It was relying on some kernel implementation. It was not working. And just for example, I abused the coordinates wildcard feature in KDigger to retrieve all the services that were running in the cluster. And since Kubernetes 1.25, it's no longer working because they updated to 1.9.5 or something like that. So yeah, some things break, so we have constantly to add new stuff and replace and repair this stuff. So let's do a demonstration right in. So this is the simplified infrastructure. It's way simpler than this morning for those who saw that. It's only an application that might be vulnerable with other applications running that are hardened. The issue here is that they are collocated. They are running on the same clusters. So yeah, disclaimer is going to be way easier. I hope people will all follow this one. So yeah, let's go. Hope it'll work. So let's just run our script. Yeah, you will see how I will type very fast. So you're on your, you just bridge the web application, you found a reverse shell, and now you can type whatever you want. So first, you just want to see a little bit where you are. So this is like a Linux file system, basic one. You are running as an unprivileged user, 1000, okay. And there are a few processes running here. So the first one is, of course, a web server, as you see. But there is like only 3 processes in this thing. So the idea is to realize that maybe you are running inside of a container, and a good idea would be to download KDigger to see a little bit more about the environment and recognize a lot of stuff quickly. So let's do it. Because you are working in security, you are very serious, and you will download with curl. You will download the SHA-256, verify that it matches, and then install the tool. Yeah, it worked. So Here you can see that kdigger is basically a CLI tool, a basic one. The main command is the dig command. It allows you to use the different plugins to dig into your cluster. And first, what we'll see is different plugins that are available. So there are a few. I will go to some of them quickly. So the first one is the admission scanner. So basically, it allows you to create pods and see if the admission was protected. If the admission is like protecting you for creating privileged pods that are mounting the host file or things like that. You can list the API resource, check your authorization, check the capabilities of the process running, retrieve information about the C groups. It can leak information, retrieve the cloud metadata information. So this can actually be very helpful to know on which cloud you are running. There is this new one, container detect, which I basically implemented a few checks that we discussed on Twitter with some friends to actually detect you are running inside of a container or on a real host. You can basically just list the devices, the environment variables, and so on. So let's see what we can do with that. Yeah, I just wanted to show that you can format it to JSON. Magnificent. So yeah, first things first, let's check if we are indeed running inside of a container. So it implements just a few checks. They are really basics. So for example, systemd is running as the PID one. It's not always the case, but it's really often the case on host. Kthread is not the PID2, etc., etc. So here we are giving like 3 hints that we might be running inside of a container. So that's fine. So let's check if we are running inside of a container that is in a Kubernetes cluster, in a pod. And what we can check is the environment variables because they are populated in each containers. So this is with this information, we have like a lot of clues that we might running inside of pod. So let's try to talk with the API server. If we talk that, we see it's version 122. So it's a bit old version, but fine. And we can try to leak some information. So here in the C groups, it no longer works with C groups v2, which are implemented now in Kubernetes. But with this one, you can see that we actually leak some information about the container runtime. We can see it's Docker that is running under the hood. So it might be interesting. So let's see the next step for a pen tester in a Kubernetes cluster that just got a shell is to see if we are running in a privileged container. Because basically, if you are running in a privileged container, you are just running as root on the host, so you can do a lot of stuff. So let's check. Here we see that we might not be running into that kind of container because we don't get a lot of capabilities on our process. So let's investigate. If we cannot go onto the host, maybe we can retrieve a token here and create a privilege pod to escalate. And here indeed, we have a service account token, which is pretty normal, like it's auto-mounted by default at the moment. And we can find the token certificate and the namespace we are in. So with that in mind, yeah, you can also retrieve the token like this. What you want to do next is check the capabilities of this token in the cluster. So check the authentication. I think a few people here will recognize exactly the kubectl auth list. It's just the implementation inside of kdigger. And some people will say you don't even need kubectl to do that. You can just do it by hand with curl. Of course you can do that. It's a bit long though. Happily I wrote super fast, so it will be okay. But yeah, you just have to write a bunch of URLs, write a bunch of JSON, and then it will be okay. Yeah, so fast. So here we retrieve the same information. So the idea from now is that maybe we can just create that new pod just to check. We can check if there is like our Arden app that we can see. Because and one information I skipped, sorry, is that we can basically exec. So if we can exec in this namespace, maybe we can just retrieve the pod of the Arden web app and escalate to that place. But now we cannot get all the pods, and in our namespace there is only the web app and the SQLite, which is the database of the web app. So it's not that interesting. So what we want to do now is to try to scan the admission controller, because the idea is that because you can create a pod, it's not everything. If the admission controller is actually preventing you from creating a privileged container, it will be impossible for you to escalate. So let's scan that. Yeah, the tool just reminds us that because we cannot delete these pods, we will actually create new pods that will be here forever. So it's not like super discrete. So we can just force that. And we can see here, it's perfect. Like we can create anything. Basically, this cluster is running like with default settings. We can create a auth pass pod, a privilege pod. We can see, I can show you that the pod were actually created in the namespace. So those were the artifacts from that scan. So it's, of course, not super discrete. So next step, I added a little stuff to KDigger is that now you want to create that privilege container. So I added like a little template manifest generation tool to actually create those things. So you can basically use KDigger, generate a privilege in a host pass container. So now you have that pod with all the settings used. But for the sake of demonstration, I will just use a little script I use. So it's Node shell, so maybe you might know this one. I just modified it a little bit to get a process on any nodes, not just the node you want to go. So in the beginning, it was just an administration tool, for people that doesn't want to install SSH on their nodes. But here, I just like modified it a little bit. So we just spawn a new container. So we can see it here. So we have our container. It's basically a container that is running as privilege with host file mounted. We NS enter into all the namespace of the hosts. So that in the end, we are on the host file system. And we can see something interesting here is that because we were root in the container, we stayed root and we are root in our host thing. So next step is just to try a little bit and just check what is running on that node. And what is interesting here is that we have almost everything. Yeah, it's a mononode cluster, so it's normal. But we have the hardened web app and our MySQL. So it might be interesting for us to just check how is this thing. So this is the MySQL. It's running, and most importantly, it mounts a volume. Because it's a database running into Kubernetes, you need to have some volume somehow. So this volume is mounted on /mount/database, but you can retrieve the host path on the host just like this. And basically, because you are running on the host, you can see everything from the pod. So you are here, you just find some very confidential information, and that's end of the game. So you find your flag. Yeah. So now let's recap a little bit. So what exactly happened? So at the beginning, we had this situation. We had our Kubernetes cluster. We were actually running the web application on the same node as the hardened web app. So we are in the blue area. We just found a vulnerability in the software that allows us to create a reverse shell. So that's the first issue, really. It's not related to Kubernetes. Then the second issue is that we found some credentials in the container. So for us, it was like a huge step because we could actually create another container and we could talk to the admission control. It was like, can I create a privilege container? They were like, yes. So no problem. So now we got that privilege container. It was running inside the same namespace as the bridge application. But basically, a privilege container is just something really easy to escalate to the node. So if we could schedule on any node of the cluster, we can basically own the cluster. So how to fix these issues? First one, vulnerability in software. Just don't write bugs, It's as easy as that. So just makes, so work a little bit. No, it's quite hard. It's almost impossible. Nobody gets that. So try to audit your code. Try to scan your container image and do things about the result of the scan, actually. And yeah, this is the issue, but this is actually the hypothesis in our case. So yeah, we will get this kind of vulnerabilities. So these things will actually erase the first vector of attack. Next thing, try to be more careful about your airbag because you found these credentials, it was easy to actually escalate. So avoid mounting service account token if it's not like something you need actually to authenticate with the API server. Be very careful with the write, and for that, we have a super guide on Kubernetes documentation, which is the role-based access control good practices. So if you want more information, go into that thing. It will give you precious advice. So second issue, we found some credentials in our container. So, oh no, it will erase this second issue. Third issue, no admission control. So just before me, I think it was someone talking about OPA gatekeeper. So yeah, airbag is not enough for these workloads. You need more granularity. So the idea is to add some brick into the API server to actually filter which kind of pods can be created or not. So pod security was removed. Now the replacement is pod security policy was removed, sorry. The replacement is pod security, which is stable, and you can find good documentation about it. The pod security admission plugin will actually enforce the pod security standards that can be enforced by multiple different admission controllers. And there is like a super blog post about that, which is actually kind of a tutorial that was made into a video presentation at the KubeCon Europe 2022. So you can check that one if you want. And shameless plug, I just wrote a little historical context blog post on the Kubernetes website. So if you want to learn a little bit about the birth of pod security policy and how it was removed, it can be interesting. So it will actually fix the last issue. The API server will just reply, no, you cannot create that kind of container. So if you want to experiment by yourself, you can, of course, go to GitHub. We wrote a little article on our website. You can experiment with the small CTF that I created along the tool. So the demonstration I used, I basically created a really small CTF. It's like a 3-step CTF, and it's really beginner friendly, so you can install it on your computer and experiment with that. So just like to precise, I added new plugins to the thing. I added support for ARM64. You can now install KDigger with Nix, thanks to someone at Control Plane. And it's super nice. Like you can use nixery.dev basically, which is awesome. And you can use it for pod manifest generation now. And I wanted to finish on that note. So the Kubernetes community is working to improve security of Kubernetes and its security, and on the side to improve like the communication over the security. So we just merged the security checklist quite recently. If you have some security knowledge, or if you don't, you can check it. Of course, it will help you. If you have some security knowledge, please come by and tell us like this is missing, this is missing, this is missing, so that we can improve this one. It will be amazing. And quite recently, we also merged the API server bypass risks. So this one is quite nice because it actually unveiled a lot of things that were non-officially stated in documentation, like static pods and things like that. So it's really interesting to read. So I guess thank you. And if you want to learn more about KDigger, go ahead and check. And yeah, thank you for the attention.
Any questions? Okay, well, thank you again. The next session is in a couple of minutes, which is a 5-minute session. So go get a drink, water. Thanks. Right in time?
I can.
Yeah, it's right. Yeah, you're next, yeah? You have 5 minutes, right?
5 minutes.
So next up we have Matty. Got it right. He's a London-based software engineer at Buoyant, an avid open source contributor. One of the maintainers of the, is that Linkerd project?
Linkerd.
Linkerd project.
Yeah.
Thank
Rhymes
you.
with Cardi B. Yeah.
Yeah? You've thrown me off now, mate. CNCF's graduate service mesh. He's passionate about networking, not just the social type, and systems engineering, but I'm assuming you'll be in the pub tonight.
Yeah.
To test that theory.
Yeah. Gonna do more networking after the presentation.
Exactly, exactly. So can we put our hands together for Matty?
Thank you. That makes me feel super comfortable. Hello, everyone. Hope you're excited to be here. I'm super excited to be here. This is my first time in Scotland, actually. And this is the first time KubeHuddle is taking place. So thank you to the organizers and to everyone involved. I wanted to talk about a problem that we've seen in our community for quite a bit of time. And it's a problem that I think is not just in our community, not just in the Linkerd community. Most of the open source projects that make use of a sidecar might bump into this at some point. It's how sidecars and jobs interact. Do people know what a sidecar is? Can I get a quick show of hands? 1, 2, 3. Okay. So most people know. I won't spend too much time on that. But yeah, with that being said, I'm going to start by talking about myself. So yeah, my name is Mate. I'm a software engineer at Buoyant. I'm also one of the Linkerd maintainers. I've been involved with the project for a little bit over 3 years now. You can reach me on Twitter, GitHub, and on Slack. I'm in the CNCF, Kubernetes, and Linkerd workspaces. I used to look like that once upon a time, but now I work with IP tables, so I have circles under my eyes. But, you know, such is life. Cool. What about Linkerd? You've heard about sidecars. What about Linkerd? 1, 2, 3. Okay. Well, I'm going to be using Linkerd to exemplify what a sidecar looks like. But for those of you that don't know what Linkerd is, it's CNCF's graduated service mesh. It's ultra light, ultra fast, and focused on security, like most service meshes, I suppose. We've been in production for a large number of years, and we've seen a lot of people adopt this, all the way from enterprises down to hobbyists. As a service mesh, Linkerd is basically just a platform tool. I'm going to demystify that buzzword real quick. It's just a platform tool. You use it with your application to enhance your networking, and it gives you observability, reliability, and security out of the box. And at Linkerd, we have a strict philosophy of being super simple to operate and super simple to use. The way Linkerd works, like most service meshes, is through a sidecar. You have a proxy. Ours is written in Rust. It's built purposely for the project. You use it next to your applications. You pretty much inject it into the pod, and it takes over all of your TCP connections, and it gives you all of these goodies out of the box. Now, naturally, if you've been working with Kubernetes for a while, and if you've been working with job objects and batch processing, you'll know that sidecars are not really well supported for jobs. And we used to have a key P in progress, a Kubernetes enhancement proposal that wanted to make sidecars a bit easier to use, but unfortunately that didn't really go anywhere. So you're lucky enough to have me today talk about the problem and show you some solutions. So this presentation is going to be pretty short. We only have like 20 minutes. So instead of talking a lot about the problem, I'm just going to show you what it manifests and how it manifests. And then we're going to look at some solutions. I have 3 goals in mind for this talk. First, to present the problem. Second, to teach you how to actually deal with this problem if you ever see it out in the wild. And third, I want to introduce a Linkerd extension that I've been working on, and that's one of the solutions. Just really wanted to talk about my side project. With that being said, let's start to look at a problem. And that's exactly my face when I have to look into the proxy codebase. Not sure many people really identify with that. But over here, I have a Key3D cluster running. I'm just going to increase the font a little bit. And inside, I actually do not have any pods running except for whatever is in kubesystem. So the first thing that I'm going to do is have a look at what a job looks like. I don't want to assume a lot of prior knowledge about this kind of stuff. So I thought the best thing to do is just to show you how the object looks like. So a job, just like any other Kubernetes object, has a GVK. It has a kind, it has a group that it belongs to, in this case, batch/v1. And then inside, it has a spec. In the spec, it pretty much handles just like an ordinary deployment would. You have a pod template, and this pod template will spin up a pod that will run until completion. So that's one sort of guarantee that jobs make, and the main use case that you would use a job for. Jobs will create transient pods that just run until completion. So a lot of people use them for batch processing. For example, if you want to do some cleanup and if you want to run some scripts, I've heard people use them to process emails and send emails. I know people use them to train ML models, so so on and so forth. In this case, my job is pretty simple. I'm using a curl image. Don't ask why. I don't know why at this point. But in this curl image, all we're doing is just sleeping for 10 seconds. So this is just to basically show you how this is supposed to act. Now, oops, I forgot one thing. We also have some annotations here and some labels. The label I'm going to talk a bit about later, and the annotation has to do with Linkerd, but I'll also talk about that later. Just wanted to let you know that they're there. First thing that I'm going to do is apply this manifest. The job is going to be created, and while it executes, while it sleeps for 10 seconds, I'm going to also install Linkerd. So Linkerd as a service mesh can be installed either through the CLI or it can be installed through Helm. We generally recommend that people install it through Helm for production usages. I'm going to use the CLI just because I don't really need to template out anything, and it also generates certificates for me. So basically, just to show everyone, the Linkerd install command just generates some manifests, and we just pipe that into KubeHuddle. And yes, I said KubeHuddle. Let's deal with it. But yeah, I'm going to pipe this into KubeHuddle. And this is, oops, I cannot type. It's hard to type and to speak at the same time. But yeah, going to pipe this into KubeHuddle, and this is going to create a couple of pods. We call this the Linkerd control plane. So if I look into the Linkerd namespace, we can see that we have 3 pods that have started. We use this control plane to talk to all of the sidecars that are injected next to your applications. So for example, we have a destination service that's going to serve any service discovery request that you have. You, for example, have a target. It's going to give you all of the endpoints for that target. We have an identity service that's going to create certificates for all of the proxies. We actually scope certificates to 24 hours to make sure that they're always refreshed. And finally, we have an admission controller, that's this proxy injector. And based on an annotation, this proxy injector is going to add the Linkerd sidecar into our jobs or pods. Now, let's have a look at our job pod. It already completed. So this is one of the things with jobs. Like I said, it creates transient pods that run until completion. So if we get the job, we're going to be able to see the actual status. It has 1 out of 1 completions, and we know that because the pod itself completed. The status is completed. Now I'm going to delete this job, and now because I installed Linkerd, I'm going to reapply it. And what you'll see is that now our job will actually have, I'm just going to start using aliases, sorry about that. But now you'll notice that our job will have an additional container. So instead of 1 out of 1, we have 2 out of 2. And if we do a describe real quick on this pod, I'm just going to scroll up. The proxy injector that I mentioned earlier is going to, add all of this stuff in. It's going to add a sidecar in, and this proxy is going to take over the networking traffic. Now, generally, people use Linkerd and service meshes for networked communication. You have like a server and a client. You want them to do MTLS. You want to get reliability and metrics, so on and so forth. There are situations when your jobs are going to do the exact same thing. You have some networked calls. You want to get reliability. You want to maybe have some policies in place. But jobs, like I said, were intended for batch processing. They run until completion, and proxies in general do not know about this. So what I mean by that is that if we look at the pod now, we're going to notice that it's sort of shifted into a not ready status, and this is a bit of a problem, right? Because now our pod actually cannot be cleaned up, and our job will never actually be reported as being successful. So this is the problem that we're sort of facing. The proxy needs to terminate, but in order for it to receive an actual termination signal from the container runtime interface, we actually need to tell the API server, like, hey, this pod needs to go. The proxy itself can handle these termination signals, but there's nobody to send a termination signal to it. So it's a bit of a systems engineering problem. Now I'm going to go back to the slides. Hopefully it makes a little bit of sense. But the problem itself sort of boils down to, okay, how do we actually, in a job object, send termination signals to the proxy? And I'm going to present 2 ways to do this. The first one is probably going to freak out some security experts, but don't worry. But the first option is to share the process namespace. So each pod has this option in its spec to share the process namespace. If we look at this poorly drawn diagram, we can see on the left side that we have a sidecar and a main container, and this is exactly what we've seen in our example pod before. But these 2 are running as isolated processes. They don't have actually access to the process data of the other container that runs inside of this pod. If we use this share process namespace field in the pod, if we turn it on, then all of them are going to have access to each other's process data. This is a bit of a double-edged sword, though, because while it's very general and it can apply to any specific sidecar out there, like it doesn't have to be Linkerd, it doesn't have to be a service mesh, it can be anything, it also means that you have a big security vulnerability because now all of your sort of sensitive data that's in a process file can actually leak out. The way the solution would actually work is, instead of just having the two containers, you introduce an additional container. I called it a watcher. And this watcher can actually watch all of the process information from your process directory. So it's really simple. You sort of establish a watch. You look at all of the processes. When the process is finished, you just send the termination signal to the sidecar. The main drawback here is that you're going to end up spinning and busy looping, and that's going to eat away your CPU cycles. So depending on how important resource usage is to you, this might not be the perfect solution. The advantage is, though, that you can literally just code this in a bash script. You don't even need to containerize it. You just sort of do it all in the pod manifest, and it can work. But for people that actually do not want to do this on their own and do not want to be yelled at by their security team, there's another option, which is sort of the Kubernetes way of dealing with this. And sorry, I'm just going to check my time because I don't want to run over. But there's also a Kubernetes native way to deal with this, and that's to implement a controller. And at this point, if you're looking at the slides, you might be like, well, what do you mean? That's just a Docker file. Well, controllers, if you build one, it's going to be very specific to the type of workload that you're running. So if you use, for example, Linkerd, and you want to use a controller to shut down the sidecar in a job, then you need to know what sort of guarantees the Linkerd proxy sidecar makes, and you need to know how it behaves. Like, you cannot extend this to just any arbitrary sidecar, right? You're going to start running something next to it. It's probably not going to work in the same way. In this case, our community sort of got together because they were all super, bummed that they cannot run any job workloads, and they came up with a way to do this. But first, I want to talk about this utility that inspired them. So we've been aware of this problem for quite a long time, and we as in the Linkerd team, came up with this really cool util. It's called Linkerd await. And Linkerd await is a small binary that you use with your normal injected workloads. And it can either wait for proxy readiness or also shut down the proxy container when the main process finishes. And it works really simple. All you have to do is just change your Docker image. I know it's all you have to do. It's a pretty big ask, but you basically bake it into your Docker file, and you overwrite the entry point to call this util binary instead of calling your old process or old command. So basically what I'm trying to say is that this util wraps around your command, and when it's done, it's going to fork your process, and when it's done, it's just going to kill the sidecar proxy. Now, of course, our community was like, well, wait a minute, I don't actually want to change my Docker file, like, what's that? Don't give me that as a solution. So they pulled all of their brainpower together, and they said, okay, let's turn this into a controller. And this is where my side project and extension comes into play. We're going to build a controller, or rather, we built a controller for this that works by using an admission server, and it automatically adds this await utility into your basically pod spec without you having to do anything. So if you're a bit unfamiliar with admission servers, the way they work is you get some requests from the API server. So for example, you try to spin up a pod, you get a request, you do something, you either validate it or you mutate it, and then you apply it back. In our case, we use an admission server that mutates everything. So first off, we create a job. This job is going to spin 1, 2, 3, 4 pods. It's going to get registered with the API server. The API server is going to start sending admission requests with each pod object into, to our admission server. And the admission server is first going to start filtering out those pods. Like, okay, which pods do I actually want to mutate? And that's what the label is for, sort of like the annotation that we have to inject Linkerd. It's going to basically filter out these pods, and once it finds a pod that it knows it can mutate, it's going to change the entry point of the main container. So first, it's going to add an init container. This init container is going to pull the binary for us. It's going to copy it over into a volume. The volume is going to be mounted to the actual main container, and the entry point is going to be changed. So I know that sounds a bit complicated, so I'm just going to show how it works in practice. So over here, sorry, I just have to first import the images. I haven't actually published any of this yet, so you're the first to hear about it. Lucky you, I guess. And what I'm going to do is I'm going to deploy this admission controller. It's called Linkerd Sweep. I'm not very good with names, as you might have been able to tell so far. And if I list all of the pods, we're going to see that, well, it hasn't started yet, but hopefully it will. Yeah, 2 out of 2. Okay, it's running. What I'm going to do now is delete this old pod that I had in here, if I can type, just so the job can actually restart and recreate the pod. So before it wouldn't work, you know, you had 1 out of 2 ready because the proxy still wasn't terminating. And now, if we list the pods, we see that it's running. And if I do a describe on it, I'm going to basically, well, we're going to see what happens, but I just want to take it from the top. First of all, we have a new init container. This is the new init container that I was talking about. It uses this await util image that I've built just for this, so it's tagged as test. And all this does is just copies over the await binary from a temp directory into a volume that we've just mounted. And we can see the volume mount here. It's /linkerd from linkerd await, has read-write permissions. Next, if we scroll down to our actual sleep container, this was our main container before, we can see that the command has been overwritten. So before we used to have just sh-c sleep10. Now the entry point has been overwritten automatically by the admission controller. So instead, we call linkerd await, which is the binary, the util binary that we're using. We pass this shutdown flag to tell it, okay, fork the process. After the process is finished, send a sig term to the proxy. And then we basically run the old command, and this is going to be forked, and it's just going to run as a sub-process. And then finally, we have a volume mount that we just use. It's an empty directory, and we just use it to copy the binary from one place to the other. And the end result is, basically, our example pod is now finished. It's completed, because once the sleep basically finishes, it's just going to automatically shut down the proxy. So if we also list the job, we're going to see that it has 1 out of 1 completions. Now, like I said, this is a side project, so it's something that I've been working on as an extension for Linkerd. If you do want to get involved, I haven't actually opened it. Well, I've just opened it to the public. I've just made it a public repository. You'll notice that, obviously, there are no issues and pull requests in there. But I think in the next week or two, I'm going to be able to get this into shape. If you do want to contribute, this is a great way to learn how to build Rust controllers. So definitely hit me up. You can, just check the repository out in your free time, or you can just ping me directly on Slack or whatever social media you use. I think that's going to be easier. And then just to end on a high note, because all my presentations tend to have very unclimactic endings, my company, Buoyant, together with a bunch of other open source leaders, are running a virtual conference called KubeCrash. They say it's a KubeCon warm-up. It's going to have a bunch of free presentations that are going to be way more in-depth than my 20 minutes. So please check it out if you're interested and if you're thirsty for more knowledge. And finally, at Buoyant, we also have something called Service Mesh Academy, where the maintainers give monthly presentations just to sort of get people more used to service meshes and to just working with service meshes. So if you want to learn how MTLS works and all of that stuff, there's a lot of great stuff there. Finally, I thought I wouldn't have time for questions, but I think I still do have time for some. And if we do not have time for your specific question, you can always find me by the water cooler. So, yes, bring the questions.
Yeah, so given that Cilium has gone down the path of sidecar list mesh as well as Istio, what does that mean for the sidecar going into the future?
Yeah, that's a good question. Look, I think depending on the project and the philosophy of the project, having or not having a sidecar might make sense. For us, we think the sidecar model is still the right approach when it comes to service meshes. And personally, as an engineer, I think it is the right approach because it lowers down the operational complexity that you actually need to run a service mesh into production. I don't know if any of you have ever had to do any CNI work or to debug anything that's at the CNI level. I had to. It's horrible. It's much easier when you run a sidecar, and also basically the boundaries for trust and the boundaries for errors and upgrades and all of that stuff is way more isolated. I can definitely go a bit more in depth, but do we have any other questions? Does that answer the question, first of all? All right, cool.
Did you look at more generic tools such as KubeXit or anything like that?
Actually, I have not, no. I did do a bit of research to see if there's anything that we could use for this, and there was nothing that we could sort of adopt or recommend to the people in the community. But definitely, if you do have any tools that you think would be a good fit, send them my way. We generally love to interact with other open source projects, so I'm sure if there's any way we can adapt it, or if you're accepting any PRs, we'd always love to get involved. So grab me after we're done.
might be an ignorant question, but wouldn't this behavior of killing off sidecar containers automatically be something that's ultimately better placed as part of the kubelet?
Yeah, it is. Okay, so real quick, graceful termination in Kubernetes is a bit weird. The kubelet basically delegates everything to the container runtime. So whenever a pod starts, the kubelet tells the container runtime interface, okay, start this pod, and it's the same when it kills the pod. Now, with jobs, obviously, the nature of sidecars is not always super compatible with what you would want to do, but it still adds, for example, MTLS and reliability and all of that stuff. Unfortunately, the Kubernetes API doesn't actually expose anything for us to send termination signals. If you could, for example, use a client set or a Kubernetes client and tell the API server, okay, send a termination signal to this pod, it would be great. But you can't do that unless you delete the pod. That's the only time when SIG-term signals are actually being sent from the CRI down to the pods. Does that make sense? Yeah. It would have been ideal. I would have loved it. Less work for me in the weekend.
Yeah, will this extension work with GitOps tools? Or I'm assuming you got to make the usual sort of exceptions of things that are injected, or?
Yeah, I think it will work with GitOps tools. To be completely honest, I haven't given it much thought yet, but I think it will work similar to how Linkerd works. You sort of, you deploy the application, whether you want to do that with GitOps or not, it's going to be up to you. And then because we're actually filtering all of these pods based on a label, you're going to be able to add that as part of your GitOps workflow. So while I do not have any concrete plans now, the roadmap is actually all in my brain at the moment. I think it will, and I'll be able to prioritize that. It's my own project. I can do what I want.
Okay, thank you very much. Can everyone put your hands together for Matty?
Thank you.
Perfect. Hello, everyone. Hello. I am looking for the scotch because I swear Rockode said we would have scotch.
6 o'clock.
Okay, I can wait till 6. I can wait till 6. Hello, everyone. I'd like to tell you a few jokes. I'd like to tell you a joke about UDP, but you might not get it. Yeah. Y'all have heard of that before. So an IPv4 packet walks into the bar, and everyone just cheers and is like, hey, how's it going? And an IPv6 walks into the bar. A packet walks into the bar. No one wants to talk to them. Hello, everyone. So I'm here to talk about how network engineering has gone DevOpsy. I feel kind of awkward having to stand right behind my computer because I like walking around, but hey, even better. Come on, where's the button?
It's down. By the way, it may not be suitable for the video recording.
Okay.
They'd recommend you stay.
Okay, never mind. I'll just keep doing this. That's fine. That's okay. So I've given this talk a few times before, and I decided I needed to change it up because Leanne is in the audience and she's heard this before, and I don't want to bore her. And I'm sure some of you might have heard it. But the inspiration behind this talk is is partly to do to my journey into the world of DevOps and how I was able to take a lot of my network engineering capabilities and skills and bring them into the world of DevOps. So my name is Marino Wijay. I'm a developer advocate at Solo.io. We are a application networking service mesh API gateway company. We'll talk about that later on. You can find me on Twitter. I also stream occasionally on Twitch and maybe YouTube, and I usually stream with some folks in the community here too, like Leanne, and maybe one day I'll get to stream with Kernel. But that being said, I'm honestly, this is not going to be a highly technical talk, but then here's the funny thing. You know, several people came up to me and were like, hey, are we going to see a demo? Are we going to see a demo? And it just like kept eating away at me. And so literally while I was sitting there right when, I forgot the last speaker's name, but anyways, Matthew, I was like, you know what? I'm just going to pull up a demo environment like right now, and then I'll just figure it out on the fly and we'll see what happens. Anyways, we'll do a demo. All right. So service mesh is a VPN. Why is it a VPN? Why, you know, what's with this statement? What is the issue behind it? You know, some people may feel against this statement and some people may agree with me. And part of the reason why I bring this up is because as a network engineer, I played with technologies like IPsec. How many of you have sat there trying to bring up an IPsec tunnel only to realize that your shared secret is incorrect? How many of you have tried to also stand up your tunnel, seeing that the tunnel is online, but then forgot to define your interesting traffic? Yes. All right, we've all kind of been there. But part of the reason I bring this up is because these technologies like IPsec, technologies like routing, layer 3 routing, have basically lended its way to where we are today in the cloud native world. And we'll talk about more of that because I want you to imagine an OSI model for a second. Just like, you know, picture it. Actually, I won't do that to you. I actually have an OSI model here. But let's start from the bottom. All right, we have this physical layer where all I really care about is CPU, memory, disk, whatever. And at this point today, that's all we truly need, right? That's all we really need. And then everything else becomes logic and software on top. And so when you look over to the very far right, you see that there's the Kubernetes layer because guess what? Today is 2022 and we're all talking about Kubernetes. We're all here at KubeHuddle. So everything we interact with is likely going to be around that realm. But what's also very interesting is that there were a lot of things that happened before we even got to the world of Kubernetes. You know, the concept of containers was derived through this concept of networking namespaces. How many of you know what a networking namespace is? Right? Okay. So how did we get to a networking namespace? Why did we get to a networking namespace? We'll talk a little bit more about that. But as we climb up this layer, these layers in the OSI model, we start to realize that we need better tooling, better systems out there to be able to move our packets around between our pods, as well as provide some very granular, rich capabilities at higher levels or higher layers. And so technologies like Cilium, the CNI, the Container Networking Interface, made it super easy. Hello, Liz, I see you over there. Make it super easy for us to allow our pods to communicate. You know, you pop on a pod, it gets an IP, boom, it can communicate with other pods, provided you have all of your policies and whatnot figured out. But that idea of IPAM, DHCP, where does that come from? That comes from the networking world. Tools like Cilium have made this very simple for us to work with. Now, what about technologies like proxies and load balancers and how we go about doing things like rollouts for new deployments? We use these technologies anyways back in the day to be able to create different versions of our app and then roll them out accordingly, like using the AB model or the blue-greens model. But having to manage each one of these components individually, it was kind of challenging, and we'll talk about that in a second. So my journey was interesting because when I started in the world of networking, I actually started chasing after certifications. So I was chasing after the certification dragon because, quite honestly, I felt like that was a great path for me to learn about the fundamentals of networking, things like routing, things like switching, things like firewalling, VPNs, and whatnot. But I kind of grew up and worked my way through the campus, through the data center, through the storage area realms, and then found myself in the world of software-defined networking, which is pretty much the pivot point for deciding, hey, you know, when I build an app, I need a just-in-time network. So this was really a movement towards, let's make our networks much more software-like so that we can build our networks in software, and then they become, or they come to fruition when we have an application that we need to build just in time. So there's also a bit of jumbo frames there. If any of you have worked in the world of iSCSI, you'll kind of know that it was a bit of a pain, you know, having to deal with a bunch of like switches with not the right MTU sizes, and then yeah, your storage is not going to work and your LUNs won't come online. But the other thing too to consider is, you know, as a former network engineer, I had to configure so many different devices. You're touching a firewall, you're touching a router, you're touching a switch or several switches, and you're having to do this across multiple sites. And then guess what? You're writing all of your configurations in Notepad or Notepad++, whatever tool you're using back then. And then you realize, oh shit, my laptop just died. I've lost all my configurations. I haven't backed anything up. So we kind of gravitated towards the world of, hey, let's start storing our configs in TFTP servers so that they can be pulled down when routers come online or switches come online. And while that was serving as a way to work around some of the challenges of like, hey, I just left all my configs on my laptop or whatever, it also allowed us to start thinking about automation. Hey, I don't want to sit there and configure each VLAN individually or each port on, you know, my switch to tie it to a VLAN or set it up as a trunk port. I can automate this. I can use technologies like Python to be able to script how I go about configuring that. But before we even get there, like, imagine having to do all of these different activities before automation existed. Imagine having to walk into a data center, seeing a wall of spaghetti, and then having to like comb through that spaghetti to find that one wire, which just had like a broken, like whatever you call them these days, is clips on the end of the wire. Yeah, to find that out. But we decided, hey, you know what? Let's just create some technical debt. Let's just use software-defined networking to make this easier for us. And so we kind of just started ignoring a lot of the physical layer problems and then wrapping software on top of the physical layer just so that we can build what we needed to just in time. So let's automate all the network, let's automate the VLANs, let's automate as much as we possibly can, but we also still need some sort of mechanism to, you know, manage this all, and some sort of config management or version control. So this is where we started to gravitate towards this world of net DevOps. So I mentioned earlier that we had technologies like Python or languages like Python that helped us script these languages, or script the way we go about configuring our devices. How many of you received that initial email from Kirk Byers a long time ago saying, hey, come take my Python for network automation course? I'll raise my hand because that's kind of where I started. Anyways, but that was the start of real network automation. And then you started to see that Ansible playbooks also made their way into the data center to configure network devices. And then you started to see tools like Napalm provide an abstraction layer for so many different devices because every device from different vendors were different in the way they were configured. And then you started to see how devices also expose their APIs. So now you can take a programmatic approach to configuring all these devices. Now we're getting somewhere, but we're still lacking some of that version control. So where were you when I needed you, Git? Like, honestly, when you think about it, 15 years ago, there was no real mechanism to track your changes against your network configurations. You kind of had to manage it yourself. There were no real tools. I mean, maybe there might have been like some text tools out there that helped you compare different configurations together so you would have them side by side and you can see the differences. You know, fiber channel zoning, for example, you're trying to do a merge config or something like that. If you're not looking at it side by side, sometimes you're going to miss a line and then your LUNs won't be mapped to their initiators and targets. But that's a different story. But having Git back then probably would have made a world of a difference because now I'm not having to sit there worrying about that change I made last week and if it's going to impact something in the network down the line, like maybe a random firewall rule or something along those lines. And then Kubernetes entered the chat. And we started to see that, oh shit, our networking game just got more complex because guess what? Pods come and go. They come to life and then they disappear. And then when a new pod comes online, it has a different IP. So what's up with that? Like, how are we working through those streams? And this is where technologies like
container networking interfaces or container networking plugins like Cilium, like Calico, like Antrea, as well as other technologies like ingress resources or ingress gateways started to come to the world of Kubernetes, primarily to allow us to manipulate the way we can handle our traffic coming into the network and traffic that is inside that Kubernetes network. But then now you start seeing a whole bunch of network configurations in your YAML, which basically just means if I am a network engineer today, most of my network configurations probably will look like they're in YAML, which means if you are a network engineer today and you're trying to understand this stuff, maybe you want to start with learning a little bit of Kubernetes, but also learning some, why do we use YAML as a configuration spec? Why do we use it to, create desired state in the way we operate our applications? But you will find networking either at layer 4, whether it's like BGP configurations, or you're doing layer 7 traffic policies or even authorization policies, you'll find that all in YAML. So now we have these set of technologies that have evolved from what we used to do. So we had routers, switches, firewalls, load balancers, which still exist today, right? They still are there, except we use different abstraction layers to program these devices, because having to create the network for a container every single time and then destroying that container network every single time it disappears is not practical. And this is why we have container networking interfaces. Service meshes allow us to get super granular. The last person who spoke gave a very good overview of how service mesh works. And quite honestly, I'm not going to dig into that. I'll show you some of the things that work in a service mesh. And then we also need a front door for the way we start to access our applications. So we start to see we start to see API gateways show up. API gateways are there to accept our incoming connections and then decide, hey, are you allowed to access this resource, or should I limit how much you can access? So let's go back. Service mesh is just a VPN. Why is it just a VPN? So we've taken the ideal of IPsec, brought it to the world of MTLS. So y'all are familiar with MTLS. We're trying to create some security and encryption between our endpoints. We also bring routing into the mix, because now we're trying to determine how do we get to the right resource at the right time. But then there's also this element of how do we see things, right? We used to be able to dig into logs. We used to be able to dig in and debug things within our network devices. Now we need other tools to be able to see that. We need other tools to be able to extract that data and feed it elsewhere. And so in the world of service mesh, as you know, the sidecar was able to provide that. But what happens when the sidecar disappears? So what about ambient mesh is just a VPN without sidecars? What does that actually mean? Let's take a look. So ambient service mesh, for those of you that aren't aware, in the world of service mesh, there are several vendors out there. You just heard a talk about Linkerd. Cilium is another service mesh vendor out there. Tetrade is out there as well. I'm from Solo, but one thing that was interesting is that Solo and Google worked together on this project to basically create a sidecar-less version of Istio service mesh to basically say, look, if you don't need the sidecar anymore because we're trying to save on resources, well, you have another option here. And so what has happened is we've actually moved from the sidecar approach. We still have it. It's available to you if you actually need it. But then there's an approach where we actually split up the sidecar functionality in service mesh and say, hey, if you only need MTLS and layer 4 connectivity, let's deploy something called a Z-tunnel, which is deployed per node. And that Z-tunnel, which effectively is proxying connections on behalf of all pods that live in that node, will say, hey, if I have a communication that needs to happen with a pod in another node, well, let me tunnel to it. I can tunnel directly to another Z-tunnel. And that tunnel is actually called something called the HBone, or the HTTP-based overlay network, which is effectively a mechanism to carry TCP traffic in HTTP. This is a tunnel. This is an IPsec tunnel-like thing. Literally, we are staring at an IPsec tunnel, which is providing encryption. Now, the details here around where are we getting certificates and whatnot, there's a lot of information there, and I'd love to dig into that. Basically, to sum it up, we're going to call on the identity of a particular application, use that certificate as the mechanism to create the one-end trust of that tunnel, and then we'll do the same on the other end of that Z-tunnel. Now, when we need layer 7, let's say we need policy, You know, the sidecar was responsible for all that layer 7 policy previously, but you realize that it takes up a lot of processing power. It takes up a lot of memory to be able to process a lot of traffic at layer 7, especially when we have, you know, very specific information in our like requests. So what we can do is we can offload that to something called the waypoint proxy, which is actually processing that layer 7 traffic for us if we need to. So we can use just the Z-tunnel layer 4 bit and not really have to worry about having that layer 7 proxy up there. Or if we actually have layer 7 policies we want to implement because we really want to go for this, you know, super strict identity, we're honoring certain headers, whatever it might be, the waypoint proxy can be deployed as well. So this actually creates a very interesting mode of operation where you can onboard a lot of your services without having to inject a sidecar, which means you can have your services in the mesh, and they can still take advantage of a lot of service mesh-like features. Now, why is this a lot like IPsec? Well, why is this like a VPN? Well, it's simply just this. When you have two endpoints that are facilitating a tunnel together, a connection to each other, and then they're proxying connections on behalf of a massive set of workloads, what do we just have here? We basically have an IPsec tunnel. So that's why service mesh is a VPN. Now, what does that mean for that network stack going forward? So that network stack actually is kind of interesting because you'll always have the hardware layer. Now, whether you buy the hardware yourself or you go to someone else is entirely up to you. Whether you build your own cloud or go to a cloud provider is entirely up to you. Whether you choose to deploy an SDN or software-defined network or use VPC or VNet-like technology, that's entirely up to you. Now, where it gets interesting is whether you decide to go ARM or x86 based off of your needs, based off of the performance that you're looking for, based off of the cost that you're trying to save. And then you go up the layers to the container runtime and then Kubernetes. And then you can start doing this dance of, now I can use CNIs and Kubernetes. CNIs and service meshes. But interestingly enough, if you recall, if I try to expose an application and give it all the right security, you know, pass a certificate to it, and I did this before all the work we did in the DevOps space, I can't give you the actual like time it would take me, but it would probably take me a really damn long time to get that all configured. Today, I could go pull templates and be able to configure an application, give it all the necessary networking it needs with probably a single YAML manifest that will also contain my networking configuration. So that network stack changes based off of what you're using, based off of what you need. You know, a lot of these components can be highly interchangeable. Whether you use Cilium as the CNI is up to you. Whether you use Istio as the service mesh is up to you. There are other options there, but I'm giving you a perspective here. Now, do you want to learn more? Do you want to, get familiar with some of this stuff? I have 2 links for you. Don't worry, they won't extract your crypto wallet, I promise. The first one is actually a course that I decided to build because I saw a lot of gaps in the way we just jumped right to CNI and Istio and service meshes and API gateways. What that gap was, and if you actually go to that link now, you'll see what the intention of the Network Foundations workshop is that we're here to address things like the OSI layer, IP addressing, IP routing. We're here to understand how DNS works. We're here to understand how HTTP and curl and dig work. We're here to understand how we even got to container networking with networking namespaces. And then we'll finally land at Kubernetes networking. And the reason why I took this approach is because I was that person that was like, holy shit, I have a lot of gaps when it comes to working in the world of DevOps. How do I address them? And maybe there might be other network engineers that might benefit from them. Now, there's also the solo plug. So obviously, if you really want to go take some solo workshops, you're more than welcome to. You don't have to. But I highly recommend you do. And also, there is a draw. So if you want to win a drone, please go right ahead. Now, there's one more thing I'm going to actually show you. And I'm actually going to show you something called ambient mesh. So I'm going to make this a little bit larger so you all can see. And if I do a kubectl or KubeHuddle, for those that have issues with the way I pronounce kubectl, you're going to see a little Kubernetes cluster there. But I'm also going to do a few other things where I'm going to enumerate all the namespaces. And you'll see that there is an Istio system namespace deployed. Now, if I also do a -- show labels, you will see that there is one particular namespace, where is it? Which is the default namespace that has a label called, oops, I wish that copy to clipboard would go away. But anyways, istio.io/dataplane-mode equals ambient. This is a mechanism for us to basically tell Istio that if you see a namespace with this label, we want Istio-based services, but we don't want a sidecar deployed. Basically, we're just turning on the ambient mode of Istio so that you can still take advantage of the sidecar capabilities without the sidecar, effectively. But what does that actually mean? What does that look like? What is in the Istio system namespace? How much time do I have left? Because I've not been keeping track of time.
12 minutes.
Okay, perfect, excellent. I am right on time. So if I do a kubectl get ns, or actually get all dash, actually, yeah, get all dash n Istio system. Actually, you know what? Let me do this. Let me.
You got 22 minutes.
What? How did I go that quickly? Okay, I guess I had 22 minutes. So if you take a look at this, you see that there are 4 pods called Istio CNI node, and then there are 4 pods called ztunnel. Now, the Istio CNI node is actually a mechanism to basically direct traffic to say, hey, if you are trying to communicate with a service that is backed by Istio, even though it doesn't have the sidecar, but it lives in another node in the cluster or another, just in another namespace or something along those lines, you're basically just saying, let's redirect the traffic to that ztunnel and let the ztunnel proxy that connection. What actually is going on is ztunnel is going out to capture the specific certificate of that service account of that workload and saying, hey, we're going to use that and we're going to create that encryption between that endpoint and then whatever other endpoint as well. So actually, if we go look at the logs of this, or if I actually run a curl command here, which is basically just calling one service to another, and I can tell you which service it was calling by just looking at the command. Basically, I am execing into the sleep pod, and I'm calling the web API service. So if I output the logs of the ztunnel pod, any ztunnel pod, you will actually find out that you can see how it's capturing the identity, like you can actually look at, and it's in SPIFFE-ID format. So it's capturing the identity of the sleep pod, and it's telling it, hey, I'm going to use this to create my secure tunnel or my secure overlay to the destination, which is the web API pod. And then on that end, we'll have the SPIFFE-ID pulled from its service account. So now we actually have MTLS available between these 2 endpoints, even though the 2 actual pods themselves aren't directly, having that mutual TLS connection. They're doing this through that ztunnel. Now remember, this is all at layer 4. So this means a lot of my traffic patterns are optimized. This also means that I don't have a lot of additional services running on that ztunnel pod, which means that the footprint required to run is a lot less than what I would have with sidecars running for every single pod. But ideally, what's really cool about this is if you are looking at this from an operational standpoint and you want to implement a service mesh without having to restart your services because you have to inject sidecars, this is an approach that you can take. Now, you all can actually go take this lab yourself. I'm not going to dig into all of this information in detail, but the intention here is that now I've got you hooked. Maybe you might want to go take a look and hop over to the academy and do a self-paced workshop on ambient mesh and then discover that, hey, I want to learn more about Istio mesh. And then maybe I want to learn more about glue mesh. But anyways, that's for another conversation. So just to kind of summarize, right? Let's kind of go back a little bit and talk about this stack for a second. I have a multi-topology network that I have to set up, that I have to service virtual machines, physical devices, containers that run inside of Kubernetes, maybe containers that potentially run in other orchestration platforms. One day we'll get there where we're able to bridge it all, but this is going to be the network stack that you're going to be able to use to get you there. And the reason why is that you're looking for the best of breed. You're not looking for one size fits all or a silver bullet that'll take it all out. You're looking for a combination of different network stack tools that'll help you get there for your application or your microservices. Now, this slide was left blank because I don't know why I left it in there. I meant to take it out. That's okay. If any of you want to learn more about DevOps networking, if you want to learn more about container networking, if you want to even learn more about Istio, there are a ton of resources that I highly recommend you take a look at. 100 Days of Kubernetes by Anais, amazing resource. 90 Days of DevOps, obviously you heard Michael earlier today, amazing journey. Networking in Kubernetes, a very succinct, I think 400-ish pages resource that really covers everything from the ground up to the point of like what I kind of talked about in my session. And then Kunal. Where's Kunal? I got to give him, Kunal left. Gosh. Kernel is one of the goats when it comes to content development. Obviously, there's another one in the room. He's taking a picture of me right now, the king of open source over there. But that being said, if you actually want to learn computer networking at a very basic level, Kunal created an excellent course on YouTube. I highly recommend you check it out. One thing I'll add is part of the reason why I jumped to the world of Kubernetes is because I saw a lot of familiarity with the way Kubernetes operated, with the fact that it relied heavily on a network, the fact that it was a distributed system. So for those of you that are really like interested into digging into it or wanting to understand more of the networking side of Kubernetes, obviously that book is great, but run TCP dump, use Wireshark, dig into some of that traffic, and then you'll understand the network flows a bit better. Thanks, and always follow the packets. That's all I gotta say. Take care, everyone. Do you have any questions, concerns? Yes.
Okay. So you showed the OSI layer and the OSA model and all of the Kubernetes-related constructs.
Mm-hmm.
It feels to me like a lot of the technology that we're building is layers of abstraction on layers of abstraction, etc. I can't speak today. Can you see any opportunity to simplify things anywhere in this big stack?
Yeah, so I've seen that there are vendors looking to work to simplify all the different CRDs you would have to manage in a given cluster. Solo is one of them, Isovalent's another one of them. And I know a few other companies out there that are actually working actively to just make the overall experience of deploying a network for your application very simple. However, the other side to it is we still want to give you the opportunity to like play with it, get to the point where you can start going custom if you want to, deviating from, I don't want to say the word, it's such a dirty word, best practices, but deviating from those practices altogether if you absolutely need to. But it all really comes down to we absolutely do need that abstraction. Maybe there are better ways to do it, but this abstraction means that we're just writing objects for you that you don't have to write into Kubernetes. For example, in the world of Solo and what Glue Mesh does is we simplify a lot of the Istio CRDs so you're not having to sit there and create like service entries for every single object that you have that is external or internal. Or if you have multiple virtual services or destination rules, and they all are tied to like different versions of your app, well, use less CRDs overall with Glue Mesh to be able to achieve that. But that's an example, right?
Yeah, nice pitch.
Yeah, I have to. Any other questions? Yes.
How do you avoid inter-AZ traffic with the per namespace proxy approach?
Can you repeat that question? I couldn't hear you.
So how do you avoid inter-AZ traffic with the per proxy namespace approach?
How do you avoid inter-AZ traffic?
Yeah, because it will obviously add latency and cost depending on where you host your stuff. So if you have just one proxy per namespace, then it definitely will cross if you have a multi-AZ cluster.
Yeah, so we do realize that there is a limitation, but the proxy isn't tied to a namespace actually. So a proxy is representative of service accounts, not particular namespaces. It's just deployed. Like for example, the zTunnel resource, while it is deployed into the Istio system namespace, it's actually servicing workloads wherever it's tagged for ambient. So what happens is there'll be multiple identities tied to that particular like Z-tunnel pod based off of whoever's trying to communicate. And so it's not necessarily a per namespace model, it's more of a per service account model. There may be times where you may have to scale up the number of proxies you have to deploy, or Z-tunnel proxies, and that's entirely configurable on your end. And the reason for that is because, look, like one Z-tunnel pod is not going to be able to facilitate thousands of connections, so you have to scale that. And so we could lean on the principles of like Kubernetes scaling altogether if we really wanted to, because ultimately the way tunnels will operate or the way Z-tunnels will form secure overlays with other Z-tunnels, it'll be basically the same way it would if you had multiple like proxies available. So you could have almost like you could almost get to a point of a full mesh tunneling setup where you have like active setups, but we're not there yet. Like theoretically, it's possible. But here's the other thing, like today we use Envoy as the mechanism underneath Z-tunnel. And Envoy itself is very taxing. There are a lot of extra features that come with Envoy that aren't necessarily needed for what we're using with ambient mesh or Istio. So we're actually exploring, and actually not us, but more so the open source community is exploring building out another kind of proxy that is a lot lighter weight. How they're doing it, how they're going about it, I'm not sure yet, but it'll look to alleviate a lot of those performance concerns along with any sort of contention and allow us to move away from any sort of truly shared models if we needed to. Any other questions?
Okay, thank you very much. Everyone put your hands together. So the next session starts in 12 minutes at 3:30, but I've been asked to remind everyone that there is a workshop down at the Glass Cube on Ebpf with Dennis Janot.
I actually made this joke in Disney World, where I went to the store and there was some dad who picked up a branded Battleship game. I just walked up to him and like, I hear that game's hit or miss. He looked at me, put it down, and just walked away. He's in stable condition. Call your mom or dad. I love it. This is very American, but you know it's true. He was innocent. Innocent. The element of surprise. Wow. From the otter slide. That one actually took me a little while to figure out. That was good. I like that one. We have an idiom, don't spill the beans. Don't spill the beans. If you can see, that's pie. Yeah. Come on. That's a worldwide joke.
Are you okay with us streaming this, by the way?
Yeah.
It's been providing great entertainment for us. So.
That's huge if true. Oh, come on, perfect timing. Come on, that was perfect timing. That's an inflation joke.
I just retweeted something about Osmosis number 4 now, and it's above LA for one.
Oh my God, really? Top secret and bottom secret?
Like literally after we talked about it, which is also kind of sus.
Yeah.
But yeah, it popped up in my feed.
Oh, fun. I'll take a look at that later. Yes, 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 yes.
Want to know if I'm moving back?
No. I would. Come on, that was good. That was good. I do love how they're streaming this. That's awesome. I do like that one. He's still going to the office. Don't trust him.
Only 2 more minutes for this. Wow.
It's another American one, but it's true. You know who Penn and Teller are. It's another programming joke. It's good to remember. It's good to remember.
Start, is that right? I got your baby shower for your baby shower. I said, are you serious?
It should work now.
Okay, well, we get started then, or is everyone wanting to see JJ's puns? JJ obviously likes a bit of humour, but he also is a developer advocate representing IBM Cloud all over the world. He mainly focuses on the IBM Kubernetes service and OpenShift, trying to make companies and users have a successful onboarding to the cloud native ecosystem. So without further ado, can we put our hands together for JJ?
Hello, everyone. So thank you, first of all, for coming here. After sitting in this room and just popping my head into the other room, I noticed very quickly that this talk is quite a few steps earlier in the journey of Kubernetes compared to the audience that is here. So I'm going to go through this Kubernetes OpenShift in way too short of a time to kind of level set, and then I'm going to get to the code as quickly as possible so you can actually see the beauty of it. I want to make sure everyone realizes that this is a very basic talk. This is basically, we're going over the very, very basics of it, but it's enough to feel dangerous. So if you've heard some terms you just had no idea people were talking about, this talk is for you. Otherwise, I can put the jokes back up. Anyway, so yes, hi again, JJ, developer advocate, which nobody knows what that means anymore, unfortunately. The way I like to describe it is I'm a personable nerd. I'm supposed to be here to speak enough about something, but also pick up a bar tab here and there too. That was a joke. Thanks. I really do have the email address of awesome@ibm.com. If you know anything about IBM, we have atrocious email addresses, and that's how amazing what happens when you find the right paperwork. And you can pretty much find me everywhere, at JJ Asgar on Twitter and whatnot. Always willing to talk about this stuff. My job is to be accessible, so never hesitate if you have any questions. If I don't have the answer, I will find someone, probably Marty over there, to actually have the real answer for you. There you go. So let's start at the very beginning here. We're going to start with the building blocks, right? The goal of this whole talk is for you to be able to walk out of this room and understand how to deploy a very simple Python application. And hopefully, at least what I figured out was the hook that made me realize that this truly is the future for development in general, to be able to be successful. Because just out of pure nerd curiosity, why do most businesses exist? Anyone have a good answer? Money, that's exactly it. The whole reason why we do this job is to earn money. So you need to realize, as people in this space, we are trying to remove roadblocks so our downstream users, which are usually developers, can get their stuff built as quickly as possible. So let's actually just start from the very, very ground where you need to understand everything is built off of something called a container. There are two different major places out there. There's something called Podman, and there's something called Docker. I got yelled at by my marketing team, so I'm not allowed to use the Docker logo. That's supposed to be a joke. And I'm an old man yelling at the cloud. I'm not actually that old. I just have a lot of gray in my hair. So there are multiple different offerings out there. There's something called Podman, as I said. There's Docker. There's things called Builda, which actually builds the containers. And there's also Canico, if I remember correctly. They all adhere to something called the OCI spec, which is important to know, which is the standard way for all containers to talk to one another. They all need some type of registry to be able to store that container to pull it down from. Obviously, Docker Hub we all know because of what's been in the history. Quay, GitHub now has one. It's all great. They're all built from something called a Docker file, which is just a way to declare what needs to be inside of that container. And then the beautiful story that is containerization in general, you package and you can run it anywhere, anything with the container runtime. If anyone has any questions or thoughts, don't hesitate to raise your hand while I'm speaking. I'm here to answer questions. That's why I'm here. I'm also a streamer, so I'm very used to pivoting my conversation from, what the OCI spec is to, JJ, what is a computer, very quickly, so don't worry. So as you start building up your applications, that's where Kubernetes comes into play, right? You need some way to be able to run all of these containers and all these different microservices or applications. The core thing, the way that I finally understood Kubernetes as a core concept is, or at least to anchor your thought around, all Kubernetes really truly is an API to compute. If you can put your mind in that headspace, all of a sudden, all the weirdness around Kubernetes starts making a lot more sense. Because what you do is you just give it a container, it will find a place to run. Important to know that there's quarter minorly releases, and there's no long-term support. Now, as I asked a few moments ago, what is the core of your business? What is the reason why it exists? It needs to make money. That's a very strange thing to say, that we're building our whole future off of a technology that has no long-term support. What makes all the money in this world? Enterprises, right? Don't get me wrong, I was started in the startup world, but enterprises are the one that make all the money. We need things that can last a long time. Kubernetes also has a lot of community support. So yes, you'll be going to Stack Overflow to figure out when things go wrong. And that's a hard sell for a lot of people. Obviously, people like IBM, might be a small company that you've heard of. Also, AKS, EKS have offerings of Kubernetes, but they are important to know that they are just like upstream versions of it. There's not a product. And again, there's a limited core framework, which is important to know. And if you want anything on top of Kubernetes, more than that API to compute, you have to realize you're going to be doing all that work. And that's really important to realize when you start building your business here. Now, you might have heard of a small company out there called Red Hat that was purchased by another small company called IBM. And I realize that logo's old, I'm sorry. But believe it or not, there is an actual offering out there that is an enterprise-grade Kubernetes offering. So when you start actually looking to run your business on Kubernetes, OpenShift is actually a really good player, where the beauty of what is Red Hat is 10-year support for software, right? And you start telling people that, all of a sudden you can be confident that for 10 years, you know for a fact you will have support from Red Hat running your platform. There's quarterly releases. The latest is 4.9-ish. That number changes pretty regularly. There's actual enterprise support, which is to know about. There's an ecosystem certification, and most importantly, if you buy whole hog into the OpenShift ecosystem, what you do is you get around this. People forget that this is a Kubernetes ecosystem, and they've actually broken it out to more things now. So you tell your boss, hey, I want to go run on Kubernetes. We got to figure out what we're going to run. That scares the fuck out of people, right? It legitimately does. And that's the whole reason why something like OpenShift exists. All right. So let's talk about the core concepts you need to know inside of Kubernetes and OpenShift. I'm going to mention a couple things that are specific to OpenShift in a moment, but everything is Kubernetes. OpenShift is Kubernetes, but there's still additions to it, if that makes sense. So the first thing first you need to know is a deployment. What is a deployment? It is actually the smallest amount that Kubernetes knows about. I lied to you at the beginning. It's not a container. It's actually a deployment. And as you can see here, you can have n number of containers inside of a pod, which is a number of deployments. So you see there, you got 2 containers, and you set a replica of 2. It will make sure that it can know where is to run the actual application. If you look down at the bottom, this is a 3-node cluster. What is a node? A node is just basically a CPU. When you really boil it down to what it needs to know, it can be anything ranging from a VM to a bare metal machine to a container. It's just a CPU. Most importantly to know, as a downstream user of Kubernetes or OpenShift, you don't actually need to know those nodes. Of course, you can do different ways of like labeling nodes and make sure that you have only GPU heavy loaded work runs on something with a GPU or whatever. But as a downstream user, you just have that API. So as you see, we don't even know as a user, it's just Kubernetes or OpenShift. Does that make sense? Thumbs up? Perfect. So let's talk about some internal concepts of Kubernetes and OpenShift. Yes, I'm cool, so I call it K8S. It was supposed to be a joke. First thing first is, of course, with every new technology, we need to rewrite DNS. So we have our own DNS inside of Kubernetes. Another joke. So the easiest way to describe it is if you have this application and it's looking for foo web, it looks for something called foo web. It talks to its internal DNS. And then it can go to any of these pods, which is pod C. This is actually pretty close to what the production level YAML would be. You tell, hey, if you're ever looking internally, yes, you can do this externally, but we're just talking about internally. If you are looking internally for foo web and you're looking on port 80, you go to one of these pods with running port 5000 to run this container. It can be anything, it doesn't really matter, but that's how you map things together. The next thing you need to really know about is something called namespaces. Namespaces is the way to slice and dice your Kubernetes cluster. We've had a lot of really interesting conversations about how namespaces are used in advanced concepts at this conference, but this one is the core, the whole idea of it, where you can have dev, QA, and prod all on the same cluster. As long as you have namespaces, granted you can break out of them, but we're not talking about that. You could have dev, QA, and prod all running on the same cluster, making sure that when you do performance measuring and whatnot, you're actually running on the same hardware instead of Sally Joe's desktop underneath her thing in the office. That's still a problem if you don't know. On top of that, Kubernetes comes along, or sorry, OpenShift comes along with things called projects. Projects is actually a layer on top of namespaces and extends it to an ability to tie it in with things like AD or LDAP. There are supposed to be some X's here, and every once in a while they're not always there. But if I'm just a user and I'm just a dev, I can just work inside of this one dev project environment. Also, projects have been designed to be kind of like feature branches when you do development with Git. So the idea is that they can be ephemeral. So you can pull your code out of that and merge it back into main, which would be your prod instance, for instance. As soon as you wrap around the power that is a project, life becomes so much easier, and you can kind of take the same trunk-based development process with Git and be able to just run it on top of OpenShift. Again, projects are done with OpenShift. So when you start talking internally inside of Kubernetes and when things need to start happening, there are load balancers. There is this company that starts with an F and ends with a 5 you might have heard of. And they actually have ways to do really interesting things with it now. But at the time, when I first wrote this, they hadn't released their software SDN one. By the way, your talk about SDNs earlier was amazing. I don't think he's in here. But the idea is load balancing can be its own talk, but there is a way to load balance between pods inside of a Kubernetes cluster, and it's important to know that they do exist. Ingress is the hardest thing to understand when it comes to Kubernetes, believe it or not, out of everything you need to know. On vanilla Kubernetes, this is how you map how all your pods talk to one another. So back to that foo web idea, this is a very basic ingress saying that, hey, if you go to foo web and you need to talk to foo data, the ingress will tell you where you actually need to go inside of the application. If this makes any amount of sense to you at all, you are eons ahead of the majority of people who use Kubernetes out there, which is awesome. But as you start getting more and more microservices inside of Kubernetes, this starts becoming unwieldy because this is all YAML, and you have to add and add and add to the ingress YAML to be able to do this work. And that's why something called routes was created inside of OpenShift. Routes basically turn that whole crazy YAML that you have to pay attention to into 2 commands, which is pretty damn cool. You basically say, hey, I want a new ingress. OpenShift figures out what it needs to attach to, and it just gets it done. You'll see a demo of that in a second. And it makes life so much easier, especially you can just flip things on and off. So if you have a dev, QA, and prod environment, you can actually turn dev, QA, and prod on really easily, be able to test your work, which is important to know. So let's talk about some ecosystems, which the ecosystem of this space. I've chosen 3 here. Most of them were already talked about today, which is cool. But I want to make sure that if we haven't talked about it, you at least have some frame of reference when somebody says one of these words. First of all is Helm. It's just a package manager. It's not, I know, it's not a package manager, but the best way to understand it is it's a way to programmatically deploy an application onto a Kubernetes cluster. Helm charts are amazing. We have actually one of our maintainers, again, Marty, I'm calling you out, here, which is amazing. It's a great project to be able to get something installed onto your Kubernetes cluster. But if you have no concept of what it really is, think of it as a package manager. Makes life easier. Then Istio, we've had just multiple talks about Istio. It's a service mesh. I'm not going to talk about what a service mesh is because if you're at this talk and trying to learn about how to deploy an application, service mesh is a few steps away from where you are right now. It's important to know, though, it was just given to the CNCF, which is really good for upstream development, which means the service mesh will become a much more interesting opportunity to do more advanced microservice things. And finally, Knative. what is Knative? We all know what serverless is, yes. What Lambda, if I say Lambda makes sense to people, raise your hand, make sure everyone's paying attention, cool. The Knative, in essence, is a way to run serverless functions on top of your hardware, which is important to know. That's great for regulated industries where you have to run on your hardware for whatever reason. It's important to recognize that there is a way to do this. That brings in some philosophical questions about how you should run serverless, blah, 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 blah. Don't worry about that. Most importantly, it's a way to run serverless applications on your clusters. Okay, so believe it or not, that was actually the majority of everything you need to know about how to deploy to the foundational knowledge, the building blocks, to be able to deploy something to Kubernetes. I realized I didn't talk about a lot of things because, believe it or not, you don't actually need to know a lot of things to get around to this. So I'm going to go ahead and not scare you anymore and remove that screen. So if you see here, this is OpenShift. Being that I'm supposed to only talk about OpenShift, it is Kubernetes, but I'm only supposed to talk about OpenShift. I'm going to be doing this through the OpenShift interface so you can see this. There are CLI commands to do all of these things, but when you understand the power of what I'm about to show you, you'll understand that running your application in a production-like environment is pretty quick and straightforward. So first thing first, first of all, any questions? No? Okay. So we're going to create a project first. How about KubeHuddle? Because I'm what's the word I'm looking for? Original. Go ahead and create that. There you go. You see how easy that was? I have this amazing application called the Cloud Native Python Example app. Again, I'm great at naming things. And we're going to go ahead and grab this. And we're going to go ahead and grab this. And if you haven't seen my amazing application, here it is. And this is the last place I don't even remember what WDI was, but that's this amazing application. Hopefully you don't steal this from, oh, it is open source, so I guess you can't steal it from me. So what we're going to do is, as you notice, I'm a developer here. There's also administrator where you can do some really things, but installing operators and things like that. But we're just going to take this from a developer standpoint. All right. I'm going to go ahead and install it from Git. I'm going to go ahead and plug that in there. Hey, look, it was already smart enough to figure out that it was a Python application. That's pretty nice, right? Like I didn't have to do anything. I just put the Git repository in there and it figured that out. I'm going to run it on 3.8 because if you're running Python 2, we should probably get a beer and talk about why you're doing that because that's very sad. Something if you've never heard of the concept of the UBI, that's a universal base image. That's a Red Hat supported container. Think of like Alpine is a good way to describe it, but it's the Red Hat version of it. The beauty of it is it's supported by Red Hat. Again, if you're building your business on this, you can actually like leverage Red Hat for stuff, which is neat. I'm going to call this Cloud Nathan. There we go. And what we're going to do, call it KubeHuddle. And then just because I don't want, this is weird. I don't want, what's the word I'm looking for? Name clashes, we'll call that. As I said earlier, we're going to create a deployment. Is this big enough for everyone? Do I need to make it bigger? So the name is the unique name component that built the actual thing. The application name is when you start having multiple applications inside of the actual project. So you can have multiple application names inside of it, so like microservices. Does that make sense? Yeah. Cool. As you can see here, I'm going to create that nice little deployment. And then there it is. I don't need to worry about routes. I'll make that a little bit bigger. As you see here, it's just a checkbox, which is pretty nice, right? So imagine doing this for all of your microservices you need to expose. All you got to do is check a box and then uncheck it to expose it. So we'll go ahead and create that real quick. And don't make a liar out of me, please. There we go. You even get a fun little GUI. And we're going to wait for that build. So as you see here, it's going pending. You can actually already look at the logs of what's going on. I'm going to make this smaller because the screen is not the size I was expecting. See, awesome at IBM.com, just saying. Okay, as you see, it's pulling it down. So while that's happening, I am going to, I didn't set this up, so bear with me. I just went brain dead. I'm looking for webhooks. All right, I'm going to delete that webhook because I was supposed to delete that before this talk and I didn't. Now, the actual thing that convinced me why OpenShift is so damn cool is that they have built-in webhooks. So we've talked about GitOps today. We've talked about a lot of automation. This is actually built into, like you can do Argo CD, you can do Flux CD, I don't know about Rancher, on OpenShift. But from the very, very beginning, as you'll see in just a moment, you have a built-in Git process with using webhooks here. So as soon as this is done, you'll notice, oops, I need the build config. Where'd it go? There we go. Nope. Must still be running. Okay, go back here. So, yep, still running. So as soon as this comes up with a build config, I'm going to grab that and actually give it a webhook with this new application. Here we go. Here's our build. There's our route. So if we go over here, oh no. No, there we go. God, I was really worried for a second there. So as you can see, sorry, go ahead. Did you want me to remove the person that made the last move? I think you do. Yes, please. Come on. Get out of here. So there we go. We got our application. As you saw, it was literally 3 clicks, and I already installed a Python application. First of all, just take a moment and realize that, right? Like, I did this in front of everyone with a little bit of heckling. Yeah, a little heckling. And I was able to deploy a simple Python application. Cool. But that's not the cherry on top. The cherry on top is actually getting this part of our CD platform. Of course, there's always to do CI, but who does CD today? Continuous delivery. You are all lying. Nobody actually does continuous delivery. Come on now, right? But what we're going to do is we're actually going to turn this on so there is actual continuous delivery. So if I come over here and go to details, no, where'd it go? Did they change this on me? Pause services. There used to be a build config. Oh God. Here we go. So as you see here, there's already built in 2 webhooks. There's the GitHub one, so we already have it. So I'm going to go ahead and copy that URL right there. I'm going to go ahead and throw this in here and add a brand new webhook. Everyone knows what a webhook is? Yes? Thumbs up? How about nobody? Who doesn't know what a webhook is? Okay. Oh, you don't? Are you just trolling me? No. Okay, so the easiest way to say a webhook is a way for something else to receive a JSON blob or some level of data when an action happens. So I'm going to make a change to this code, and it'll send off this webhook to this URL, to our OpenShift cluster, and it'll trigger the rebuild. So I don't have to do anything. It'll just make it happen. Now, of course, in the real world, you have some level of CI in front of it or some testing in front of it, but because, as the cool kids say, YOLO, I realize they don't say YOLO anymore, but I've got gray in my beard, I'm allowed to say it. As the kids say YOLO, we're just going to YOLO some code out to it and make that change. All right, JSON, and then because I like living dangerously, it's going to be everything. And as you can see already, the checkbox to say, yes, it's actually there. I was already able to find it, which was great. So then, all right, I'm not speaking at I don't even remember what DTR I was. Go back over the code. And of course, there's a lot more in here, but we don't care about that right now. Go ahead and edit this. And I'm going to be at KubeHuddle, and I will forget again in about 6 months. And of course, as you can see, you can have like health checks and whatnot inside of it. You know, custom header of awesome, of course. But, you know, whatever. I'm going to go ahead and commit those changes. And then, if we come back over here, already, because I can't figure it out, you'll notice it's already started kicking off the build, right? Like one webhook already hooked up to OpenShift, and now already that's been deployed.
Beauty of it is it's smart enough to realize and actually spin up the application for us. So if you watch this very quickly, as soon as the build's done, now build is done. Done? What are you doing? Oh, storing the signatures. It's important. Yes, it's just a fishhook. I like that. A webhook is just a fishhook. Just grabs you and just pulls you along. No, nothing. Nobody else laughed. I'm so surprised. All right. Go back to the builds here. Here we go. And as you see very quickly, it's actually smart enough to, say for instance, you have a Java application. You don't want to hear a Java joke? Pretty funny, right? Come on, no? Okay. But if you had a Java application, it took a little while to start, for instance, this would be great because it would spin it up, it would build it, if it tested and started, it'll actually wait, and then as you see here, it already did the cutover for us. So it waits for the health check to come up to make sure it happens, so then we can come back to our application and see. See? Oh, come on. Ah, okay. What the hell did I just do there? I thought I was doing a hard refresh. Yeah, no, my luck. There we go. Oh, no. Ah, too many buttons. There we go. So as you can see now, that was it, right? So the short of it is, what did I just do in front of you? I deployed a simple Python application with a handful of buttons. If you're a downstream developer, put yourself in that place right now. Imagine what they could do with that power, right? Now they don't have to worry about anything around it. It's basically back to the old Heroku days, if you're gray like me. And remember how easy it was to deploy applications. Now they can deploy it in an environment that they can do what they need to. Of course, you can build stuff on top of it and do more with it, but there's amazing things you can. So that's all I really got. Thank you.
How much more difficult would it have been to do it from the CLI? Because a lot of those downstream developers you're talking about hate the interface.
Great question. So how hard would it be? It's actually easier. It's a handful of commands at most, where it's smart enough to, I think it's 3 commands total, but if I did that with 3 commands on here, it would be even shorter than 15 minutes. So I do it through the GUI to eat in some time, but also so people can see that you have all this information, because what I'm trying to tell you is someone who runs an OpenShift cluster, or a Kubernetes cluster for that matter, is you're a platform engineer now. You've built a platform to get them to build the work on top of it. You've got to put yourself in that space, because that's the only way you're going to be successful with this stuff. Did I answer your question?
Yes.
So a hand go up here. So on the hosted OpenShift you're doing that, how are you charged? Are you for every time the application's running, for creation? What's the sort of pricing model? I mean, because you can run it yourself, I guess, but on your own hardware. But in that, you're using a hosted.
Yes. So do you want the corporate answer, or do you want the engineer answer? The honest. So the short of it is there's a lot of different ways to skin that cat. With all software, there's always nuances to the work. But if you were just John Doe coming in and just want to play with it, first of all, there are free tiers of running this stuff. They've actually gotten it working on Raspberry Pis. So you can actually run a single node OpenShift cluster on a Raspberry Pi and do some really interesting things with IoT and GitOps and whatnot. Which is just basically become a container platform to run all this, but you still have that interface and all that. But when you start looking at production level code, where you're actually going to build a business on it, you can go through AWS, AWS, Azure, IBM Cloud, Alibaba, Oracle, all them have an offering of OpenShift on top of it. And the beauty of it too is when you start looking at hybrid cloud stories, OpenShift is OpenShift is OpenShift. It is the exact same thing on all of those clouds. So again, as you start looking at it from a platform engineer level of understanding, now it doesn't matter where you run your application as long as it's running on OpenShift.
So you just have to bring compute resources.
Exactly, exactly.
So there's no, IBM didn't have an offering of just running the containers sort of thing.
So that's actually Code Engine, which is this right here, which I can dig into a little bit deeper when you want to just talk about running just like serverless level stuff or just a container here and there. I'm actually a true believer in Code Engine. Out of all the different serverless platforms out there I've seen, this was actually Code Engine was the easiest one for me to get going inside of. So, cool. I'm a Pisces.
You mentioned Universal Base Images, UBI,
Yes.
in passing there.
Yeah.
How do they compare size-wise to Alpine?
Actually, good question. If I remember correctly, the last time I looked, which honestly was going on at least 60 days ago now, there was about 100 meg difference, mainly due to some of the 100 meg difference on the UBI side, because there is still some of the Red Hat thingies inside of it to be able to get DNF working properly and all that jazz, which is obviously different than APKs or APT. It's not apt. It is APK, yeah. Question my own thoughts here. But there's a little bit difference there, but it's in the grand scheme of things, it's negligible. Anyone else? I watch a lot of Netflix. Oh, yes.
So looking at the config in the repo, you've got effectively OpenShift is a CI/CD platform and also the shared Kubernetes model as well. Can you talk a little bit about how are you configuring the build and how are you configuring the deployment? And is that kind of abstracted by OpenShift, but ultimately you would still need to supply Istio config. You would still need to talk about different Kubernetes objects that you're providing via Helm, that kind of thing.
So there's actually many layers to that conversation, but to answer this simply, first of all, it is a whole hog choice of all of the landscape.cncf.io choices from Red Hat that Red Hat supports. So that's the reason why we had built-in CI/CD there, right? Like we just had a couple clicks, it just did it. I think it's actually Jenkins in the background. But it just works, right? So I took all the same defaults that it gave me, which is great, right? Like to show off a nice demo. When you start actually playing with something like an Istio config or an actual serverless mesh, you can absolutely get in there and start changing things around. Like if I remember correctly, I'm going off script, so bear with me.
Are you supplying that in your repository as well?
No, I literally just grabbed this. I just grabbed this directory here, and the most it needs to know is the app.py and this Docker file, and it's smart enough to realize, oh, it's a, all right, I think it actually reads the requirements text. So it's like, hey, there's a requirements text, an app.py, and a Docker file. Cool, it's a Python app. I just should compile it and see what happens. But if you wanted to dig in there to play around with the YAML and to be able to make very specific changes, for instance, this build config right here, you have access to all that information right here, which for most people is out of scope trying to understand this stuff, but you can absolutely go in there and change the things around. With that testing, or with the build that I was saying with, I think it's Jenkins, somebody keep me honest, you can actually put in build steps inside of that build config for it, so you can make sure it runs PyTest or Mocha if you're doing a JavaScript app or whatever, to make sure that passes before it does the build. Does it make sense?
Yeah.
Cool.
Any other questions? Okay, we've got a hand scare for JJ.
JJ is also available for birthdays, bar mitzvahs, but only for his puns, I'm
I
afraid.
can put those up while the next person's coming up. I'm just saying, just let that go.
So it's now a break till 16:30. Okay, go get some coffee.
to be here, and I was a bit overwhelmed this morning with the keynote and everything. I did take a nap now, so I feel much better about everything. Today, I will talk a bit about secret management, the soft way. Why the soft way? I guess since we're all familiar with Kubernetes, I guess you probably have heard of Kelsey Hightower's Kubernetes the hard way. And I was like, why does everything have to be hard, right? Why don't we just make things a bit easier? And I hope that, like the things that I'm going to tell you about and what I'm going to show you is just a way to like make secret management a bit easier or softer. So my name is Lian, and I'm a developer advocate for Loft Labs. We build tools to make development on Kubernetes a bit less painful. I'm based in the Netherlands in Amsterdam. I'm originally from Germany, so in case anyone else is from Germany, happy October 3rd, today's German Unification Day. Yay! Which would normally be a holiday, so yeah, we're not there. So if you want to reach out to me to talk about anything that I said now, this morning, or I'm going to give another talk tomorrow, oopsie, you can reach out to me on the Bird app, also known as Twitter, or you can send me an email. You can also try your luck to add me on LinkedIn, but I'm not going to look into that. I'm just going to assume that you want to sell me something. So I have a background in software engineering, and I also worked as a cloud native consultant for a couple of years, basically helping our customers move into the cloud. And those are a lot of times were people who have never even used microservices before. So a lot of what I'm going to talk about today and also tomorrow will be coming from the pains that I've seen people have in big organizations when they're starting with cloud native technologies. All right, let's just jump right into it and talk about Kubernetes secrets. So if you have worked with secrets on Kubernetes before, you probably have noticed that if I have access to a Kubernetes cluster, read access specifically, I can see all your secrets, which is not good, by the way. And the problem lies with this secret resource that Kubernetes comes with. So it has this data field here, and there's the keys and then this value. And this value is not encrypted, it's obfuscated, it's base 64 encoded. So as I said, anyone who has access to read this can just copy paste the data and then run it through a decoder and then knows the value of these secrets. So in the olden days, this was a fairly simple solution. You just don't give people access to the cluster and then they can't read it. But nowadays, we are in this age of GitOps. There's a bunch of GitOps talks. Victor, I don't know if he's here, but he has been talking about GitOps for a long time. And that's kind of how we're supposed to do CI/CD now. We're told that this is the way like modern software development, and especially on Kubernetes, is being done. And yes, GitOps has a lot of advantages to it. So you can, for example, deliver all your resources in one place in your GitOps repository. And you can then use the built-in access control that Git already brings, and you don't have to come up with anything by yourself. You also can have a history of the states that your environment was in at any given time, with a little caveat that there's no guarantee that this was actually the state of your cluster at that time. It is like the desired state. There are tools, I think one is called Koslin, that additionally monitor your cluster. So that is actually something that can actually tell you this was the actual state. And also, second caveat, the history is generally persistent, but it's still technically possible to change it, and it's not entirely immutable. But there are ways that you can mitigate that risk of unauthorized history changes. For example, you can protect branches, and you can allow changes only by merging pull requests and all of those things that like tools like GitHub or GitLab would give you. But on the downside, though, devs, they will probably have some kind of write access to this repository, so they can deliver the application and the configuration of their application on the Kubernetes cluster. And if they have write access, they probably also have some kind of read access. And if all resources, including secrets, are delivered in the same repository, then we're back at the beginning where developers can read the secrets. And I certainly have some opinions on whether DevOps is an anti-pattern that doesn't really solve anything. In this particular case, because we're doing DevOps in this sense, it means that devs who manage their application as well as the configuration of the platform, that breaks the separation of duty, and that leads to this problem that we have now. Sorry, I'm getting a little bit sick, so I did a corona test though, so I'm good. But it's going to be tough for karaoke tonight. Oh, shit. Okay, so I want to take a step back and just talk about something more general, which is the concept of desire paths. And desire paths are basically paths that are created by erosion by animals or humans who pass through the way that is most convenient for them. And I'm sure you've seen that in your daily life, especially when your solution is very, very badly constructed, like the example on the left, or just really inconvenient, like on the right. Nobody will use it, and instead they will use this, like this desire path will be created. And the more that happens, it will weaken the overall structure of your product and organization, and it will make things less secure. So when we really want to understand the developer's desire paths to find the right solution, we have to think about what developers want, right? What are their desires? And I've come up with an example for this talk, but for this example, I have thought about a couple of priorities that I think would make sense, but it might be different for your organization, right? So just, take the things that are applicable for you and then just ignore everything else. The most important thing that I think we have here, the most important desire, is that we want to consume secrets consistently across environments. So what I mean by that is, I've sometimes seen in code that there's like an if-else statement that says, if I'm on dev, then read the secret from here and do this, and if I'm on prod, then do something else. And that is really not good, because your application shouldn't know that much about where it lives. I also want to keep the secrets out of the hands of developers, not because I don't like them, or even not because I don't trust them. It's kind of the thing that I talked about today, about the impact, and that well-intentioned people, without any fault or maliciousness, can make mistakes. And if a developer's account is compromised, we wouldn't want that account to have unnecessary access to things that are just like really dangerous, like all kinds of production database credentials or similar. Ideally, I would also want the devs to have a very good experience when they work with secrets. If it's like something super tedious, you have to open a Jira ticket or something, and then you have to wait for another team to respond, and blah, blah, blah. It will just get super messy. And whatever nice architecture and processes we designed, it will just not survive the first encounter with reality. So that's kind of the desire path theory here. And then finally, I would want to build this as much as I can with open source tooling. For one thing, I think open source is great. I want to really support it. But also I think that if we know exactly how tooling works, and also where the potential vulnerabilities are, that will first of all improve our trust in it, because I know what's happening under the hood. But if I'm able to now see the vulnerabilities, I can mitigate them at other places, and that will make my entire application safer. So the example that I was thinking about to showcase what you can do. What I want is, at the end, I want a secret like this to live on the cluster. It has a name called test secret, and then it has these 2 data points. There's the environment on which it lives, and then the source. So this is coming from a YAML originally, so this would be YAML. And then I want a pod. I want something to consume that secret. And the way that I'm doing it is that I am mounting the values of the secret into the environment, and then I'm just echoing the secret here. goes without saying, don't do this in production. Like, don't echo your secrets into the container. Just making sure that you know that. And this is exactly what I mean by consuming consistently across environments, because this is the same no matter whether I'm in development or in production. The only difference is the secret. It's just it's a different secret, and the pod doesn't know anything about that. So this will be our test case, and we have a bunch of options. We have more than 2, but I'm going to talk about 2 options to solve our problem. Option 1 is that we encrypt the secrets before we put them into our GitOps repository. So even if our devs have direct read access to the repository, they still won't be able to read the actual contents of the secrets. And to do that, I'm going to use a tool called sealed secrets, which will just allow us to encrypt the secrets locally and then deploy them as a custom resource. The other option is to store our secrets elsewhere, and in the GitOps repository, we only reference that secret that's somewhere else. So in the example that I'm showing, we'll store our secrets in HashiCorp Vault, and we will use the external secrets operator to connect to Vault, pick up the secret, and deploy it into our cluster. All right, so first option, sealed secrets. In this architecture, it's a very simple. We have a Kubernetes cluster, we have this GitOps repository, and we have the developer's machine. And the reason why this is like a drawn through line and this is a dashed line is because this is so the dashed lines are in the responsibility of the developers, whereas the drawn through lines are things that are in the responsibility of the ops team. And it doesn't have to be this way. This is just what I think makes sense, but it could be different for your organization or, really what makes the most sense for you. And so we start with the sealed secrets operator in the cluster. Now, in case you don't know what an operator is, basically it is a controller that lives on your cluster and will constantly monitor the state of the cluster, specifically for custom resources that we can define that operator is kind of like programmed to do. And if it detects any changes of state changes of the custom resources that it monitors, then it will do things depending on what is defined in that operator. So we have the sealed secrets operator, and then when we install it, it will create a private and public key pair, and we will need that to encrypt and decrypt our secrets. As a developer, I have to grab that public key, and then I can take a Kubernetes secret and use it to, or use the public key to encrypt it and make it a sealed secret. So now, on dev, you can do this on a development machine. In production, this probably should not be on the developer's machine. Instead, it could be like an automated system where you just auto-generate a database credential, and then you have like a technical user or something that will seal the secret and then put the sealed secret into the GitOps repository. So this is how the sealed secrets resource looks like. It's pretty straightforward. It's of kind sealed secret. You can give it a name, and that name doesn't have to be the name of the secret that you want in the end, because in the specs you can define a different name. And this is the interesting part. We have this encrypted data field, and the keys are still unencrypted, but this value now is completely encrypted, and even if you have the public key, you are unable to decrypt the secret because you would need the private key to do that. So once you've sealed your secret, you can now put it into the GitOps repository, and whatever mechanism you have to deploy things will then pick it up and put it on the cluster. Now the operator, as I said, will constantly monitor the state of the cluster. It will see there's a sealed secret now, and then it will go take the private key, decrypt it, and we end up with a Kubernetes secret. And now I'm doing something really dangerous, which is attempting a live demo. So, okay. Can you see that fairly okay in the back? Can you read this? Okay, cool. So, I'm gonna also work in a little bit of vCluster stuff because I have to, contractually obliged. So, I am running vCluster on my local machine. So I have a Docker desktop instance running. I have the Kubernetes cluster enabled there. And just because I want to simulate that I'm on separate clusters, I just spun up these virtual clusters. And I can list them, and I can see that I'm connected to the sealed secrets cluster, which is good because that's what I want. And then everything else, it just behaves exactly like a Kubernetes cluster. So I can get nodes, I can get namespaces, and I can get pods. Okay, so what I can see here is that there's nothing on it besides the sealed secrets controller that I already installed in the default namespace. And what I want to do now is actually cheat a bit and read the documentation because I don't know just from memory what I need to do. So what I want to do is, as I said, I want to grab the public key, seal my secret, and then deploy that sealed secret. And what I expect is that the sealed secret will be automatically unsealed by the controller so that my application can just read it because it's mounted into the environment. So there we go. The first thing that I want to do is I need this tool, CLI tool called kubeseal. And kubeseal comes with the sealed secrets operator. It's just the client CLI for it. And as I said, the first thing that I want to do is to grab the certificate. I'm sorry, I should have prepared that better. So this is the command to do that. So it's like fetch certificate, and then you have to tell it where the controller lives in, and pass it into this file. And we can also take a look if we want to. It is just a public key. There's nothing special about it. So the next thing that we want to do is we want to use that now to seal our secrets. And that's, again, a kubeseal command where we pass in the certificate and the format. We want it to be YAML. By default, it's JSON. And this is the secret that I'm feeding into it. I actually want to maybe look at that at first. So prod. So this is the secret. It's pretty much what I showed you before. So there's a namespace defined, which is where our application will later live. And it has a name. And the end value is prod. And then it says YAML because we're starting with a YAML. So I'm going to now seal this. And then we can look into the sealed secret. And that's what it looks like here. So we have the sealed secret resource type. We have this encrypted data now, and the rest is just like auto-generated. Again, it's nothing like magical or anything hidden here. So next, I'm going to create the namespace that I want to have my application and the secrets live in. So now I'm going to just apply that sealed secret that I just created. So I'm going to do that. And then I have a application that, again, it's the same application that I'm going to deploy for every example, I'm only going to show you one environment because we don't have that much time. But this is also what I've shown you before. It's just going to echo stuff from the environment. So I'm going to apply that. And then we should be able to now see yes, so now we see that it has successfully logged the contents of the original secret. And we can also maybe if we want to be super exact about this, just look at this secret in detail. So here we see that this is named test secret, it's in the right namespace, and we see this owner reference here that tells us that it started as a sealed secret, and it has now been made into a regular secret. So, there. Yes, I'm also speechless because this demo just worked for no particular reason. Thank you. Okay, so to summarize the sealed secrets part. With sealed secrets, you do have to manage the secrets somewhere else, like their life cycle and everything. Sealed secrets does not do any of that. But the good thing is that you can deliver these sealed secrets together with the rest of your resources in this GitOps repository, and there's nothing else that lives somewhere else that's super important besides the cluster, obviously. But this can be a plus or a minus, depends on where you're standing, what your preferences are, how your organization looks like. You can also share the public key. So once you grab that public key, you can just share it outside of the cluster. That's fairly safe because you can't do anything with it besides just encrypt secrets. So as a developer, you don't actually need the access to the cluster to grab that certificate. You could just have an admin do that and then just share the secret. The downside, or the thing that's important to understand, is that because every time you install the operator on a cluster, it will generate a new key pair. So for different environments, you have to reseal the same secret with the different certificates. There is technically a way that you can take a private key and put it on a different cluster, but this completely defeats the point of it. Once the private key leaves the cluster, it's kind of pointless, because then you're breaking the security. The only thing that it's trying to do is to keep that private key on the cluster. So don't do that, but it's possible to do it. If you wanted to do it for development environments, I guess that would be fine. If everyone just spins up a dev environment, you could probably share that private key because it's just local and it doesn't affect any production data. Okay, so on to the second scenario. So in this scenario, we have 4 components now. So we still have the original 3, the cluster, the ops repo, the dev machine. Now we have this HashiCorp Vault thing, which I put in a dotted line because by the time that you run something like Vault, maybe it makes sense to have your own security team. But again, it could be that Vault is just managed by your ops team. Whatever, depends on your organization. And in this scenario, we start in kind of a bit different, where our original secret is not a Kubernetes secret on the dev machine, but it's stored as an entry in Vault. And on the cluster, there's now an external secrets operator. And that external secrets operator has a service account, and that service account we will need to later collect to the Vault. It will have a role and a policy in Vault that corresponds to specific entries and specific verbs. So the role and policy can be very granular. It can be you're only allowed to read this one entry, and that is then tied to the service account of your Kubernetes, of the external secrets operator. To be able to connect to Vault, the operator needs a secret store, and that is that's kind of very important. That's why we're going to look at it a bit closer. So it is, again, fairly straightforward. There's 2 kinds. There's a cluster secret store that you can use from everywhere in the cluster. You can also just use a secret store that's namespaced. I just named it Vault backend because that secret store connects to Vault. And then here you specify which secret provider are you using. We're using Vault, so we have to pass in a URL where we can connect to Vault. There's a path, so we're using the key value store. And we also tell the external secrets operator how you can authorize. So we're saying, this is a Kubernetes auth, and it's mounted behind the path Kubernetes, and the role that we're trying to assume is called ESO role. So we have that secret store that lives on the cluster, so it's accessible to the operator and the service account. And now on the dev machine, we have an external secret. And the external secret is not the actual secret. It is just a reference to the secret. So that's what the resource looks like. Again, we have, it has a namespace. This has to be namespaced, I think. And here we reference that secret store that I just showed you. And what's super cool about this is if we decide to move our secrets now to, GCP or something, all we have to do is replace this cluster secret store or the secret store here. Everything else can be exactly the same. So the developers don't even have to care too much. You just change that. You just replace that secret store. And then you define kind of the specs of what do I want the secret to look like that you're going to create for me, that Kubernetes secret. So I'm just saying okay, there's a name. Go to Vault, there's a secret, or there's an entry called test secret. It has a property env, and then map that to the env key on the secret that you're going to create. So the developer will create this external secret to reference this entry in Vault, put it onto the GitOps repository, and whatever mechanism, again, that does the deployment will pick that up and put it on the cluster. The external secrets operator will monitor the cluster. That's the same as the sealed secrets operator is doing it. And once it sees there's a new external secret that I haven't seen yet, it will now talk to the service account. The service account will look into the secret store, will go to Vault, assume that role, and then grab that entry. Once it has an entry, it would go back and just create a Kubernetes secret out of the values inside that entry. And now we will attempt to demo this. I'm just really confident today. Okay, so I'm gonna go here, and then I have to switch my vCluster. So this is, as you can see, it's fairly easy, and I can also like pause the other cluster because I don't need it, and then I can. That's what I usually do because I'm just too tired to always constantly set it up again. So I just pause it, and then it uses minimal resource or like no resources, and then I can spin it up later. So I am now on this other new cluster, and I have two namespaces here that I didn't have before, which are Vault and the ISO for external secrets operator. So I just previously installed that already. And we can also look at all the pods. So we have the Vault, we have the external secrets operator. The Vault runs with the console backend, and then all just the stuff that comes with the installation. I installed all of this with Helm, by the way, so I don't actually know how it's installed. Sorry. Okay, so similarly to before, we want to have our operator create a secret for us, and then use this pod to verify that we have actually correctly deployed a Kubernetes secret. So I had to do a bunch of like authorization stuff, and the Vault actually lives on the cluster. It doesn't have to, but just why not? It just makes a lot of things easier for me. So the secret store is pretty much what I showed you already. So I'm just going to apply that. Actually, it already lives there, so I didn't have to do that at all. Then what I'm going to do next is I'm going to create this entry in Vault. I don't actually have to create this entry. It already exists, but I just wanted to show you that I'm doing. Oh, okay. I remember that I have to first export the Vault address and do a port forward. So I can talk to Vault, and then I'm going to probably, yeah, that's probably best. Oh, I have to actually export it here. Damn. Okay, so now I should be able to. Oh, Vault is. Oh, okay. Another thing that I constantly forget is that if you don't use it for Vault format, it just automatically seals, which is good, but also really annoying. Okay, just bear with. How much time do I have?
15 minutes.
Oh, okay, that's fine then. So. By the way, since we're in the UK, have you ever noticed that Vault says unseal nonce? I just feel like this is not good. It makes me feel weird. Like, what does it mean? Okay, so you have to type in 3 different keys to unseal your Vault, and then I can log in with a token. And now I should be able to. Okay, yes, I did. So this is version 4 because I've done it 3 times before, and I just put this entry that is environment equals prod, and then the source is Vault this time because we're not starting with a YAML, we're starting with an entry in Vault. Oh, by the way, for people who are not British, nonce is like a pedophile, so that's why it's weird. Okay, so we're going to create a namespace, again, where we want things to live, and then I need to actually go to my path, and And we're going to take a quick look at the external secrets. It's nothing new because I just showed you that on the slide, but just so we've done the dance. So again, secret store ref, and this is the mapping and the specs for the secret that we want to have created. So I'm going to now apply that external secret. It has been created, and I am next going to apply the pod. So I'm gonna look where it is. Does it? Oh, great! Well, I was just way too overconfident then. So who is up for debugging a container right now?
Live debugging.
So I'm sweating so much you don't have no idea. Oh, it's because the test secret was not found. Okay, why was it not found? Secret synced error. I swear it worked like 60 minutes ago. Okay, I'm not going to waste everyone's time now. Unable to create client, invalid provider config. Oh, wait. No, I did that correctly, I think. I was thinking whether I put in the... Should I have exported the address before I installed the cluster secret store? But I did, and it should be fine because the secret store lives on the cluster, obviously, so I don't need to port forward anything for it. Okay, whatever. So this would work probably on your own machine if you tried it. Yes, exactly. It's totally not because I did something wrong. It's just all of your fault. Anyhow, I have a sorry. We have I have a repository, so you can check it out there. You can try it out for yourself and tell me what I did wrong if you find out. So anyhow, with everything running in Vault now, we have no dependencies to cloud providers. But if you're already running your cluster on something like EKS or GCP, you might already be using their secret management solutions. Yes, you have them. What?
No, I actually... No.
Yes?
It was you only, but on YouTube.
Okay. Yeah. Thanks. That was very confusing. So, okay, you might already be using the secret management solutions, and it might make sense for you to just not use Vault, but instead use whatever you're already using, and just tell the external secrets operator to retrieve the secrets from there, which, as I showed you, is fairly not easy, but like straightforward. In any case, though, it's nice because now you have something that can manage secrets. So you don't have to do it yourself as you would have to do with the sealed secrets scenario, whether it's Vault or something else. And I think in Vault, it also allows you to create a secret without ever knowing what the content of the secret is. So you can just say, I need password, username, but you don't ever see it, and you can create this external secret without ever knowing what the content is, and that makes it really safe. And if you use something like Vault, you already have all the security best practices built in. You have to rotate, for example, and you don't have to think about that yourself. Vault will probably prompt you to do it. But on the downside, if you can call it a downside, it is quite an elaborate setup. So it's definitely not something that I would recommend if you're 3 people. And unless this is your business, unless you're working with secrets and security. But yeah, so if you're 2 people just trying stuff out, maybe go with sealed secrets. Once you scale up, it's definitely nicer to handle it like this than manually sealing secrets for 100 people or 100 clusters, which, again, don't recommend running 100 clusters. So you can, as I said, go to this repository. You can scan the QR code, which I promise is super safe. No Rick Astley there. It just leads you to that GitHub repository. I will give you a moment to take a picture if you want. I'm really glad that no one's taking a picture because I gave this talk once, and before I even said anything, people were just like taking pictures. And I'm like, listen, we're in a security talk right now, and what you're doing is like the worst. So yeah, to wrap up everything, I want to just like talk about what we actually, the problem that we did solve and the problem that we didn't solve, because I was talking mainly about supply chain security. So how do we get a secret from the developer's machine to the cluster? And the Kubernetes secrets, though, they are still unencrypted. So as long as they're on the cluster, they are just, again, base 64 encoded. So if you really need it to be super safe, even on the cluster, maybe don't work with Kubernetes secrets. Instead, you can have your application read secrets directly from Vault. You can use it in a sidecar situation or in a container situation where the application, again, doesn't need to know where the secret's coming from. It just uses it. And finally, you need to secure a cluster. Always, always, always need to secure a cluster. I think Andy was giving a talk earlier about all the ways that your cluster can be hacked. Nothing I showed you today will solve that for you. And then, this Kubernetes, I love Kubernetes, but Kubernetes doesn't do everything. Kubernetes is kind of like this manager who says, first, I've decided we need an SQL database, and then second, I need you to tell me what an SQL database is. So Kubernetes manages resources, but with the exception of very specific ones like pods, doesn't really understand them super well. So Kubernetes doesn't know secrets, it doesn't manage secrets, it manages a resource that happens to be called secrets, but you need to actually manage the secrets yourself. And then finally, to go back to the desire path thought, security is not just about the tools and the tech, but it's a shared effort amongst all team members of the organization to have a security mindset. And you, as I said before, you need to make sure you're building on the paths that are already laid out instead of trying to force something new. And I have a final fun fact, which is that the technical term for people who use desire paths, they are called Neanderthals. It's an actual scientific thing. So yeah, thank you very much. And I think we have 5 minutes for question maybe, or 4. So yeah, hope you learned something. Okay, no questions. I can tell a joke or, oh, there's a question.
Some JJ to go us.
So picking up on what you said, and I agree in the sense that HashiCorp Vault, for some in small instances, can be a big tool to wield in terms of safely handling your secrets. Yeah. And maybe some people who are massive HashiCorp fans in the room won't like this, but do you think from your time exploring the space that there would be benefit in having another way that I could handle my secrets coming in and out of cluster, on a server, off cluster, or in some sort of external location? Do you think there could be a tool that makes it more easy for small businesses to get HashiCorp Vault-like functionality, but in a more Kubernetes native way, that doesn't even require you to map your secrets into Kubernetes secrets and integrates directly into the pods? Do you think that something more lightweight would be beneficial? And also, is there something that exists that anyone knows of?
Would it be beneficial? I mean, yeah, it depends. It always depends on the people who you work with, because if they are just not super familiar with something like Vault, for example, then using a tool that they're more familiar with this definitely makes sense. So as I said, if you're already managing your secrets in AWS Secrets Manager or whatever it's called, then yeah, I wouldn't then I'll also create a Vault or something. That is to me, a very obvious kind of use case where you wouldn't use the best possible tool, but rather one that will work for you. I know there's Mozilla SOPs, I think. I've not looked into it. I think that goes maybe into the direction of what you're thinking. I don't know if anyone here has experience with it. So those are two gentlemen that you can talk to about that.
Thank you.
Is that a question or volunteer?
No, I'm going to answer that as well.
Oh, you're going to answer. Perfect.
Just a bit of a recommendation. I don't know if anyone's aware of it, but 1Password's recently released a operator for Kubernetes. 1Password's a very user-friendly application. We use it widely in our business, and everyone uses it. And it does exactly the same as the external secrets operator, but you can also directly inject secrets as a sidecar. So it doesn't need to be that base 64 secret. It can go straight in as an environmental variable from the operator. So yeah, a good solution.
Awesome, thank you. I think there was a question here. Were you asking a question, or was it more like a statement?
Thanks. What is your opinion about that? Secrets should never be in first place in Kubernetes. I mean, I always think like maybe if they went away with ingress to say, okay, we have it defined, but the controller you can choose because when we introduced OCP in our company, for example, the people they jumped into this and lead to this situation you just described. So the question would be, what is your opinion about delivering it?
Yeah, generally I don't actually think it's, I honestly think if you can keep secrets outside of Kubernetes, it's probably best. Because again, as I said, if you build a system that just makes the kind of attack surface as small as possible, you're just like reducing risk anyway. So putting it somewhere else, using like sidecar injection or whatever other ways that I can't think of right now, I think is probably a better practice. But again, maybe it's not ideal for every situation. Which OCP are you using for, I'm guessing? So I think with OCP, the idea, the OpenShift, kind of to make it more user-friendly, as Kubernetes has this like nice UI and everything, that makes a lot of things easier, but also invites misuse, because now you don't have to know what you're doing anymore. It might be that the way that it's set up is very strict about things, but I feel like the more accessible you make things, which I generally think is good, the more strict you have to be with what's actually going on, because you will have more people having power that they don't actually know how to wield. So hope that answers the question. And I guess there's like people to go to the next talk or something.
No,
there's one more question.
There's one more question. I'm going to make it quick, I promise.
Okay.
I would like to hear your thoughts on the secret source CSI driver.
I have no thoughts.
Okay.
Well, what kind of thoughts would you like to?
I'm just interested, how would that compare to the solutions you mentioned? If, by opinion, that feels like a better solution.
Yeah, I don't think I have enough. I have enough information. I just know of it,
right?
And I like generally what it's supposed to do, but I haven't looked into it, so I couldn't tell you anything. But maybe someone else wants to talk about it. No, I'm sorry, no one wants to talk about it.
Cheers.
Okay, great.
Can we put our hands together for Leanne?
Thank you.
Oh, that's a lot of people. Yeah, hey everyone, I'm Kunal, and before we get started, let's do some polling. How do we do this? So if you just scan this on your phone, you don't need to sign up or anything. It's completely anonymous, so feel free to, I mean, there is profanity filter, but be yourself. Okay, cool. So we're going to talk about Kubernetes or cloud cost monitoring best practices. And a little plug, I work at Civo, so we're running an event in February in Florida, so if you're interested, we have keynote speaker Steve Wozniak, so yeah, check it out. I just added this slide after Merino did his plug, so I was like, oh, we're allowed to do plugs? Okay. Okay, about me, I'm Kunal. I work as a development manager now at Civo, and relatively new to the field because I just graduated like 2 months ago. But yeah, having fun, and I love scaling communities, I love building communities, I love content creation. I have a YouTube channel, I'm very close to 300,000 now, so you can check it out. I'm a CNCF ambassador and other things. All right. Work in cloud, sometimes literally. So I love skydiving, really enjoy it. Cool. No worries. So let's do the first one. How are you finding KubeHuddle? It must be updated on your phone. Can you see this question on your phone? Yeah, so just put in some words and it should start populating. Nice little word cloud. Subscription paid off. Yeah, it's like $240 per year. Not a plug. Yeah, I don't work for Slido. Okay, that's good. That's nice. You can take this as a screenshot later on. A lot of folks said awesome. The cuddle I needed. That's a good one. Cool. That's good. All right. Shout out to Rockwood. Okay, let's move forward. This is another little one I wanted to do before we get started. How much does your company spend monthly on cloud costs on an estimate average? What? I might use this for my post-talk analysis, so I'm having a very strong feeling that some people are just clicking random things. Should have put something like that, and maybe next time. Okay, cool. As a developer or as an individual personally, how much do you spend for your demos or whatever? Yeah, you can put that in. Good. Very nice. Cool. Who's spending $1,000? Who did second one? I didn't. I'm not participating. Okay, so all the people who did option second, third, and fourth, and fifth, check out civo.com. Okay, that's the last plug, I swear. And now this is another word one. So what are the challenges you face when it comes to cloud costs? Just throw your words in there. Yeah. Transparency. That's a good one. Tagging resources. Right. unified dashboard. That's a good one. Yeah. Which one? Cool. 17. That's a good one. Actually, I have a meme on that later on. Cool. All right. Which cloud provider you use? Yeah. I do have an others option in this. This is a multiple choice, so you can select as many as you want. I said Lindode. No, I misspelled it. Never mind. My apologies. All right, cool. Are you doing multi-cloud? Sorry, what? Oh. All right. The last one is, second last one is the tools that you use. Let's do this quick because I've been spending too much time on polls. Cool. Hope. Crying customers, prayers. If you want to take a screenshot of this is funny. Yeah. I'll take one. All right, let's move forward. Last one. No. Google, sounds good. All right. Cool. So we're talking about, what are we talking about? Talking about the cost monitoring best practices. So before that, let's talk a little bit more about challenges. We saw some good ones in the challenges that folks face in the word cloud. That was good. And this is a recent, basically a study that shows what are the challenges that folks face. So 45% of the firms indicate a growing pressure to reduce the cloud costs. 37% have been stung by unexpected costs in the last 12 months. This is a recent survey we did at our company. So Sivo is a cloud native service provider. And 34% feel locked into their cloud. We'll talk more about that as well. Some say it's too expensive, so many other things. Cool. And the top reason cited for staying with the big three providers was that they believe that the alternative cloud providers outside the big three are less secure, that they will suffer more outages, yada, yada. The next sort of challenge is that something we also saw on the word cloud was inability to track cloud spends, right? So when you talk about cloud sprawl, basically means you get like a sudden build. It's like a constant problem that many folks encounter. And it's basically when a company is unable to track, or evaluate the cloud computing resources. So you have a sudden increase of cloud instances or your services, even providers. Conflicts between teams. So your finance team is why is the bill increasing, or has it happened with anyone? If you have a finance team and you're not in good communication with them, because as a developer, you're, let's say, trying to do the most optimized thing, which may increase your costs a little bit. But the finance team, how do you communicate it to them, right? So there is somehow this miscommunication and this gap across teams. Over-provisioning, basically acquiring more resources than the enterprise requires to support the workloads of the organization. And this basically results in wasteful use of cloud resources and sometimes unnecessary costs. complex billing. So cloud bills are, sometimes it's not very straight. How many of you can relate with that? Yeah. Show of hands. Quite a lot of folks. Very good. I'm on the right track. So yeah, it's, all the jargon and the technical complexity or whatever. So there are many companies around this who unify or sort of like Grafana for cloud cost monitoring. There are some solutions out there for that. Okay, monitoring again, another challenges. So let's talk a little bit more about what are your goals. So when we talk about reducing cloud costs, like for your particular organization, apart from just reducing that, what other things do you keep in mind? Anyone? I can start. Like one of the goal can be like to reduce the cost, but also maintain the same sort of like speed and the quality of service, right? You don't want to reduce the cost and also make your product not very good, right? That's one. Yeah, cool. What do you think about when you think about reducing costs? What comes to your mind? Anyone? Sorry, I didn't catch that.
You want to make it transparent to service what they are costing, so they can reduce their own costs. You can't centrally manage the costs. Rely on people to reduce their own service.
Yeah. So thinking about like for your organization, like do you have well-defined operating model, and do you have a FinOps process going on? It does not have to be complicated, the cloud cost optimization, but it requires like some approaches and habits. It's not just about tools; it's also about some of the practices and principles that we'll talk about today. Cool. Let's talk a little bit more about the best practices. So let's talk a little bit first how cost monitoring tools work. You may have seen a few, like in the slide itself, there were like so many words so many tools floating around. So essentially it's like a translator between like the resource consumption and the cost. So if a pod costs like, consumes like 50% of the nodes in an hour, it will cost like 50% of that node's cost, simple stuff. And the Kubernetes monitoring tool, like as a bridge. So for example, someone said Datadog, Prometheus, and others. So they offer like very deep monitoring solutions for Kubernetes, and by which you can dive deep into the granular like metrics and everything. The node cost. So cloud providers like API billing and all these other things. So you just need to decide how cost is split between various resources like memories, CPUs, and all these other things. And then you join these together, and then you get like the total cost, which I have a formula for that. Like it's basically what I said in like a little equation, which I'll share later. Yeah, that's basically about it. And also building block for more complex products. So like cost per deployment, namespace, cluster, or something like that. Okay, and the best practice, obviously, setting budgets for your organization, pretty self-explanatory. Things that are self-explanatory, I'll just move past because I've yeah. If you check out my channel, I make like 4-hour-long videos, so I'm trained to be very slow. So we'll get there, no worries. Cool. Everyone is familiar with this one, unused and unattached resources. So basically the easiest way to optimize cloud costs is to look at unused or like unattached resources, right? So sometimes a developer may spin up like some server to like say test a function or something, and they forget to turn it off. Have you ever heard that? Yeah, you forgot to turn off your machine when the job finishes. So and sometimes you may also forget to like to remove the storage that is attached to instances, right? Does happen? Yeah, cool. All right. And this happens frequently. So the result is that the cloud bills, like whatever you're using, they will include the charges for the resources, like once they are purchased. Okay, but they are no longer using. So in the cloud optimization strategy, you should start by identifying these unused and completely unattached resources and remove them. Very straightforward. Idle resources. So this is basically something like an idle computing instance can be something like, you have a CPU utilization of like 5, 6, 7%. And when an enterprise receives like a bill for 100% of that computing instance, that is a significant waste. That is what idle resources mean. So another optimization strategy would be to identify such instances and consolidate the jobs that you're running on them, on fewer instances. Reserved instances, they are basically prepaid compute instances that offer significant like pricing discounts. So when you purchase this from a cloud provider, you select like an instance type and basically like a region and the availability. Okay, I'm going to do it for like I'm committed to using this for a period of, let's say 3 years or something like that. So in exchange, the cloud providers, they will offer you discount. Now note that if you're paying upfront, this also was I was talking to Alex about when I asked him, like, what are the disadvantages? So if you're paying upfront, you must do your research and plan based on your historic usage because you're paying upfront for the particular period of time. And spot instances, like since we talk about reserved instances, these are basically for like last minute purchases. It's different than reserved instances, but it can help you if you're using like AWS or Azure or whatever. So you can check that out if you want, right? The general perception is that it's ideal for like your web services, containerized applications or whatever, but they tend to be a little bit unreliable because they are not always available. They sell out. Heat maps. So when we talk about like shutting down some of the services when they're not being used. So for example, heat maps can indicate whether a deployment server can safely shut down on weekends, right? So who works on weekends? Very nice. Good. All right. So yeah, that's another one. The right size. So it's difficult to size instances correctly. When you have like millions of possible combinations to choose from. In addition to like server sizes, how do you estimate your server like size of your instances? Anyone? Apart from like obviously based on previous usages. Yeah, Ingin?
I'm a developer, so I take the biggest I can get.
Were you the one who did $100 plus? $100 plus?
You never gave them back.
Yeah, that's what I'm saying. So in addition to like server sizes, you can optimize servers for like memory, a database, computing, storage, capacity, graphics, throughputs, so on and so forth. And you can have different size nodes for different my vocabulary is different size nodes for different use cases. That wasn't so hard. Software licensing costs as well. It is a major component when it comes to cloud operating costs, and manual licensing can be challenging, but increasing the risk of paying for like unused software licenses. So you can find like some license tracking tools that can identify these idle, unneeded licenses and reduce your spend. I don't have much experience with licensing, by the way, but I knew this was one. Following a cloud native design, I'm sure most folks are. This is something I've seen that at these conferences we say cloud native and move to Kubernetes and stuff. But when I go to smaller meetups and I ask them, are you using K8s? They're like, no, we're not. Why? Because it's complex and it's hard to onboard. Has it happened to anyone else? Like you see it on social media, the K8s buzz. When you talk to a company, like, do you use K8s? And then no. Yeah, maybe one for another talk. So the way I put it is Kubernetes is hard so that the applications can be simple. And I think Kubernetes being complex is one of the features of it. So it's complex so that applications can be simple. So yeah, that's that. Replacing your existing cloud system with like a more, let's say, cost-efficient one to leverage the capabilities. For example, you can like design a system with auto-scaling to ensure that you only pay for the servers that you use, right? And you should design it based on, your design basically should balance the cost optimization, the performance, because what we were talking about earlier, like reduce the cloud cost to the minimum. All right, done. But now the product is very bad. No, you have to maintain that the performance and cost optimization and other considerations by your organization, right? Cool. So for example, like a DevOps pipeline in the cloud might not reduce the costs, Multi-cluster stuff. So Kubernetes multi-cluster, basically creating multiple clusters when running workloads, and you can define the resources and the availabilities and the flexibility accordingly. So this basically allows organizations to provision their workloads in like several clusters rather than one, as the name suggests, multi-cluster, as is also known as multi-cluster orchestration. Now, some of the actions you can consider in order to optimize your resources and keep the cloud checks when it comes to Gates multi-cluster is the managing the node density. So basically the number of nodes running in a cluster, which is obviously critical when it comes to cost optimization, but it's also important to ensure that your team is running the right number, the right size, and the type of node in your cluster as well. The second one is the pod sizes, right? So which is something we I touched upon previously, but to manage the cost of your Kubernetes clusters, you have the resource requests and the limits that you can use for optimal performance, but not so much of the wastage. So you can examine your pod usage, and then you can basically consider to add in requests and limits, right? And then the next one that I already mentioned in this previous slide was auto scaling. So you have the auto scaling capabilities in Kubernetes, so you can figure out the right number of pods and nodes and clusters depending on the needs. Thank you. Multi-cloud. Who uses multi-cloud approaches? Multi-cloud is cool. Multi-cloud is good. So one of the reasons I talk about multi-cloud is to prevent vendor lock-in. Some enterprises they reach out for multi-cloud solutions, or because one thing you also have to talk about is so if you're using multiple, if most of your, I have a slide for that. So if most of your services are on like one cloud, might not make sense for like a multi-cloud approach. But when we talk about, let's say, should companies take a multi approach? So it's good so that you don't have like all of your eggs in one basket. No, not like a one size fits all solution. You have varied workloads. So you're using AWS for something, you're using CO for something, you're using DigitalOcean for something, you're using Google for something, right? And you have the based on performance and cost and the type of environment. Cool. Very close. And one thing about hyperscaler was there are like some hidden costs. And this was also someone wrote on the, can you see the meme? Yeah. So basically there's 17 a lot, depends on the context. Dollars, no. Ways to deploy containers on AWS, yes. It's also like, the big three lead in the market when it comes to these things. And it's not always like when we did, I'm mentioning this point because there was the point like why folks go for the mostly like big three part was because of the, security and reliability, but it's not always reliable, Big cloud providers are not immune to like outages. You can see the 16 hours of Office 365 outage, data center overheating, Cloudflare outage, and if someone uses iRobot vacuum cleaners, anyone here uses? Marino uses. So there was an outage for that as well. Right? Cool. And this is something that this is another thing, never mind. Because we're short on time. So multi-tenancy, multi-tenant cloud basically refers to, your cloud computing architecture. You can have like, which allows basically customers to operate in like a shared environment. Benefits with this model are like, as a cloud like vendor, you can provide increased storage with greater accessibility for a lower price as compared to just a single tenant, right? And it also eliminates the need for individual users to manage the infrastructure. Obviously, there are some of other disadvantages, but so we talk about cost benefits. So it is a little bit cost efficient as an organization who needs to like access multiple cloud providers with a range of products. You can work in a multi-tenant approach compared to working independently with a single vendor. And it can be pretty good for organizations who are growing rapidly, and especially as a provider, simplifying the management and saving time. But yeah, it's basically that. The last one I would like to mention is building a culture. So making a cost as a first-class metric. What do you mean by that? So you can do this by like promoting the idea of cloud cost within the organization, making it easy for everyone to, on the development team to see and understand what are the actual costs. So keeping cost top of the mind on as the decisions are being made. So for example, you can take into consideration like around the cost. You can take into consideration the current the current context and how it can be measured. If there is a clear definition of what is good and what is bad. It's more than just tools. So when we talk about unit cost, for example, so cost per customer thing. So it basically gives an easy answer. Like you can give an easy answer to your like finance teams around a business aspect for a particular cloud usage. And so people don't like when you talk too much tech to them who are not into tech. You tell like, this is what the bill is, this is how much we spent, this is how much this customer is giving, and then you try to talk in the cloud language. They don't really understand. That's not good for them, right? And understand which if you talk about cost per customer, it also helps you understand which customer is like more profitable and who's like least, and explain like why your bills went up or went down. How much time do I have? 2 minutes. All right. How do we do it? You can understand like pod cost, you understand shared cost, and try it all together. So I talked about earlier. So price per unit multiplied by the consumed unit per customer plus pods is equal to the customer cost. Very simple. Nice. Okay. And this is a slide I took from like FinOut. They are a tool for this. So how much does serving X customer cost? So you have the patterns of analyzing the cost for like complex system, split it across subsystems, and can I allocate it to per customer, or there's a metric I can split it by, things like that. There is a lot more that I could go on with. So like cost per feature, how much is it going to cost to build this particular feature? So when we talk about cost in general, there are so many things to talk about. Cost per customer or per segments, per app or per platform. So how much does it take to run this app daily, monthly, or yearly? Are we making money out of this app? Cost per team, for example, how much is each team spending in the cloud, right? And are there any opportunities with the cost sharing part that we mentioned across teams? And we can talk about revenue. Like we can discuss about revenue, like how much is the company making on all these platforms. We already talked about cloud costs, which took quite a while, and cost per unit thing that I mentioned. Time to market, for example, how long does it take to get these products into the market? Cost per cloud service is something we can talk about. How much are we spending on storage or compute databases? Cost of R&D you can talk about. The hours and the technology costs and other deviations and all these other things. So quote I really like by Einstein, genius is making complex ideas simple, not making simple ideas complex. I just put it in that because it relates to cost monitoring thing we discussed today. How much time do I have left? I'm done? All right. And I'm done. Thank you.
Is on. Good. Do you want to say something? No? You're loitering. So we don't unfortunately have any time for questions, but I just want to say thank you to all the speakers today and Kernel. I've been asked to remind you that David's paying for all the beers down at Angel Share. That's right, is it? No, okay. But
yeah. No, it's okay. I'll start here. There is an announcement about the social, but we do have a quick message from one of our sponsors first, and then I'll give you all the details of the social, and then we can all have some food and beer. So there'll be details on that in just a moment. But first, we just have to invite up Philip from Teleport. And we should listen, because Teleport is one of my favorite products. No pressure, but we're all watching.
We're going this side. Hey. So I don't want to keep you too long away from your chance to have a bite to eat and a drink. So just a quick intro into Teleport, the easiest, most secure way to access all of your infrastructure Teleport's an access plane that's zero trust, a certificate-based authentication solution providing just-in-time access to your resources and also providing complete visibility to engineers, for engineers and machines. So we have 5 protocols or products we support. Database access with a range of supported databases, application access, any internally hosted applications you have in your infrastructure, Windows desktop access as an alternative to RDP access, Kubernetes access, and also Linux SSH access. So we're moving away from using VPN for perimeter security, any use of any shared credentials, shared keys for access, and replacing any kind of more cumbersome legacy PAM solutions. And how are we doing that? Using short-lived certificates. So that's what I said, it's a certificate-based solution covering the 4 pillars of access in terms of connectivity, authentication, authorization, and audit. It's role-based access, so people get access to these resources based on their role solely that. They don't get keys to the kingdom, and we control that access with role-based definitions within Teleport. So it's those certificates not only short-lived, they're also kind of scoped to roles. So they'll time out and you're left, there's no zombie credentials left behind that you need to clear up, you know, say when someone is off-boarded from your organization or changes role in your organization. So if you complete session view in terms of audit logs and also session recordings of what users are doing within SSH, you know, Linux or SSH sessions, also KubeHuddle exec sessions. So it's quite a unique feature of Teleport, providing that session recording of KubeHuddle exec sessions. Then supporting access requests where you're elevating privileges of those users. So users-based access is based on the principle of least privilege. They just have access to what they need to do their day job with a certificate that's, you know, 8, 10, 12 hours long, typically to support their working day. But they can request access to more privileged environments, and we support workflows with integration with ChatOps tools to make that approval process far more easier. We're open source, so you can go out, you find us on GitHub, begin using it today, and free to use. And as David had found out and plugged us, you know, that's how he started. So feel free to go there and get using Teleport. And in terms of the organizations already using Teleport, you know, quite some big organizations, you know, worldwide now, with, you know, presence like myself in Europe and growing. And that's really it. So enjoy yourselves tonight, enjoy your dinner, enjoy your drinks. Thank you.
All right. I'll just yell in your face now, sorry. I do use Teleport every single day, so if anyone wants to talk about how I use it, just talk to me in the pub. But now we can all go to the Angels Share. When you leave the EICC, you take a left onto Lothian Road, the main street, walk down to the bottom of Princes Street, and it's just on Charlotte Square. So if you're looking to put it into your map, it's just Angels Share. We're in a private room called the Devil Cut Room, and there will be a buffet and food available from 7, and there will be drinks on arrival. So I hope to see many of you there. I hope to chat about Kubernetes and all things community, and I'll see you all soon. Thank you again.